Assalamualaikum and a very good day, ladies and gentlemen. Welcome back to International Symposium on Biomedical, Biorefinery and Energy Security, I-Bes 2022. My name is Nurhaliza Hamza and I will be your moderator for today. Thank you for squeezing the time to join us through the WebEx meeting, Facebook, and YouTube. Ladies and gentlemen, on behalf of the organizer, I would like to extend my warm welcome to all guests and speakers. Before we begin, I want to highlight a few important points for our event today. Please take a look at your chat box. In the chat box, you may find the guideline for the WebEx meeting of I-Bes 2022 and also the attendance form. Don't forget to fill it in by clicking the link provided in the chat box. Most importantly, you can also find the program book for I-Bes 22 in the link provided. Ladies and gentlemen, for your information, today is the fifth session for I-Bes 2022, which the topic is energy security. This morning will be divided into two subsessions and ended with a forum where question and answer will take place. All presenters are requested to stay on the WebEx platform until the end of the forum. If you have any question about I-Bes 2022, please get in touch with us through the chat box. Without further ado, allow me to introduce our chairman for this session. Associate Professor Engineer Dr. Lim Jian Chun is currently the Product and Services Manager of Process System Engineering Center, Universiti Teknologi Malaysia. His core expertise is in the area of the innovative development and applications of process system engineering techniques for resource conservation and for energy and carbon planning. Dr. Lim has published 56 in Web of Science and 47 Scopus Index article to date. His Scopus H index is currently 25 with 2,917 citations. He is appointed as a member of the International Editorial Board member of Journal of Cleaner Production with impact factor 6.395. He is also being appointed as the guest editor for a special issue of Journal of Cleaner Production and Chemical Engineering Transaction in Scopus Index, apart from serving as the technical secretariat for the international conference. In commercializations, Dr. Lim is the co-founder and director of product and services of UTM spin-off company, Optimal System Engineering Sendirian Berhad. He has filed for 2 patents, 19 copyright, and developed 4 software products. Please welcome Dr. Lim Jian Chun to chair the session.
Okay, thanks. Thanks for the moderator. So please give me a second. I'm going to share the screen. Okay, so are you able to see my screen right now?
Yes.
All right, thanks for the confirmation. So once again, a very good morning to everyone. So this morning, as mentioned by our dear moderator, we are going to divide into two subsessions, but basically it's all about energy security. For the morning session, I think we are happy to have the first session in the morning. We are going to have five speakers from Universiti Teknologi Malaysia and also Universitas Air Langga. So without further ado, let's introduce our first keynote speaker in the morning, which is our keynote speaker number 3, Professor Engineer Dr. Hasinda Hashim. So for your information, Professor Hasinda Hashim is actually a chair of Resource Sustainability Research Alliances, specializing in renewable energy planning optimization, and climate resilience. So she has vast experience as a technical consultant, expert advisor to the authority, industry, and government in energy and climate related area. So she was appointed as a associate editor for Energy Report under Elsevier and also guest editor for Clean Technology and Environmental Policy for Low Carbon Asia Special Issues, along with the Journal of Cleaner Production. So she received a Bachelor of Chemical Engineering and Master of Science in from UTM, Universiti Teknologi Malaysia, and obtained her PhD of Engineering Chemical at the University of Waterloo, Canada. So throughout her career, she received many awards, such as Top Research Scientist Malaysia 2020, the World Top 2% Scientist, China Belt and Road Young Scientist, iChemy Global Awards, the Sustainable Technology Awards by I-Bes, the Best Woman Investor Award in Show International Invention Fair, and Toko Penyerita UTM. This is the recent one, 2021. And she has received many national and international recognition, such as Working Group Member of Hydrogen Economy and Technology Roadmap Development for Malaysia, Nano Malaysia and MGTC, and consultant for the study of variable renewable energy smart microgrid electrical vehicle integration in Southeast Asia region under Asian Center of Energy. He's also the national think tank on the development of the report of state on climate change in Asian region, Japan Asian Cooperation and I-Bes. She's also the consultant for GHG modeling and climate change mitigation for agriculture and land use change under UNDP and GEXA, local expert for the establishment of SDG 7, Iskandar Regional Development Authority, United Nations Economic and Social Commissions for Asia and the Pacific. She was also being awarded for the participant as a fellow under the Asian-Japan Energy Efficiency Partnership Program and technical expert for thermal energy system. And to that, she has supervised more than 29 master students and 48 PhD students. And today we are happy to have Prof. Hasinda here to give us some insight with regard on the title, Has Renewable Energy been an Effective Strategy to Meet Countries' Emission Reduction Target? So without further ado, let's welcome Prof. Hasinda to give a speech on the title today. Prof. Hasinda,
Okay,
over to you.
thank you very much, Dr. Lin Chun, for very long introduction about myself. Okay, let me share my slides. Okay. Okay. All right.
Okay,
Okay, thank you.
I can see the slide right now.
All right. Okay. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Sorry, let me open the video. Okay. Okay. Good morning, everyone. So thank you very much for giving me the opportunity to share with you about our work. Has renewable energy been an effective strategy to meet countries' emission reduction targets? So that's my title for today. So if you look at this slide, so actually it shows that Malaysia are heavily depending on the fossil fuels. About 41% from natural gas, 29% petroleum, 22.3% coal, and the rest is hydro. Okay. So basically, in Malaysia, renewable energy are coming from hydro, biomass, biogas, and solar. And I believe this is also similar with Indonesia, but probably Indonesia you also has geothermal in your country energy mix. Yeah? And sorry. Mm, so So in 2009, this is electricity generation mix. In 2009, about 42.8% is and 40% from coal and natural gas. So it means that the renewable energy share in our electricity generation mix is about so the total is about 16.5%. And out of 16.5, 14.8% is from hydropower, and only 1.7% is from others, means from solar, biomass, and so on. Yeah? Okay, so means renewable energy is a very small amount in our country's energy mix. So, but actually in Malaysia, we have many initiatives. Yeah? You can see there is a lot of national policies in the transition from fossil fuel energy landscape to become more cleaner energy in Malaysia. Yeah? So in fact, in our recent rancangan Malaysia ke-12, actually we also launched Malaysia Renewable Energy Roadmap, okay, up 2021 to 2035 last year. And actually it's also emphasis on the renewable energy. So there is this is shows that actually the countries are very committed in the transitions from fossil fuel energy to become more cleaner energy in the future. Okay. And under Malaysia Renewable Energy Roadmap, actually we are focusing more on four technology pillars. One is solar, second is bioenergy, third is hydro, and new solution and resources. For example, hydrogen. So this is because actually we realize that in Malaysia we have a lot of opportunities to tap um, from renewable energy for meeting electricity demand and to meet um, industrial decarbonization. And in fact, in terms of potentials, you can see from this slide, we have a lot of potential from solar. Yeah? So if you look at Peninsular Malaysia, Sabah and Sarawak, the big bubble is from solar energy, solar PV, yeah? Followed by large hydro, bioenergy, small hydro, and geothermal. Okay, so this is basically to show that actually Malaysia we have a lot of potential. And there are many programs has been introduced in our country to meet ambitious scenario as well as BAU scenario to meet the target. So, for example, large scale solar, we have FIT in tariff initiative. We also have other program like small renewable energy power strap and so on. And because our target is to achieve 40% renewable energy in 2035, that is based on the ambitious target, and based on the scenario is about 32% from renewable energy. And this is just to share with you, among the initiatives that have been implemented to push renewable energy forward. Okay, the first one is CELCO, self-consumption, net energy metering, and large-scale solar, and feed-in tariff. So this is really involve many stakeholders. For example, banker, solar company, ministry, and so on. Okay, to make sure that the program is successful. Okay, now let's move to the what the national commitments toward net zero. Okay? So this is a newspaper cutting to show our Malaysia pledge to reduce greenhouse gas by 45% by 2030 And our Prime Minister also committed to make sure that Malaysia will become a carbon neutral by 2050. Yeah? So based on these inspirations, so we want to see how far we are in Malaysia, how far we are to achieve the target. Okay, for example, in order to achieve 40% emissions reductions, we need to reduce more than 10 metric tons CO2 per year of emissions. Okay, and to deliver net zero power system by 2050, more emission reduction will be needed, leading to more deployment of renewable energy. Okay, so this is to show you the comparison between BAU and new capacity target in order to meet the target of emissions reductions, national emissions reduction target. And in order to meet 45% greenhouse gas reduction target as pledged in Paris Agreement in 2030, current GHG emission intensity need to be reduced by more than 50% from 2020 level. Yeah? So how to achieve that? It's a very huge reduction. Yeah? So now I would like to talk about how the bioenergy can play a role to meet Malaysia carbon neutral targets. So this is basically the info about Malaysia. Yeah? So our area is not as big as Indonesia, and our population is only 32 million, 30 million, and most of our GDP is come from services, so 57% from services, manufacturing about 22.3, agriculture 7.1, mining about the same, and construction and import duties. And actually, potential of biomass or bioenergy is come from the agricultural. Yeah, and if you look at here, yeah, about in 2019, about 106 metric ton per year of agricultural crop was produced. And since Malaysia now is the second largest producer of crude palm oils, about 89.94% of out of the total crop production come from fresh fruit bunch. Yeah? And from there, about it produce about 100 metric ton per year of FFB and yield about 20 metric ton per year of crude palm oil. Yeah? So only less than about 10% is from other types of agriculture. Okay. And another possible source of bioenergy is from livestock. So if you look at this diagram, it shows about 290 million heads of livestock were produced in 2009. And poultry-based livestock, for example, chicken and ducks, accounted for 99% of the total livestock, which equivalent to 57% of the total livestock weight in 2019. So it means that in Malaysia, actually, we are among the highest producer for chickens and ducks. But currently, we're also facing issues of shortage of chickens in the country. And this is just to show you, I think everyone maybe knows, everyone working on biomass, on the energy, knows about the potential of biomass from oil palm tree. So that is huge. For example, in terms of PKS, it's about 0.05 ton of PKS per ton of FFB. In terms of mesocarp fiber, it's about 0.153 ton per ton of FFB and biomass as well. So based on this figure, so it shows that there is a lot of potential in terms of biomass for bioenergy in Malaysia. Yeah. So this is just to show you some calculation in terms of biomass availability. Yeah, based on the plantation area. And we actually can calculate how much the availability of biomass for different types of biomass, for example, from rice, from palm oil, yeah, and so on. Yeah. And this diagram also shows the estimations of livestock availability, yeah, based on the populations of poultry and ruminant for Malaysia. Okay. So, and this is basically to show you the mapping of agricultural residue. Yeah. And based on the assessments for different types of biomass as well as chicken manure, in Malaysia we have about more than 300 terawatt hour per year of energy from biomass and as well as from chicken manure. So this is actually our work. So we actually developed Beware Malaysia in collaboration with EASA from Austria. So we developed national bioenergy modeling. And actually this model also can be used for Indonesia for bioenergy planning. Yeah. So in our model, actually we considered techno-economic and emissions data sets. And we also actually map the locations of availability of all the biomass and electricity substation. We try to network with the natural electricity substation, natural gas grids, population, transport infrastructure, and protected areas. Okay, this is all the spatial data set that we include in our models. And on top of that, we also actually considered temporal data set for feedstock availability, sectoral energy demand, and policy targets. Okay. Okay, I only have 10 minutes. Okay, so this is basically to show the pathway for bioenergy, and actually all this most of the data is available in our publication in 2021 under Applied Energy Journal. Yeah. So this is to show you the comprehensive bioenergy pathway. So basically from the resources from the biomass and the routes and different routes to produce heat for industries, power with and without CCUS, green hydrogen, liquid fuel for road transportation, for aviation, maritime industry. So this is all the possibilities route for from biomass to the products. So if you look at the technology cost and biomass price, so what I would like to highlight here, so this is basically to show the cost of capex, opex, and efficiency for different types of biomass technology. And on the right side is basically to show the biomass price from 2020 to 2050. And this is actually we rank from the lowest price up to the highest price. So, and it shows that actually the palm oil mill effluent, even though it's not biomass, but that is one of the source of renewable energy, it's the cheapest as compared to other types of renewable energy sources. Yeah. And this is basically to show bioenergy deployment in power, heat, and transportation sector for a different policy. For example, if like Malaysia wants to achieve a 35% emission reduction target, this is based on unconditional GHG emissions. So what will be the first technology that will be chosen? And it shows that actually is biogas is the most promising technology. It's followed by co-firing, and then a CHP, and as well as fixed bed boiler. So why the biogas is very minimum here, if you look at the diagram, because there is a limitation in terms of amount of the biogas produced based on the FFFB, based on the palm oil mill effluent generations. And in terms of heat, okay, it shows that CHP is the best technology to produce heat. And for transportation sector, okay, transportation from crude palm oil actually provide the highest share for biofuel as compared to gasification using Fischer-Tropsch synthesis. So it shows that there is a demand in terms of biodiesel from Fischer-Tropsch. However, the price is more expensive. That makes the Fischer-Tropsch become uneconomical. Okay.
So, sorry, Prof.
Yeah.
2 minutes only.
Okay, all right, thank you. And then, okay, this is a comparison, and we want to show the bioenergy deployment for power, heat, and transportation sector. And if you look at the diagram, for the power sector, okay, renewable energy and B20 is the highest share. And why? If you look at the B20, the purple triangle, it becomes the share is become lower. The reason is because in terms of demand is increasing, but in terms of biogas generation actually is not is there is a limitation. So that's the reason why in terms of percentage share it becomes smaller and smaller. And this is basically to show the distribution of bioenergy production by state of Malaysia, and is actually for we actually considered increase of demand. So for 2020 up to 2050, and it shows that actually among the attractive technology is from biodiesel, from and then and also CHP. Okay, so and this is actually to show you the technology location allocation for different policies. So what will be the best technology in order to achieve, for example, 35% emission reduction target, to achieve 20% renewable energy in country mix, 20% for B20 is to represent 20% mix of uh, biodiesels for transportation, and GSG 20 and B20 is a mix of to achieve 35% reduction, and B20 as well, and so on. So based on 2020, it shows that the most promising technology is uh, transifications from crude palm oil and also co-firing. But if you look at different years, different technology will be selected because the demand is increasing, and also the price of the technology is also reduced. So if you look at here, for example, in 2050, fixed bed boiler is also play a role in order to achieve the policy targets, on top of CHP, on top of transportation, and so on. So this is to show the map technology mapping. So before I end, so I would like to highlight, for example, in terms of greenhouse gas reduction, the highest emissions reduction is actually from a mix of policy. For example, to achieve renewable 20% renewable energy target, and as well as a 20% mix of biodiesel in transportation sector. However, if you look at the cost, if you look at the cost, actually, this cost to meet the greenhouse gas commitment is actually come from the transportation sector. It's come from the transportation sector, and actually, it's actually based on the analysis. B20 can even can achieve more than 30% emissions reduction. So the blue one is GHG 35%. This is our target. And if, for example, the government implement B20, it's actually already can achieve more than 35% emissions reduction. So in other words, actually, the government can use this analysis to revise whether 20% is really needed, or we can revise, for example, 10% already enough in order to meet our GHG emission reduction targets. Because other than that, for example, renewable energy is the cost is more expensive, because renewable energy technology is more expensive than to produce the biodiesels. So as a summary, so higher greenhouse gas reduction potential by a mix of renewable energy and biodiesel can be achieved. However, it's more expensive as compared to meet the GHG reduction policy, which is 35% emission reduction target. And up to 30% of annual bioenergy cost reduction is can be achieved using bioenergy. And greenhouse gas avoidance cost is about 22 to 27 USD per ton in 2030, and it will be increased to 30 to 42 USD per ton in 2050 because of the increase of demand. And cost optimal strategy to meet NDC commitment is first, you can scale up the existing technologies because currently we have a limitation in terms of the size of the biogas and biodiesels. Improve bioelectricity production efficiency, for example, biomass CHP. Pursue emerging technologies, for example, advanced biofuel, or probably in the future is green hydrogen, and integrate the biomass and co-firing in co-power plants because this technology is also promising to reduce emissions. I think with that, thank you very much. And I will pass to our MC today, Dr. Lim.
Okay, thank you. Thank you, Prof. Haslinda, for your insightful talk. So I guess we will have more communication on this one during the forum session. Okay. So once again, thank you, Prof. Haslinda. So with that, we would like to welcome our panelist speaker number 5. Okay. For today's session, which is Dr. Lily Jamilato Awalin from Universitas Air. So for your information, she was born in East Java of Indonesia. So she received the Bachelor of Engineering degree in Electrical Engineering in 1999 from the University of Viagama, and Master of Engineering degree in 2004 from the Institut Teknologi Sebelum November, Indonesia, and finally PhD degree in 2014 from University of Malaya. So during her PhD, she was a research assistant in Power System Laboratory, Faculty of Electrical Engineering, University of Malaya. Currently, she's a senior lecturer in Universitas Air, Indonesia. So her research interests include support, location, protection system, distribution, and transmission system. And as a result, she has completed many research projects related to her research area. So for today's session, she will be giving us a talk related to the fault localization on transmission and distribution line. Okay, so without further ado, let's welcome Dr. Lily.
Okay, thank you, Dr. Lee. Is it my voice clear?
Yes, Dr. Lily, please.
Okay, okay. Please allow
You,
me
you,
to share my slide.
okay, sure. You may want to switch on your video as well, the webcam.
Oh, okay. Okay, okay.
Okay,
Is it
thanks. You may want to switch on the full screen mode. Yeah.
okay? Okay. Okay. Bismillahirrahmanirrahim. Thank you very much, Dr. Lee. Assalamualaikum warahmatullahi wabarakatuh for everyone. I'm glad to share with all of you about in this session in the energy security topic for today. So I try to share my field research is about fault location on the transmission and distribution network.
Okay. Dr. Lily, before that, you may want to open out a full presentation mode.
Oh, full presentation, yes.
Yeah.
Okay.
Okay.
Okay, thank
Thanks.
you.
Go ahead. Okay.
Okay. Okay, for today sharing for the content of the presentation is the first is about introduction, overview of the fault location method, and then continue with the voltage seg and current swell characteristic, and then a little bit review of the trigonometric method, impedance based method, and also maybe another method if possible we have more time, and then also example of the tested network, and then the conclusion. Okay, for the introduction, actually if we talk about the energy security, of course we talk is the very large topic. So energy security is related with the energy, and then economy, and then policy. For the energy, maybe we can break down in the energy mix, energy infrastructure, and energy efficiency, energy innovation, and R&D. And then also energy security also relate with the economic part, which is we can discuss also relate with the topic diversification, international prices, investment regimes, and then sustainable development. And then also for the energy security, of course, this one we cannot ignore of the policy of the maybe policy from the government and then from the local also. This one we can also talk about interdependence and then international security, national security, also public policy. So all of three big topic is for sure is relate each other. But now for today's sharing, because this one is very short time, so I will try to discuss about my field is maybe we can break down is very small topic about fault location, which is this one is related with the energy efficiency, of course, because in the practice we cannot ignore that always fault is always occur in the transmission and distribution line. Also, maybe in the we can relate with the renewable energy on grid and so on. Okay, if we go to the fault location topic, so fault location we can cause by environmental factor and also human error. From the environmental factor, we can break down that the causes is maybe caused from the storm, lightning strikes, snow, freezing rain, aging power system component, and so on. If we look at my country, Indonesia, in the distribution and transmission line, is still more for overhead line. So this one is, of course, is very significant effect to the fault causes, because sometimes in the overhead line is maybe for the tree from the accident and so on, from the snow and so on, can make a fault. And then from the human error also can cause the fault. So because as of the fault, if a fault occur in the distribution and then or distribution or transmission line, we cannot ignore that one. So what we can do to reduce the fault occur, we have to immediately identify where is the fault occur, where is the fault point. So this is it's not easy to detect the fault point. So this one also fault also relate with the impact to the reliability index. So many research that already done by researcher, we can classify into conventional technique and then impedance-based method and then traveling wave and high frequency component and then knowledge-based method and hybrid method. For the conventional technique, actually this one is in the real practice, we still need this one. For the conventional technique, maybe a long time ago, customers still call if the fault occur, or maybe if we blackout occur in the distribution. So customer we call, and then okay, in my home or in this company is we don't have electricity. So what happened? We will call if in Indonesia we call PLN, and in Malaysia we call a TNB. Okay, Tenaga Nasional Berhad. If in Indonesia we call Perusahaan Listrik Negara. Okay, so the customer we call, and then the PLN, the crew will come and then observe with the conventional, maybe with the tracing the distribution network. So what happened? This one, of course, very takes time to identify where is the fault point actually. So from this experience, so researcher improve the impedance-based method from the this one is actually impedance-based method first time uh, conduct to solve the fault occur in the transmission line and then improve and improve again in the distribution network. What the why the impedance-based method is the first time is created by to solve the fault happen in the transmission line, because the transmission line, if we know that in the transmission line the characteristics is the long cable without branches. So this one is easily compared to the distribution network, and then the same cable and so on. But however, transmission line is still have so many problem because high voltage and so on. So this one impact to the how we solve the problem by using impedance-based method. So if we compare how this method solve in the transmission and distribution line, of course, we will have a very different error because the characteristic of the two of the transmission of both of the transmission and distribution lines is very different. Okay, and then the third method we can classify as traveling wave and high frequency component. The traveling wave is actually what we call the traveling wave is based on the wave which travel by using injecting the current to the transmission or distribution line. So if the current will meet the point, one of the point, the current will go back to the early point again. So this one is based on the traveling wave. I think if the crew until now is like the crew will check for in the implemented in the practice is still using the traveling wave. And then another method is knowledge-based method, and then hybrid method is the combination between another method. So this one is why we talk about the current voltage sag and current swell. Voltage sag is the suddenly voltage will drop, which drop when the fault occur. So this one is very dangerous to the distribution and transmission line, of course, to the maintenance also. So what for the first time we talk about the fault location, we have to know about the voltage sag and current swell. So if you can see here that if in this example the voltage magnitude is dropped for the voltage EARMS. For the EARMS, this one we have a drop value magnitude, because this one is for the example of the characteristic of the pattern of the voltage when fault occur for the single line to ground fault A only. Okay, so another voltage is a little bit increase. Okay, and then for the current measurement, when the fault occur in the transmission or distribution line, this one is the actually I adapted from the measurement when fault occur in the distribution line, and for the condition for resistance low for resistance. The condition of the current swell, of course, the current is suddenly increase, and then this one very dangerous for the maintenance. So what we have, that's why the reason why we have to identify fault immediately. Okay. However, this condition actually adapted only for the fault resistant for the condition measurement node can detect for that one, but for the condition that the medicine even fault occur, but the measurement node maybe cannot detect also for the condition maybe fault high fault resistant, and then the fault occur in the long distance from the measurement node. Okay. Okay, this one is for example, one of the example of the knowledge-based method, which is go deep again for trigonometric method. So we in this method actually I adapted from my previous research. This one based on our measurement, we have the voltage magnitude from in the per unit, and then phase angle also. We this one all of this one is based on the measurement when the fault occur when we simulate in the PSCAD. So what we can do, based on the value, we can describe as in this trigonometric. Okay, this one is Q is the reflect to the database from the voltage and phase angle, and also P also from the voltage seg magnitude and phase angle also, and fault is we assume as the fault value in the fault point. So based on the trigonometric method, we can describe, we can formulate this formulation. Okay, sorry, my laptop is something like stuck. Sorry. Sorry, I cannot go to the next slide.
Oh,
Very sorry. I will stop sharing first.
yeah,
Sorry.
you may want to do that.
Okay. Sorry. Sorry, doctor, how many time again I have? The time?
Yeah, I think we can actually have another 5 minutes for you, if possible.
Oh, okay. Okay.
Doctor, I will share for you.
Wait, because sorry. Because the monitor is like stuck.
Okay. Nampak balik. Ini bukan ni.
Astagfirullah. Very sorry. Maybe I have to log out from log out the of the my computer.
Doctor, sorry. Can you
So please,
share your slide at the chat box?
because I cannot what this one I cannot escape or whatever.
Oh, meaning that your computer is now hanged?
Yes.
Slide ni tak ada bagi kat kita.
Restart the computer.
Yeah.
I cannot even I cannot control the Webex. Sorry. Maybe I off my computer first. I will go back.
Okay,
Wait.
Doctor. All right. Webex and join lagi. Tu ada dah live tadi. Doctor, Doctor, can you leave Webex then join back? Dr. Lilik? Oh. Okay.
I think probably can get a admin to remove Dr. Lily. Okay. Sorry for the technical errors. So while waiting for Dr. Lily to come back, so in order to make the event smoother, so we would like to suggest to move on to our next speaker first. So for our next speaker is actually Dr. Fazila Muhammad Zawawi from Universiti Teknologi Malaysia. So for your information, Dr. Fazila is a senior lecturer in the Department of Thermofluid, School of Mechanical Engineering, Universiti Teknologi Malaysia. So she is currently a member of the Computational Fluid Mechanics Research Group. She received a Bachelor of Engineering in Mechanical Engineering from Universiti Teknologi Malaysia in 2003, and her Master of Science in Aerospace and Avionics, PhD in Aeronautics from Institut Supérieur d'Aéronautique, Toulouse, France, in 2010 and 14, respectively. So her current research interests include renewable energy-based power generation system, hypersonic boundary layer control, protocraft aeroelastic and fluid structure interaction, drone conceptual design, applied modeling and simulation, and computer-based code development. So as a senior lecturer under the School of Mechanical Engineering, she has taught several courses related to mechanical power generation system, which are turbo machinery, fluid mechanics, and compressible fluid flow. So Dr. Fazila Muhammad Zawabi is currently leading a couple of government-funded prototype project, for example, related to wind energy, So she has also involved in some other government-funded fundamental research projects related to heavy lifting drawn specifically on efficient energy propulsion system. So without further ado, let's welcome Dr. Fadila to give a speech about the highly reliable and efficient horizontal axis wind turbine under Malaysian wind environment. Dr.
Okay.
Fazira?
All right. Thank you. Thank you, Dr. Lim. Okay, let me share my screen. So, can everyone see?
Yep,
Okay.
so
All right.
good. Go ahead.
Okay. Thank you. Okay. Assalamualaikum warahmatullahi wabarakatuh, and good morning, everyone. Okay. First of all, I would like to thank I-Bes 2022 Organizing Committee for this invitation. Okay, basically, what I'll be sharing uh, will be on the topic entitled "A Highly Reliable and Efficient Horizontal Axis Wind Turbine Under Malaysia Wind Environment." Okay, my name is Fazila. I'm from the School of Mechanical Engineering. Okay, basically, what is going to be shared will be more or less related to the ongoing wind turbine project at UTM, funded quite recently by Malaysian higher education. Okay, so in my sharing, I'll be touching a little bit on the energy scenario in Malaysia, the issue with the wind energy generation system when installed in Malaysia and the potential solution to the issue. And maybe I will end my session with the research activities conducted at UTM Wind Turbine Lab. Okay, so I'll be commencing by highlighting the newly announced Malaysian government renewable target in its install capacity. This is basically what have been shared by Prof. Haslinda just now. Okay, this is actually under Malaysian Energy Transition Plan until 2040. So according to the sources, to the source MIDA News, okay, actually in June last year, 2021, Malaysia has set a more ambitious target, okay, for itself in this year 2021, last year 2021, to achieve a higher penetration of renewable energy in the Malaysian power capacity mix, which is 31% by 2021 compared to the previous one that was only 20%. Similarly, by 2025, and further a more higher target, which is 40% in 2035. So according to this energy transition plan, the government will focus in the effort to increase renewable energy as it accounts for 80% of the country's electricity demand, as well as to ensure the sustainability of energy supply. Okay, and this is basically to show the penetration of solar and wind energy in Malaysia compared to that in the top 10 countries in the world, Denmark, Uruguay, Germany, and so on. So where we can see that Malaysia has only 33.5%. Okay, that the share the share percentage of total generation, okay, to date, and where it's coming from the renewable energy sources compared to the total generation mix, which mostly is provided by solar PV. So basically, the current energy mix for Malaysia power generation is mainly provided by natural gas and coal, and in which country like US, European Union, like Japan, China, Brazil, um, have already started to phasing out fossil fuel energy based energy generation and replacing with renewable energy sources. And therefore, I think due to this fact, why the cost-effective renewable energy-based power generation system, specifically in Malaysia and Indonesia, okay, is essential and has to be worked on to make the economy country model a reality. So basically, these are the types of renewable energy which currently, the recognized source of renewable energy in Malaysia. So they are biogas, biomass, small hydropower, and solar PV. So unlike this four renewable energy type, wind energy has yet to be approved as a source of the nation renewable energy. So the government has begun to be looking into the potential of wind energy as one of the eligible and reliable energy for generation electricity in Malaysia. So SEDA basically it is stand for Sustainable Energy Development Authority. Okay, is the regulatory agency who is responsible for the development of the regulatory framework for wind energy in Malaysia. So, and they are still assessing the potentiality of wind energy. So these are the measuring the measuring parameter that they use in the potentiality assessment and condition requirement to let the technology and employing the wind energy workable and reliable. Okay, they are capacity factor, CF, annual energy production, AEP. Okay, and another one they use turbine performance index, TPI. So we'll be looking in the next slide how and what will be the potential mean or solution in terms of like technology that could fulfill the requirement set by SEDA, which later could be contributing way or factor to the development of wind energy in Malaysia. So here are amongst the wind energy among the wind turbine installed in Malaysia. Okay, wind energy potentiality study. Okay, so first we have 150 kilowatt of wind turbine at Pulau Terumbu Layang-Layang, Sabah. So this was actually the very first commercial wind turbine in Malaysia installed by Tenaga Nasional Berhad, TNB, the National Utility Companies in 2005. Okay, basically this was initially to power up the TLDM, Tentera Laut Diraja Malaysia, and resort at the surrounding. So why it was installed is due to the fact that from the wind energy potentiality study conducted that actually this island possesses the greatest wind energy potential compared to other places in Malaysia. So the second one that we have is 100 kilowatt of wind turbine at Pulau Perhentian Island, Terengganu, somewhere in East Coast Malaysia. Okay, just observe the figure at the right. Okay, with two turbines. Okay, this one, and the system has a solar power capacity of generator that can support 200 kilowatt of power. So, however, findings showed that it was not convincing enough for wind energy to be successfully generated there, and moreover, it has been reported that the turbine has stopped working due to some issues, which is not revealed actually. So I'll be sharing you a possible factor contributing to this wind turbine of not producing acceptable power generation or wind power capturing performance. Okay, next we have 3 kilowatt to 25 kilowatt of wind turbine at Kudat, Kuching, Kuala Perlis, and Terengganu. Of course, the result never been published. And the last one we have is 3 kilowatt of wind turbine in Setiu, Terengganu, conducted by UMT, Universiti Malaysia Terengganu. Okay, basically the application was to supply electricity to help a shrimp farm industry at the time. So in reducing the high operation cost. So basically all the wind turbine installed were for educational and research purpose. Okay, only as the government still assessing to determine the wind energy potential as one of the nation renewable energy. So basically all for study will all turbine for all these studies project were bought from abroad. Okay, so they are basically having the same issue in terms of their capability to produce expected power. So of course, yes, it comes actually. The issue comes behind all of this renewable energy. Wind power generation for Malaysia in this is about the low wind available wind speed. Okay, so where the commercial imported wind turbine could not generate good performance or even acceptable performance, and in some worse case, even they cannot even generate any power. So why that happened is due to the fact that they are the system is designed at rated wind speed of at least 15 meter per second, which is not or even far than the received wind in Malaysia. So the power produced in this case is not economical, sensible. The cost to pay is too high compared to the amount power it can generate and cost to a nonsense of figure of return of investment. So in this case, so from here it could be said that the application market and business of commercial wind turbine, especially when compared to other sources of renewable energy such as solar, becomes not practical in Malaysia. So I just would like to show you here actually the comparison that state the issue just now. So the example case of that is the wind turbine installed at Pulau Perhentian, in which the system was designed for rated 100 kilowatt, yet the power that can be produced is only 9 kilowatt per turbine. So basically this is the power that can be generated when it is operating under wind speed of 7 meter per second, which I could say that it's quite high wind speed relatively. So how we solve this issue basically? So we really need to do to ensure that the wind energy could be reliable in generating power. So which led to convince the government to include the wind energy as one of renewable energy. Nation's renewable energy. So is that the wind turbine system that not only functional but also very efficient under low wind speed environment to harness the untapped potential wind power in Malaysia. So of course, yes, many of us know that wind turbine install in Malaysia has a very bad reputation on their capability and reliability because of I think that have been mentioned earlier just now, not only due to the low wind speed contributing factor, but it is also due to the design, the matching system between the mechanical power generation system and power conversion system. Okay, so all right, I think so maybe I could end my talk with the research activities involved at our at UTM wind turbine laboratory. So so this is the lab. The research work covers the aerodynamic and structure wind turbine blade design. This is to comply the standard IEC 61400 wind turbine design requirement part 1. We also actually cover the experimental validation, numerical simulation work, analytical optimal design. We also we also fabricate the blade for testing under the SID standard just now. So this is the test setup and the rig. So this is the blade spar design and analysis. We are performing finite element modeling and simulation on composite blade. So we also cover the generator house fabrication, okay, functional test and verification, okay, verification testing on integrated control system with power generation unit. We also conduct a calibration and integration of sensor and communication with control system, power generation, conversion and charging circuit testing. Also on the integration of control system with power generation unit, on optimization work on a well-matched integrated wind turbine system, combination of mechanical power generation system and conversion system. Okay, according to that. So this is just to share that we are under validation stage in TRL, technology readiness level 7 in this project, okay, which is demonstration system of 30 kilowatt wind power generation system, okay, to be installed at Desaru Coast. Okay, this is more or less the size of the wind turbine that's going to be installed. And I think as conclusion, yes, I think wind is potential to generate power in Malaysia. So the imported commercial available wind turbine doesn't work. Okay, so what we do is we redesign the blade to perform well in our wind environment, and of course with the localization of wind turbine system production, the cost per kilowatt hour power generated become much reduced. And I think okay, that's it from me. Thank you.
Okay, thank you. Thank you, Dr. Fazira, for your insightful talk. So we will have more questions for you during the forum session.
Okay.
All right. So once again, thank you. So with that, I would like to inform there's actually a little bit change of our schedule. So for our next speaker, it will be actually Dr. Satya Pama. Let me show on the screen on the presenter mode. Okay, so the initial schedule is actually we're going to have Dr. Henry, but unfortunately, due to some technical error, so we would like to invite Dr. Satya Pama first to be the next speaker. So, and for your information, for the following session, we will be actually combined with the session in the next part. So we will be actually having one following session instead of having two. So we will do it at the last of the event, okay, after our last speaker. So let me give some brief introduction about Dr. Satyabhama. So just give me a moment. So for your information, technologist Dr. Satyabhama, she is actually currently the director of UTM Ocean Thermal Energy Center and a senior lecturer in Razak Faculty of Technology and Informatics, Universiti Teknologi Malaysia, and she is registered with Board of Engineers Malaysia, BM, and Board IEM, IEEE, IET, and Energy Institute of UK and Malaysia. Currently, she is focused on ocean thermal energy conversion and its efficient technology to tackle sustainable development goals and 2050 decarbonization action plans with oil and gas industries. In addition, she is the project manager for Satrex Tech project, and she received her PhD in electronics engineering, focusing on steam firm solar cell from Waseda University of Japan in 2015. She possessed vast experience in the development and application of efficient materials for solar cells photovoltaic system. Upon joining UTM, she has been actively involved in the STEM education initiative and program as part of her university social responsibilities. Above all, for the past 18 years, Dr. Satya has involved herself in design, development, analysis, lead trainer, and managing of various electrical and electronics testers, telecommunications, and renewable energy industry in and out of Malaysia. And today, we are happy to have her to give us some insight with regards the OTEC technology as a marine renewable energy in APEC region. So, Dr. Satya.
Thank you very much, Dr. Lim.
Okay.
Allow me to share my screen.
Yep.
You can see my screen, yeah?
You may want to
Okay,
put
a
on the
very good
full screen.
morning. Yeah, a very good morning to the moderator, the chairperson, and also Prof. Haslinda is here, and all the other participants. It's a great pleasure for me to be here and presenting and talking about ocean thermal energy conversion. Okay, as highlighted and mentioned by Dr. Lim just now. So the topic for today is ocean thermal energy conversion, OTEC technology, as a marine renewable energy in Asia Pacific. We often talk about in Malaysia in particular, but since we are having our friends from Indonesia, we would like to see, in a broader picture. So that's why, the title is like this for APEC. Yeah? And here the research members of our team, the bigger team that we have from Malaysia and also from the Japanese collaborators. As highlighted just now, yeah, I'm from UTM Ocean Thermal Energy Center, that's here in UTM KL campus. Okay, the outline of my talk. First, let us have a look at what is the marine. What are the technologies that's classified as marine renewable energies by the IEA and so on. Then talking a bit about OTEC and the HOTEC, an advanced OTEC system that we are working on currently. The OTEC potential in Malaysia, which also covers a little bit about APEC and also the around the equator. And commercial OTEC plant, 10 megawatt. So how can we visualize that, concept and theory and the way forward? So this is to highlight the marine renewable energies under the OES, as you can see, OES, Ocean Energy Systems, which is actually a technology collaboration program by IEA under the United Nations. So they have define and classify as the image here. It shows the ocean, you see. So ocean has to be the medium of the generation. So that's what we call as the marine renewable energy. And we have tidal and current in that, under the marine renewable energies. And we have ocean thermal energy, which we are going to discuss further today. And we have salinity gradient and the waves. Okay, some parts of the world, the potential are there. So that's what we want to look at. What are the potential near the equator, as I highlighted just now in Malaysia and Indonesia in particular, because the members are, audience are in such countries. So there, what is the potential that's already there? So that being said, we look at the OTEC demo plants that's already existing in the world. So in 2013, there's been this, they've designed and developed the 100 kilowatt of OTEC plant. It's an online at the shore. So online plant or inland plant, we can say online or inland plant, 100 kilowatt in Okinawa, Japan. Then followed by in 2015, also you can see it's an online plant in Hawaii, 105 kilowatt. Here, the engineering or the technology provider is Genesis, and on the other hand, in Hawaii, it's called the Makai Engineering. Then, 2021, we have a floating OTEC plant, 1 megawatt, which is the capacity built for 1 megawatt by the Koreans, the CRISO, the Korean institution. And in of the Korean the ocean there, they have validated and confirmed to generate this of floating type up to 400 kilowatt. Okay, and the project is to bring this floating 1 megawatt to the Kiribati in the Polynesia, Micronesian islands there, and to confirm. But due to the pandemic, there has been some delay. I'm not sure yet, but today I think we haven't heard from the Koreans yet. This 1 megawatt is not been confirmed yet because they need to bring to the Kiribati. Okay, So these are some of the plants that's available. Some of the studies that's going on, particularly on the OTEC, is the CTCN, which is the Climate Technology Center and Network, the Ocean Energy Technical Pre-Feasibility Study. And this is also by the Japanese Tokyo Electric Power in Nauru. Nauru is also another island somewhere near the Polynesian, Micronesian in the Pacific. Then that being said, um, the, the Okinawa plant from the 100 kilowatt, they have already experienced and enjoyed all the benefits. So that in a pipeline, they are planning for a 1 megawatt OTEC plant. Okay, so this is being confirmed by the Global Ocean Resource and Energy Association Institute and supported the funding by the Ministry of Defense support towards securing budget for the installation of deep ocean water intake facility in the Kumejima Island itself. So Okinawa, where specific is the Kumejima Island. So they are doing the study and the budgeted for 1 megawatt anywhere, anytime near the future. Now we look at the OTEC closed cycle. So having this OTEC closed cycle, which it provides a stable power supply, which is 24 by 7, it is really one of the technology that can combat the carbon neutrality and the pledge that majority of the oil and gas companies have pledged for. So how does the principle work? It uses the surface seawater, which is between 28 to 30 degrees C, which goes into the evaporator and evaporates or change the phase of the working fluid in the system. To date, the most efficient working fluid has been ammonia. So in this system, the closed cycle, ammonia being the working fluid, gets the heat from the surface seawater and changes phase into vapor. And that vapor passes through the turbine and turns the turbine, and when it's connected to the generator, it generates electricity. So that vapor, the working fluid just now, comes back to the other side of the system, whereby it's known as the condenser. It's also a heat exchanger. So the condenser then condenses the working fluid back to liquid phase. So how can a condenser make the working fluid to change from a vapor to a liquid is by having condensation process, and it uses the deep ocean water. You can see here roughly, but 1 kilometers, 1,000 meters depth. We get about 5 degrees C, of seawater, which we use to condense the working fluid. And as I mentioned earlier, the most efficient working fluid has been ammonia. So this is the closed cycle, the principle of the closed cycle OTEC. So this system here, it goes in circle, yeah, whereby it changes phase to vapor, then to liquid, and back and forth. Yeah. That's how the system produces or generates electricity, which you and I use for any other purpose of commodity and so on. All right, next we saw that OTEC can generate electricity. Okay, other than that, OTEC and its spin-off industries to sustain an OTEC system or a plant. So an OTEC plant combats energy issues that we have already seen just now, yeah, with the principles of the closed cycle. Yeah. It also provides access to clean water, food supplies, rare earth mining, SWAC, which is seawater air conditioning. One of the example could be data center cooling, and many more to explore. Right, so this being a floating type OTEC or an online, so it uses the surface seawater and the deep ocean waters. So then the OTEC from the discharge that's out from the surface and the deep ocean waters, we can use it for others, such as mentioned here, reuse of the deep ocean waters, as highlighted here, for aquaculture and so on. That being said, having a bigger picture of what an OTEC plant can produce electricity, can produce water, desalinated water, and also for aquaculture and other benefits. This is another model, the Kumejima model in Japan, whereby it provides a sustainable local community of for by providing the energy, water, and food. So having one OTEC plant, of course, this is a demo plant, we call it, because it's only 100 kilowatt uh, demo plant. We can have vegetables, agriculture, desalination water, seaweed aquaculture, coral nursery, yeah, which protects the environment and so on, and oyster, yeah, the kuruma shrimp or the prawns, shrimps, the sea grapes is aquaculture, for cosmetic industries, and hot bath for tourism, yeah, and so on. One of it, the swag, the seawater, air conditioning also part of it. So currently we are having this research project under the Science and Technology Research Partnership for Sustainable Development Success Program, which it is sponsored by JICA, JST, and the Ministry of Higher Education Malaysia, and many industry partners and universities are in this project. And we focus on the hybrid OTEC, which is the HOTEC, which we call it HOTEC, which is the H stands for hybrid OTEC. And when you look at the conventional and the closed cycle that is highlighted just now, the novelty here in the HOTEC is the production of the electricity and the production of the desalinated water, whereby the closed cycle produces the electricity or generates the electricity, and the open cycle on the left-hand side here produces desalinated water. So this is the technology novelty, and it's going to be the most advanced OTEC system in the world. Okay, can't see my. I hope you are able to see my screen. Yeah, let me know if you can't. Okay.
I can see.
All right, thank you, Italy. So hybrid OTEC, just a little bit more. This is a 5 years project, and as of now, the HOTEC is already been designed and developed, and we did a test also, a partial test run in Japan last year. So, as I've highlighted here, designed and developed by IOES Saga University and the engineering companies and NCS Incorporation. So, moving forward, due to the pandemic, there has been some delay in the project. However, this year we are expecting this system, HOTEC, to be here in Podixon, Telok Kumang, whereby we'll be doing the test and technical evaluation using the surface seawater of Telok Kumang, Podixon. So now we look at the Malaysian context, whereby the energy-related bodies in Malaysia. So under the Ministry of Energy and Natural Resources, we have, of course, the federal statutory bodies, the EC, Energy Commission, and Sustainable Energy Development Authority, SEDA. Yeah. On the other hand, of course, power generation company, the main one is the Tenaga Nasional Berhad, and in Sarawak, Sarawak Electricity Supply Corporation, and in Sabah, Sabah Electricity, and the ONG, the National ONG Company, Petroleum National Malaysia, which is Petronas, and other energy providers such as YTL Power, Genting Semi Malakoff, Edra Global, and many other smaller players though. Okay, so that being said, renewable energies in Malaysia highlighted and picked up the report by SEDA, which was also highlighted by other researchers just now. So Malaysia Renewable Energy Roadmap, the MyRER by SEDA, a highlight is that I want to say here is the E in the SEDA is not electricity and it's for energy. So keeping that in our mind, bearing that in our mind, renewable energy to date in Malaysia, majority the report talks about hydro, solar PV, biomass, and biogas. Of course, OTEC is not included, but after this, I would like to show you in context of our potential our geographical situation where we are in the equator. So we need to propose, would like to propose to include OTEC in the energy mix, especially now. Why? Because we have pledged for the carbon neutrality, carbon net zero, and so on. Majority by the ONG, oil and gas, and other Malaysian government. Yeah. So if we are really we really want to achieve. So from this report we can see that the peak consumption and the installed capacity is highlighted in the graph here. The solution that we need to provide, which needs to include OTEC and other potentials in order for us to reach this new capacity target by 2035, which is about 40% of renewable energy share. As highlighted by Prof. Haslinda, we are at very small percentage, only 1-digit percentage of renewable energy. But if we want to achieve this capacity, the installed capacity, we have to really work towards it by implementing new technologies such as OTEC. Yeah? And besides that, I would like to also highlight in the equators, the wind potential in the world. And this shows the wind potential in the world. And we understood from previous lectures, researchers saying that we have very limited wind in this equator, this area, which is the equator, right? So as we are all aware, the maximum or the highest potential for wind is always the north and the south. Yeah. So that being said, we really need to rethink and unthink the energy mix that we are proposing, and where should the potential be placed by the government and also the private companies. Yeah. So this is highlighted here by the map, the global map, and taken from this footer here that's been highlighted, the citation here. So in Malaysia, a typical wind turbine, if we are going to have, we roughly have about average or about 5 meter per second from this potential, the map that's highlighted here. We are somewhere here, between 5 meter per second, which was clearly highlighted by the researcher earlier. So what is the conventional or typical wind turbine power output, at least it requires about 14 meter per second. Of course, new ideas and innovative ideas are required in order to bring a wind turbine into Malaysia and our area here in this part of the world. So that can be done, of course. But when we look at what are the available potential, so we really need to think very hard and very well in order to propose the energy mix to the government and also the private sectors. So talking about the RER just now, the wind in Malaysia from this report, it clearly says what it's about 5 meter per sec, and where are the areas that we have here in Sabah is in Kudat, right? So some questions I put forward. Low speed wind turbine can be an innovative idea to tackle wind in Malaysia. But what is the larger the installed capacity that we can go? So we are very clear that we have wind about at an average of 5 meter per sec. So what's the capacity of the wind that are we looking at? Are we looking at 1 megawatt or 10 megawatt scale, or smaller than that? Mini or micro wind turbine might be a potential in Malaysia. I don't want to deny that. But when we want to have larger scale, so different technology is required. So that being said, so this is the potential for OTEC, worldwide potential for ocean thermal energy driven for energy, water, and food supply. And you can see clearly the equator that I've been saying since just now is where the sun energy is being stored. So the potential for OTEC is in the equator near here. So Indonesia is here and Malaysia is here. So we have a huge potential. You can see slight potential here in Japan. That's why at the southern part of Japan, which is the Okinawa and Komechi. And Korea, for your information, they don't really have it here. That's why they are bringing the 1 megawatt to this area. the Micronesia, Polynesia. So that being said, OTEC potential in Malaysia, we have great potential in Sabah. Yeah, the depth of the desired or required deep sea water is about 1,000 meters or less than that. Approximately 600, 700, we can get deep sea water at 5 degrees C. So, which makes it a potential site. Yeah? Total OTEC potential area in dark blue here, approximately 92,000 square kilometers, and the power is 12 gigawatts that can be. It's a rough estimation, underestimated though. So we are in good hands for OTEC in Malaysia. And this is in a paper highlighted here. And temperature and other profiles of the Tawau, Simpadan, Kalumpang, Layang-Layang, and Pangi has been highlighted here in this graph, temperature and depth, whereby the surface seawater at 27 degrees C, deep sea water at the 600 meters, we get 7 degrees C, which is sufficient to have the 20 degrees C of temperature difference. Salinity and the dissolved oxygen and the water mass shows a profound characteristics for water. This is for commercial OTEC plant, a 10 megawatt. It's highlighted here very quickly. I think I'm running out of time. So with 10 megawatt, we can get a net power of 8.6 megawatt. Why? The remaining is for the pumping power. So, and all these are free. Yeah, the flow rate of the water, both approximately same. Similar, the deep sea water and the surface sea water comes to about 4.5, 10 to the power of 7 kilogram per hour. So the cold deep sea pipe length about approximately 800 meters, seawater pipe diameter with 5 meters. Yeah, the floating type OTEC plant is what we are proposing for a 10 megawatt to be placed in Sabah. Yeah. So commercial OTEC plant, 10 megawatt, 100 megawatt OTEC plant production of green hydrogen and green ammonia. So this is a visual by Lockheed Martin actually about 10, 12 years ago. So it yet to materialize in the world. But this is the idea that we put forward to the Petronas and also oil and gas companies, whereby they already have the offshore plants and so on, like this. Yeah. So this is an article, a few more slides we need to go. Petronas Eneos MOU to explore the green hydrogen production. We talk about the hydrogen, yeah. Now we have in the market the gray hydrogen and the blue hydrogen. We are talking about the green hydrogen. Why? Because we want to tackle the carbon neutrality and the carbon net zero. In order to do that, yeah, what is in the pipeline of the supply chain? This is an overall an article last year, September. We can see wind here and solar, renewable energy, but we would like to propose the on-land or offshore of OTEC to be in place, especially we are in the equator, so in Malaysia and Indonesia, we have OTEC. So in order to produce the hydrogen, which is the energy carrier, hydrogen is not the energy itself. Hydrogen is the energy carrier. That being said, by MIDA also, Petronas, Samsung, with the Koreans also, some development on clean hydrogen supply chain is going on. So in order to produce, what is the energy that you use to produce the hydrogen? That is what we are proposing to be OTEC, because you can get a huge capacity, 10 megawatt, 100 megawatt. Now, hydrogen has been discussed by so many researchers, the government and industries and so on. So hydrogen production in ASEAN by 2040 is really going to be very, very high. And if you can see the countries highlighted here, okay, I did highlight Malaysia, but in Indonesia, they are, using the renewable energies is really very high. Yeah? So the y-axis here shows the unit in million ton of oil equivalent, so 140. Million ton oil equivalent. So it's really huge. So by 2020, in order to achieve this, we need to have a solid technology or a system to produce the green hydrogen. So that being said, I think we need to incorporate renewable energy in the energy mix with OTEC. It's very, very important. Okay. The way forward, that we would like to highlight, OTEC in Malaysia and Asia Pacific, is to have viable business model to sustain the OTEC commercial plant. And UTM and also Universitas Air Langga, being the academia, so OTEC technology for educational and talent development is something that's very, very important for us. And firm policy to sustain OTEC technology is vital. Yeah? So OTEC to engineer a better world. That's our tagline, and I would like to the takeaway message here. All right, with that, thank you very much.
Okay, thank you very much. Thank you very much to Dr. Satya. So we will be seeing you in the forum session later. So thanks again for your insightful sharing in OTEC. Okay, so with that, we would like to move on to our next speaker. So let me share on the screen.
Very sorry, Dr. Lim.
Yeah, are you able to see my screen?
Yes, very sorry. I'm Lily. Previously, I still not
Yeah,
finish
sure.
my
Later we will
presentation.
allocate you a
Okay.
session.
Okay, thank you.
Okay, thanks. Okay, so our next speaker will be Dr. Amrila from Universiti Air. So for your information, Dr. Tata Amrila earned his PhD at the National Chiang Tung University, Taiwan, followed by an internship program at Max Planck Institute of Chemical Physics of Solids, Germany, and continued by postdoctoral appointment at Advanced Institute for Material Research at Kobe Center, Tohoku University, Japan. He's currently a lecturer at Universitas Air, Indonesia, joined in 2009. So his area of interest include the fabrication of nano-sized material, the properties of oxides and carbogenic compounds, and the study of how small size affect the exotic phenomena and functionality of thin films and nanocrystal. So today, Dr. Tata is going to share with us some insight related to the new material of rock salt type epitaxial thin film as a heavy rare earth monoxide ferromagnetic semiconductor with a high Curie temperature. Dr. Tata? Are you ready?
I'm sorry. Okay, I'm ready.
Yeah.
Yes, I'm sorry. Okay. Shall I start the?
Yeah. You may want to share open
Okay.
your webcam first.
Okay, I would like to share. Here is the PowerPoint.
Yeah.
I'm sorry for the delay because I'm still talking with my son.
No worry. How about
Okay.
your webcam? Would you like to switch on your webcam?
Oh, webcam. Okay, sure. Okay. So
Okay.
my voice is clear, right?
Yeah, you may want to switch on to the full presentation mode.
Presentation mode. Okay. Okay. So can you see my slide now?
Oh, good. Go ahead, Dr. Tata.
Okay. Thank you very much. Okay. Now I would like to first of all I would like to thanks to the committee of the I-Bes. I think I-Bes. I mean, it's my honor to join in this conference and to gain some collaboration later with the researcher from UTM. And I'm Tata Amrila, the lecturer in the Universitas Air in the nanotechnology department. And then in here, I would like to discuss more about nanotechnology. I think, in my opinion, that this is a very interesting for me. And then I think that what I did, my research hopefully can mix with you guys, and then we can gain some collaboration, something like that. Okay, actually, I'm just 2 years in the Airlangga, and then I did not yet start in my own project in Universitas Airlangga. But last year, I just came back from Japan, finishing my postdoctoral program in the Tokyo University, and this is my work during 2 years I stay in Tokyo University. And I think it would be very nice to discuss my work in Tokyo University about the new kind of material, namely holmium monoxide. This holmium monoxide is only found in the gaseous phase so far. And then we try to make holmium monoxide into some thin film, like a solid film, and then hopefully we also can use this holmium monoxide for some application, including for energy-related application. Okay. If we talk about the energy-related application, we also talking about nanotechnology actually. Most of development of energy related application, for example, like a solar cell or photovoltaic, there are a lot of development now. I think Malaysia also famous with some research with the photovoltaic or solar cell. Not only now, not only solar cell made from silicon, right? The photovoltaic also developed into some made from perovskite material, and then copper-based material, or CIGS or CZTS, something like that. Well, all of the development of the solar cell take some advantage of, namely photoelectric effect from some nanomaterial. And then mostly there are combination of the two kind of semiconductor material to obtain some photoelectric property, photoelectric effect that to generate or to convert the sunlight into some electricity. And again, if we talk about photoelectric, we may also talking about the photo or electrocatalyst, or we also talk or in combination between photo and electrocatalyst, called the PEC. Because by using this kind of technology, we can convert water into hydrogen fuel. And then we also, if we talk about the electrocatalyst or for some catalysis properties of catalysis process in some nanomaterial, we're also talking about some application, namely supercapacitor or battery. And there are a lot of development of nanomaterial to obtain some new kind or type of the battery or supercapacitor having very excellent properties, or high capacity or something like that. And then if we talk about battery and supercapacitor, the process, there are some heat transfer, and actually we also can use that heat transfer to generate some energy to make some generator, something like that, to convert heat into some mechanical, and then to generate some electricity. And then we also, if we talk about the generator, there are also some scheme, namely nano generator, that take advantage of the piezoelectric properties of some nanomaterial, and then we can make some nano generator, something like that. So what I talking here is all of this kind technology, energy related technology, is connected each other, and then we can make, or we can realize this technology by using nanomaterial, and then a lot of kind of nanomaterial that can be used to generate or to produce this kind of technology. For example, like a TMD, carbon oxide, MCN. I think the MCN is a very famous material nowadays in the past 5 years, because MCN can be used for most of this kind of technology. And there are also some perovskite. You know, perovskite material now exhibit higher efficiency, solar cell efficiency compared than silicon. But unfortunately, because perovskite is not stable as a silicon-based solar cell. But all of this kind of material can be used to make some energy, technology-related energy in, as I said before. It's because I just have, I don't know, 10 or 20 minutes here. So I probably will discuss much about chalcogenide. And I think you, most of you now in here know about the chalcogenide. There are the chalcogenide is the compound that that contains some chalcogenide element, for example, like oxygen, sulfur, selenite, tellurium, bismuth, and etc. And then there are also a lot of chalcogenide compound. There are some two-dimensional chalcogenide or dichalcogenide, and there are some metal chalcogenide. Metal chalcogenide is combination between some metal element with chalcogenide element like molybdenum selenide, molybdenum sulfur or tin sulfur, and there are also antimony sulfur, and there are a lot of chalcogenide, metal chalcogenide. And then that metal chalcogenide can be used for many applications. And then in the past few years, probably 10, 15 years, there are also some development of chalcogenide compound by using rare earth element. And it was found that the combination of rare earth element with chalcogenide element, we can obtain powerful properties. And and then we can use this rare earth-based chalcogenide for many applications. And for example, like optoelectronic, electronic, and including for solar cell that I will discuss later. And most of chalcogenide compound, oh sorry, this is my son. Yeah, most of chalcogenide compound is a semiconductor, and then most of semiconductor did not possess ferromagnetic properties. We can obtain the semiconductor properties when we dope some semiconductor with a magnetic element, or we can make some chalcogenide with magnetic element, for example, like iron, cobalt, or probably some of magnetic element, magnetic element, for example, like europium, chromium, like a gadolinium, to obtain some ferromagnetic semiconductor. And obviously, as for rare earth monoxide, for ferromagnetic semiconductor, it's very difficult to synthesize. It's because the JIP energy of the most of the rare earth have a very large negative JIP's energy, which means that they are mostly found in the gaseous phase. And then my advisor in Japan, in Tokyo University, tried to condense them, try to make them into some solid phase, and then hopefully we can use that the magnetic ferromagnetic semiconductor based rare earth oxide, rare earth chalcogenide for some application. And in here, I try to make holmium monoxide. As I said, that holmium monoxide is a new kind of material only found in the gaseous phase, and then we can combine holmium element. Holmium element is very large magnetic properties, and then this, I think, the largest element having magnetic behavior, and then we combine them with some of oxygen atom to make some holmium monoxide. And then this kind of holmium monoxide have three kind of magnetic mechanism. There are some direct magnetic mechanism, AKKY magnetic mechanism, and then super exchange magnetic mechanism. And then how to make this? How to make holmium monoxide? We use some, namely pulse laser deposition. we use some target here. This is the precursor. We use holmium 203 instead of holmium monoxide. Holmium 203. We can obtain very easy, right? And then we want to transform this holmium 203 into only holmium monoxide by using the pulse laser deposition. And by ablating the target, ablating the holmium 203 with some oxygen gas, and then we control the environment with the very large the pressure, we can obtain some holmium monoxide in film. And then this is the substrate. So I mean, there are some plume here come out from the holmium 203 target, and then we can just only holmium monoxide binding with the substrate so that we can obtain thin film holmium monoxide thin film. Yeah. And then luckily, after 200, more than 200 samples, I guess, 400, 400 samples, we obtained holmium monoxide phase by using several measurement. Here, I just only showed you the XRD. We found that some holmium monoxide phase in here, and then, but unfortunately, we cannot avoid the holmium 203 as impurity. But yeah, we are very happy that we can obtain holmium monoxide in here by using several measurement characterization. We believe that our sample is holmium monoxide, including by using the XRD. We can see there are some peak of the holmium monoxide, and then from the RSM also we also find some holmium monoxide peak here, which means that we have successfully grow some holmium monoxide. And by using other measurement, for example, like UVs and then PPMS, we also can found the holmium monoxide having semiconductor properties, but they are very narrow band gap. Okay, very narrow band gap. The band gap is about 0.11 electron volt, close to the metal actually, but as long as that we still have some band gap, we can call this holmium monoxide as a semiconductor or probably semi-metal. And then by using the PPMS, we determine the resistivity, and then the resistivity of holmium monoxide through the variation of temperature. We also can see that the holmium monoxide have the characteristic of some semiconductor. Okay, and then we believe that we have successfully grown new kind of type semiconductor, namely holmium monoxide. And then the good thing that the holmium monoxide, after we try some magnetic measurement, a lot of magnetic measurement, including many kind of magnetic measurement, we claim that the holmium monoxide have strong ferromagnetic properties, of course, because of the magnetic element of the holmium. And the good thing is holmium monoxide have a large TC. Yeah, it's about 130, and then the TC of the holmium monoxide is the most largest TC in compared than the holmium mono chalcogenide, others holmium mono chalcogenide. Before holmium monoxide, there are some report of the holmium mono chalcogenide, others holmium chalcogenide, for example, like holmium sulfur, holmium selenide, holmium telluride, or holmium pentatide, for example, like holmium nitride, holmium sulfur, phosphor, and etc. And as we see that here, the TC of the holmium monoxide is larger compared than others. Yeah. And then this is a good thing that probably we can also dope the holmium monoxide with some smaller element to enhance the TC of the holmium monoxide into room temperature probably, and then we can use this holmium monoxide in we can realize some holmium monoxide into some application. One of application of monoxide is they are called spin solar cell instead of solar cell. There are some technology called spin solar cell. Spin solar cell is utilizing magnetic semiconductor. You know that solar cell is combining between two semiconductor, P-type and N-type, right? Just they are just only semiconductor. But as for spin solar cell, we can change. You see that, for example, like silicon-based solar cell, silicon N-type and silicon P-type, right? And here is they use gallium arsenide. Gallium arsenide is also semiconductor. They are P-type and N-type. From this combination, we can obtain some photoelectric, where there are some electric, how to say that, the electric charge, right? Electric mobility from P-type, from N-type to P-type that can produce some electricity, for example, like that. And then if we use some ferromagnetic semiconductor, for example, in here, this is just this is not Holmi monoxide. This is other ferromagnetic semiconductor, very famous semiconductor. There are some gallium arsenide doped by manganese. There are some ferromagnetic semiconductor, and there processes ferromagnetic semiconductor near room temperature. When there are some photon from sunlight come into this kind of heterojunction, N-type gallium arsenide and then P-type gallium arsenide doped manganese, we can obtain some spin tunneling that can enhance the mobility of the electricity. So that probably by using spin solar cell, we can obtain higher efficiency of the solar cell. And for example, like if we compare with perovskite solar cell have very large efficiency, but they are not stable. And if we compare with the silicon-based solar cell or gallium arsenide solar cell, this kind of solar cell is more stable, but having lower cell efficiency. And then if we modified or we develop this kind of the combination to silicon or to semiconductor, we can probably obtain some higher solar cell efficiency that probably we can have some very high solar cell efficiency. And then spin solar cell, as I said, that can be found when we combine the conventional N-type solar semiconductor with ferromagnetic semiconductor. When the ferromagnetic semiconductor, because the ferromagnetic semiconductor has a spin Hall effect. Our holmium monoxide, when we measure with the PPMS, we can see that there are some spin Hall behavior. And then we believe that when we combine holmium monoxide with other semiconductor N-type semiconductor, we can obtain some spin solar cell. This is new type of solar cell that having high efficiency. Yeah. And a summary, here I would like to give some report that we have successfully grown, namely holmium monoxide. Holmium monoxide is new kind of material that before they are just only found in the gaseous phase, and then we have successfully grow as a solid phase, as a thin film phase. And then if we can combine this kind of holmium monoxide with other N-type semiconductor, for example, like N-type gallium arsenide or probably N-type silicon, we can probably obtain some, namely spin solar cell. That spin solar cell having high efficiency compared to conventional solar cell. Okay, that's all my talk today. Hopefully, what I discussed now give you some insight about the solar cell. Yeah, thank you very much. I would like to give to Dr. Kim again. Thank you.
Okay, thank you, Dr. Tata, for your insightful sharing. So I will see you in the forum later on.
Sure.
Okay, so
sorry. Sorry.
no, I'm saying I will be seeing you in the forum later on for the
Okay,
Q&A session.
Sure.
Okay, so once again, thanks.
Thank you.
Thank you.
Thank you so much. Okay. Bye-bye.
Thank you. Okay, see you later. Okay, so for our next speaker, we would like to welcome Professor Shri Sivadasan from UTM. So for your information, Professor Engineer TS Dr. Shri Sivadasan is currently a professor at the Department of Engineering and Technology, Razak Faculty of Technology and Informatics, and a research fellow at the Center of Environmental Sustainability and Water Security, UTM. He received his PhD in Environmental Engineering in 2006 from the University of Newcastle upon Tyne, United Kingdom. His PhD research was on the treatment of pharmaceutical wastewater containing mercurite abiotic using anaerobic digester. He obtained his master and bachelor degree from UTM in the field of chemical and environmental engineering, respectively. His interests are largely concerned with the control of pollutants in the environment related to industrial wastewater using anaerobic process. Specifically, his research is more concentrated towards the control of pollutants from various wastewater source, for example, palm oil mill effluents, paper mills. So his latest project was the treatment of textile wastewater using the modified anaerobic buffer reactor and treatment of landfill leachate using anaerobic stage reactor combined with a membrane bioreactor for the removal of selected micropollutants. He's also very much active in the national and international arena, promoting environmental awareness and the concept of sustainability. He's a committee member of Malaysian Water Association, a Malaysian Water Academy, under the section of Industrial Research and Development. He's also the editor-in-chief for Malaysian Journal of Water published by the WMA. She has produced more than 200 research articles and conference proceedings in the field of environmental engineering, particularly using the anaerobic reactors. So without further ado, let's welcome Prof. Shiri. Prof. Shiri.
Hello, can you hear me?
Yeah, I can. You may want to share your video if you haven't done so. Yep.
I already shared
Okay,
my
Prof.
slides. Can you see?
I can see. Go ahead, Prof.
Okay, thank you very much. Thank you for the lovely introduction about myself. Okay, so first of all, I'd like to thank the organizing committee for giving me the opportunity to present some of my work on the anaerobic reactors for wastewater treatment and also for the biogas production. And I will be talking about some of the fundamentals of AD anaerobic digestion. I think most of you all know about AD system and so on. And also after that, I'll talk about the biogas production, particularly from the palm oil made effluent. Then finally, I'll discuss on some of the challenges that we face in Malaysia for the anaerobic digestion systems. So as you all know, about AD process, it's a relatively complex process, which has 4 main stages, such as hydrolysis. The complex polymers are broken down to protein, carbohydrates, and lipids. And then after that, further to amino acids, sugars, and also higher fatty acids under the acidogenesis process. Then after that, further degradation of the polymers through the acidogenesis. And finally, what we are interested, I think most of the industry people are interested in the methanogenesis process or the final product, the methane. And but in order to produce this methane, so you have to go through all this process in order to get the methane. So these are some of the fundamentals of the anaerobic process. The next part is the anaerobic digestion reactors. There are many types of reactors in the world. I would say like 50 to 100 types of reactors in the world. It consists of from the conventional UASB upflow anaerobic slash batch reactors until the new, the membrane coupled with the anaerobic process. So basically, we have like I mentioned to you, from complete mix, from anaerobic contact process, fluidized bed reactors, expanded bed, and even the stage reactors, which we developed in UTM, which I'll be showing to you all. The fundamentals AD design that I think everyone should know is that the volume, the organic loading rates, the hydraulic retention times, and all that is very important for anaerobic process design. And these reactors are designed basically based on the what you call factors that I mentioned here just now. The HRT is very important because if too high HRT is unnecessarily large reactors are required for the process, and if it's too low, you may reduce the biogas output from the reactor. And also the organic loading rate, which is the quantity of the COD provided to the treatment system per day, which is very important. And also other what we call nutrients such as phosphorus and so on, which is also a function of the organic loading rate. And seed sludge, one of the important factors which determines the populations of the microorganisms. And of course, the pH, the optimum pH is for AD is 6.8 to 7.4, and pH like 7, I think, would be a ideal pH for the anaerobic digesters. This is some of the basic fundamentals of anaerobic digesters. Before I move on to explaining to you what are the reactors that we design in UTM. So this is the what we call latest reactor that we designed, the multi-stage anaerobic digester in UTM KL. It's basically it has the ability to separate the acidogenesis and methanogenesis. You can see from the slide. They're allowing the reactor to behave as a two-phase system. It has no moving parts or mechanical mixing, making it relatively inexpensive to construct. And the sludge generation is low and the solid retention time is high. And it's also stable to hydraulic shock loads and organic shock loads. And we have tested using the landfill, the real landfill leachate, and we found out that it can remove more than 99% of the COD from the raw leachate. And some of the what we call benefits of this anaerobic digester is it has the staging mode, whereby the operation will improve the fluid quality, and which can accommodate the toxic slugs more efficiently by passing them in less time through the reactor system. So some of the micropollutants, for example, the antibiotics and so on, it's not easily biodegradable. No, it's not easily removed from the conventional what we call biological processes and all that. But this stage reactor that has the capability to remove even the micropollutants. And also it generates separate environments for promote favorable condition for microbial populations. involved in the degradation of recalcitrant compounds. And basically, let me explain to you a bit on the concept, how the process really works on this multi-stage anaerobic digesters. Like I mentioned to you earlier, that it is from the acid-forming bacteria. Then it goes to the second phase, is the methane-forming bacteria. The first stage is the acid-forming, whereby the bacteria utilizes the organic matter and forms the organic acids. Then after that, in the second stage, the methane-forming bacteria or the microorganisms predominate and convert further to methane and CO2. So the second stage is very important, where the stabilization occurs for the final production of the methane. So this is the concept for the multi-stage anaerobic digester that we develop. It's a two-phase system whereby we separate the acid-forming bacteria, and at the same time we also separate the methane in different stages of the reactor. And we have another type of reactors also. We have developed in the laboratory, which we call modified anaerobic buffer reactor. The MABR, the modified anaerobic buffer reactor, is basically is a series of the USB, the outflow anaerobic sludge bed reactor, which in the wastewater is forced to flow under and over the series of vertical buffers that you can see over here. And the compartmentalization of the reactor prevents the horizontal movement of the biomass. And there's high amount of active biomass is retained in each compartment of the reactor. And the feature provides the excellent contact between the contaminants and the microorganisms, no longer biomass retention, and better resilience to the OLR and also the HRT. So, and its design also ensures contact between the biomass with the substrate without the need to use any mechanical mixing. Okay, moving on. Now let me talk about the composition of the raw biogas. This is some of the general information about the biogas that is being produced in the anaerobic reactors. For every cubic meter of biogas that is produced, the electricity that can be generated is 5.5 kilowatt. So this is ideal condition, and average calorific value is 20 megajoule per every meter cube of biogas that is produced. And one of the problem with this biogas is the carbon dioxide, which is around 35 to 45% that you need to remove before you can use that biogas for electricity supply and also for other purposes. So these are some of the what you call fundamentals. How you can use the biogas. In fact, you can straight away use the biogas, but we call it as a low grade fuel, which has the methane content is around 55 to 65%. And because of the CO2, you still can use that, without taking out or without scrubbing the CO2 from the gas. You can just use at one side or for cooking and all that. And even for electricity production using conventional biogas generators for homes and all that. But there's another type of biogas that we call as upgraded biogas, which has high what we call methane content, more than 90% of the methane, and it's is basically used for remote applications, and also cooking of fuel, and even for electricity production. So this upgraded biogas can be used to produce electricity production, which I will show to you that we have done some work on this. And our work is basically on the palm oil mill effluent. We have used the palm oil mill effluent to produce electricity, and not in a big scale, in a small scale at the laboratory. And as you all know, palm oil mill effluent contains high amount of COD, can go up to 80,000 milligrams per liter. So it's a great potential for biogas productions. And in Malaysia, we have more than 500 palm oil mills in Malaysia. So if we can convert all of them to biogas plants, I think they can supply the, I think I would say like 10% of the energy for Malaysia. So let me give you some information how the palm oil have the opportunity to produce electricity. For example, let's say we produce the CPO, the crude palm oil production in Malaysia is 20 million tons per year. And out of this, palm oil mill generated is around 60 million cubic meter per year of palm oil generated, and which is equivalent to nearly 3 million tons of COD per year. So just imagine the huge amount of COD is there. So with that, the methane production that produce from this 20 million tons of CPO is nearly 3 million cubic meter of methane is produced per day, which is equivalent to around 567 megawatt electricity, okay, per day. So there is a huge potential for palm oil mill effluent to be used for electricity generations. And it has been done in Malaysia, and there are many plants and also biogas digesters in Malaysia, but it's not that much. So these are the challenges that I will be explaining to you after this. So this is another study that we conducted in palm oil mill plantation in Felda, Palung, in Negeri Sembilan, Malaysia. So what is it's relatively looks simple process whereby the palm oil mill from the mill is directed to a pond that you can see here, and this pond using a pumping station is sent to a covered lagoon. So what they did, the lagoon is covered with a thick 1.5 centimeter thickness of the membrane, HDP high density polyethylene membrane, which covers the lagoon. And you know what will happen once that lagoon is covered, and the amount of methane and also CO2 production is very high, very huge. And you can see the balloon so is going up and down when the methane production is very high. And by using a electricity generator, and also of course to remove the CO2 using a scrubber, and you can produce the electricity. And currently they're supplying to TNB. And the production is 1 to 1.5 megawatt plant. So relative the construction of the plant is 7 million Malaysian ringgit. So the return of investment is around 3 to 4 years. So there's a great potential for this. And challenges for anaerobic digestion deployment in Malaysia, there are many challenges are there. Even though the Malaysian government is very keen in developing the renewable energies capacities, particularly for the electricity generation for sale to the grid, to reduce the dependency of fossil fuels and reduce the carbon footprint. And Malaysian government are very ambitious to increase the planned renewable energy capacity by 100 megawatts. 100 megawatts. But nevertheless, in 2008, there's a study showing that there are only like 60 megawatt of installed capacity of the biogas has been commissioned so far. Thus, it can be concluded that the growth of biomass plant installation is still in the early stage in Malaysia, although various opportunities are available for Malaysia. Another challenge is that the cost and also the return of investment. The Malaysian government has introduced various financial schemes, for example, the Renewable Energy Business Fund, and also the Green Technology Financing Scheme, GTFS. But there's a still lack of participation from the Malaysian based banks to finance the renewable energy projects, even with the existing GTFS. And this is due to the lack of awareness, actually. It's not that the technology is good, but I think the awareness and also the experience of renewable energy projects among the financial institutions or investors in Malaysia. Besides that, expanding the grid connection to the biogas plant is unfeasible, as most of the palm oil mills are located at the suburban areas, and it's quite far from the what we call interconnection point. So this is because in order to to have a very good what they call investment or the return of investment, the biogas plant should be around 10 kilometers to minimize the transition power loss and also to the economically viable of the investment. So it should be around 10 kilometers from the nearest interconnection point. Another challenges are the shortage of professional technicians and so on. And because you need high skill, personal and careful maintenance for the AD system, it's not like aerobic process, because it's very quite difficult to maintain the anaerobic digesters because it's very confined and we want to make sure there's no oxygen goes into the anaerobic digesters, and we need a lot of specialized people to maintain and operate the AD system, and also to capture the methane and to generate the electricity. And now I think with a lot of seminars and workshops on this AD system conducted by the government, even in the institution, even myself also conducted several courses on this, and we have given the experience and also some skills to the people, to operators on this, how to operate the AD systems and so on. Okay, and another big challenges of this AD is the electricity market structure that we found in Malaysia, because there is uncertain financial viability of biogas projects and also unsatisfactory pricing arrangement under the FYP, because the AD need to compete with other renewable energy sources, such as the solar PV. Currently, the solar PV, I think the government are paying around 0.8 to 1.23 cents for every kilowatt, compared to the biogas, because biogas now they're paying like 0.28 cents. 28 cents to 32 cents. But if you look at PV, what they call the solar PV, it's nearly more than 1 ringgit of Malaysia. But it's very competitive now because you need to compete with biomass and also small hydropower in the renewable energy sectors in Malaysia. And in fact, they need to beat. They need to beat every time when they want to sell to the TNB. And this is a challenge also, and also some regulation policies by the government. It changes from time to time, like I mentioned to you, because the bidding system is now on compared to previous years. Few years ago, there's no bidding system. Now the bidding system says so they need to compete each other to sell their gas or methane produced to TNB. So these are some of the challenges. And conclusion, I would like to say that Malaysia has a great future to generate electricity from biogas generators from palm oil made effluent. And it has been done now, and a lot of people are looking into that, produce methane from palm oil mill and also from other wastewaters. So with that, I would like to take any questions. If there is any questions, thank you very much.
Okay, thanks, Prof. Sherry. I think we will do the Q&A session in the forum session later on. I'm sure there will be a lot of questions. Are we going to do it later? Okay.
Thank you.
Thank you. Thank you, Prof. Sherry. Okay, so with that, let me introduce our next speaker. Okay, so our next speaker will be actually Dr. Henry Tiglasana from the School of Physics, Airlangga University. So he's actually born in Kepri, East Java, Indonesia. And he completed his Master of Physics in 2005 from Sebelum November Institute of Technology and his PhD in Experimental Physics in 2018 from Flinders University, South Australia. He has been a member of the Faculty of Science and Technology, Airlangga University since 2003. Since late of 2020, he has been appointed as a head of School of Physics as well as the head of Physics Department in Airlangga University. During his year in Airlangga University, he has been carrying out some experiment in optical spectroscopy, and after he completed his PhD, he's also interested in renewable energy research topics. Since 2019, he has obtained research grant from local and national research funding scheme, and also overseas research project grant, such as Australia Alumni Grant Scheme in 2021. His current research activity are closely related to the gasification process, as well as the solar energy application, such as he's eagerly building out a solar car with his collaborator currently. Okay, Dr. Henry. Dr. Henry. Are you ready? Let me check. I cannot hear you. Let me check. Let me check. Yep.
Okay, now can you hear me?
Yeah, I can. Thanks
All
for
right.
responding.
All right. So sorry, I'm not quite familiar with WebEx.
Yeah,
yeah.
it's fine. You want
Okay,
to try to share the slide?
Hopefully I can do that. So there's a screen here. Now you are the presenter. Okay. And touchscreen Windows. Okay, should be that one. Can you see my share? Please?
Yeah.
All
Yeah.
right, excellent. Thank you very much.
You can put on the full presentation
Yes,
mode,
sure.
maybe.
Sure. Okay. So it's okay now? Shall I start?
It's not in the full presentation mode yet.
Okay. So this is now. Can you see it?
I can see, but it's not in
But
the full
it's
presentation
not in
mode.
the.
It's not in the
Yeah.
yeah.
So I can share again here. What about now?
I think it's still the same.
Okay.
It's in the PowerPoint. It's not in the full presentation mode.
Okay, let me check this. Should be different. Should be application. Let me check the application one. And
Pak Heri, probably the meaning is slideshow mode, Pak.
yeah, I already do this time.
Yes,
But
that,
they
that
can
one.
do. Yeah, but they can't do that. Can you see it now?
It's still in the.
Yeah, I already slide slow, but this one is slideshow, right?
Yes.
And you
Yeah,
can't see it, can you?
Yeah. How about you? You are viewing a full presentation mode, is it?
This is not a presentation mode. Doctor, can you share at the chat box? Maybe I can help you.
Or maybe you.
Share it.
Yeah, or maybe you can just.
Okay, yeah,
share
yeah,
through
yeah.
computer.
Sure. I will send the file, right?
Yeah, or you want to save it in the PDF mode? Maybe it's easier. PDF file, so that you can control yourself.
How to send the file to the participants here?
So, you want to save it into PDF file? Maybe you can just share in the PDF file. Then it will be easier.
Hang on. I need to save it first in PDF.
Yeah. It will be easier if you can just control yourself.
Yep.
Just save a PDF file. Yeah. Okay. So you can try to open out the PDF file and you need to share the screen on the PDF file.
Can you see it?
You have to share the screen first.
Yep.
Have you shared the screen? You have to share the PDF file on the screen.
Yep, I already did.
You want to click on the view and full screen? Maybe you can click on the view and full screen. I think there's a function where you can go to the view and full screen. Yeah.
This one.
On the top, beside the command view.
Doctor,
on the left.
I think
On the left. Home command view from view.
Yep, view, and then.
Doctor, I think you can proceed.
Yeah. It's fine. I think this is better.
It's okay.
Okay.
Yeah, just to see whether we have to. It's fine. If you do not have the full mode, I think this is better than the previous one now.
Okay. Sorry
So I
about.
think you can proceed with this one. No worry.
All right. So well, it changed now, right?
Now you can just use this one. This is fine. Go
Okay.
ahead.
Yeah. All right. So thank you very much, Dr. Limt. Today we're gonna sharing about the issues where Indonesia is already facing up a couple of decades since maybe 1980s to 1990s and then earlier 2000s and then up until now. But it's a bit slowly changes differently. But we are still going to, let's say, encourage all of the people in Indonesia to be aware of the renewable energy and that usage. And also because we are in the educational systems for the high educational systems in the campuses, we need to encourage all of the peoples of the students in the universities that they need to aware about these applications, the renewable energy, whatever the level you are interested in, and whatever the application that they are going to implement, they must be very, very crucial to understand about why we need to look at to the renewable energy for Indonesia. This is nothing else that we are going to enlarge and provide all of the affordable access for all of the people in Indonesia and every country in around the world. But that's not going to that as easy as what you thought. So we are going to touch very, very macroscopic point of view of the renewable energy. Even we are usually take into account everything in more details for the research process. So I'm going to introduce myself. I'm Heri Raksana. So okay, now the problem is we just hit this one, I think.
You
So
can scroll down, maybe.
yeah, it's so slow. Okay. Yeah, it changed now. So this is my photos, and I'm from the physics department, School of Physics, Faculty of Science and Technology. So we are particularly we are talking about the thermochemistry and thermoconversions in thermodynamics process. And also, we are going to talk about the application of the spectroscopy in uh, the, the conversion between photon to the electric to generate electricity. We call this a photovoltaic, whatever you are interested in, to the solar panels or the organic solar cells or whatever. So yes, we are in the School of Physics, but we are talking about a bit more chemistry and physics on the between. Okay, this is what actually we are very, very embarrassing of. So let's say the top view here, we can see that this is the soccer games between, from my memory, this is I capture from the Barcelona in the Australia when they visited Australia in 2019 maybe, before the pandemic, or maybe 2022. And then the white one here is the Australian players. So if you look at the screen here, all of the details are very, very clear. So it indicates that all the intensity, all of the light um, from the light source into the object and it's reflected to the camera is perfectly works very well. And while we are talking about the stadium in Indonesia in the bottom here, this is the local domestic league in Indonesia. And we can see quite different intensity if you look at this. Is not because the Australian and some players from the Barcelona has the bright skin, but at the grass. The grass are different. If you look at to the naked eyes, they're the same. Our stadium are as nice as what the stadium in overseas, even in Australia. But now, when we are look at to the screens, when we are look at the camera, they are different. They look very different. It's why because the lighting are very low intensity, and it's due to the power of the electricity consumed by the stadium. Why? Because it's more expensive when we are working with the electricity with a high power to generate the light um, uh, going over the stadium. Okay, so basically, yes, they are different, and we understand why they're different. This is because of the energy consumptions between Australia and Indonesia, and let's we compare with other countries as well. So this is a bit embarrassing. Let's we compare a bit more details. Look at here, the top here I put Indonesia and number 15, and this is the and you see the one, two, three, four, five, six on the sixth column here. This is the population, so the number of people here, and Indonesia is the fifth or the fourth biggest countries around the world, 270 million people, inhabitants. But look at this 900, just 900 mega watt per year that we consume. If you compare to Australia here, which is 9,500, and because we are talking to UTM now, let's look at to Malaysia here. This is even half of Malaysia. Sorry, half of the Australia, and it's completely 5 times more than what we consume per year. That's why when we look at, if I go back to the screen here, these differences are very, very embarrassing. So why? Why do we put at these situations? What do we do? Okay, now let's we go a bit more detail for what we are doing in Indonesia. So Indonesia should put more power and energy power on the basis of the renewable energy. So on that picture, I try to capture one of the wind turbines or windmills in South Sulawesi. We just developed this in 2019 or maybe 2018, end of 2018, and this is the largest wind turbines in Southeast Asia. So this is the just new project as the evidence that we actually can do that. Blackout and chronic air pollution in nations with abundant sources of clean energy makes no economic sense. That's true. We need to do something, not only by doing research, publish a lot of paper, a lot of articles on the very reputed journal. But the point, while we are doing this, we can do services for the people very well. Significant proportion of the eastern Indonesia have done reliable power supplies. So why does Indonesia remain the resilient for fossil fuels? We, we, we just put all of the rubbish on the air as the pollutants. For the archipelago as large as Indonesia, look, we located at the equator at the top of ring of the fire as the active volcanoes. It wouldn't be wrong that we think that our nation as Indonesia could become one of the world leaders in the renewable energy. So a lot of an abundance resources for the renewable energy in Indonesia. But why our condition is sort of like this? Indonesia has the potential to generate 280,000 megawatts of the power of renewable energy, such as wind, solar, tidal, and geothermal. We cancel out all of the biomass still. We are not going to do with the organic sources, but we just, what we actually can see very easily, tides, geothermal, solar, wind. That's pretty much uh, abundant resources in Indonesia. Interestingly, this is more than 14 times that the country's current electricity consumptions. So let's we do it just half of those. We just have 7 times of what we actually consume at the moment per year. Okay. Now, just ask Maria. Okay? I'm busy. So this is unpack what we actually facing off. The Indonesian electricity needs to predict to grow up until 7% until 2027, and as mentioned by the previous the two previous speakers, up until 2040, Indonesia will be very significantly about 3 times more than Malaysia will consume in for 2040. So that's just the hydrogen production. That's just point of view of the hydrogen productions. In general, we are going to have more than that. Okay, more than that. The capacity, the number of people in Indonesia, and the engagement of the people when they're well educated, they will realize that they need more energy for their life. This is the average out across the country. So it's important to know that somewhere between 10 to 20 millions Indonesians who don't have access to electricity, which is 20 millions is about to 1/5 of our populations. And only 60% of the people in East Nusa Tenggara, which is the eastern part of Indonesia, they have electricity, just 50%. And more likely in Papua, in the eastern part of Indonesia, it's just 50%, which is ridiculous. Okay, in many areas, power is also not available for 24 hours and it's completely dark, completely no electricity at day. Okay, what is the little step that you have done? So we're just trying to do something that we need to serve, that we need to put engagement of the people, how they do the daily life, how they consume their energy. So that's even started in 2018 in Sidrap. So Sidrap is some places in South Sulawesi. The name is a bit similar to what we had in India, but yeah, this is actually in Sulawesi, the biggest windmill in Southeast Asia, in Sidrap in South Sulawesi. So it turns to 30 turbines, provide 70 megawatts of energy, and services to thousands 70,000 households. It covers 10 hectares, 100 hectares of lands, making South Asia the largest wind farm. And so, what the commitment from the government and the national electricity services, we call it SPEL in Indonesia. So why not we have the more renewable energy sources being harnessed? So that's why we need to take some action policy on the basis of what the other countries look at to Indonesia. This is not from Indonesia, look at what Indonesia has done. This is from other countries. They look at a couple of countries and then they do some evaluations together with Nepalese and say India, Pakistan, Afghanistan, and Indonesia. In 2004, Indonesia is no longer the oil exporter. Yes, we know about this due to the significant decrease of the oil production. In the meantime, the use of fossil has increased by 60%. So this is kind of on the other hand, we increase the needs of the oil production, but we limited by the production. It's just limited by what we produce. The capacity is low and the demand is very high. This has forced Indonesia to import the oil. Start from 2004, we imported to fulfill the domestic needs. Indonesia has not strategically tapped its huge potential of renewable energy, except hydropower, which is already producing 4.2 gigawatts, which is still not quite abundant, 4.2 gigawatts with the hydro power. And geothermal, ridiculously, is just less than 1 gigawatt. Geothermal is quite easily because we have already surrounded by the volcanoes. The use of other resources of energy such as PV, winds, micro hydro, and etc. is hampered by the high cost of the hands inability to compete with the fossil fuels. That's not the question. The question is how we service all of the people in Indonesia, not about the price.
Hi, Dr. Harry. Are you able to hear me? I can't really hear you from my end.
That we don't need to do the research about this, but look, perovskites as the polymer uh, employments, they have a very potential and promising achievement rather than the dye-sensitive solar regards. Okay, so that's why we are not going to do these things for Indonesia, or at least until 2040. We just left behind. This again, we are going to do the XPS, UPS, MIS, NICAS, which is very cutting edge technologies to investigate all of the microstructure of the metal oxide. But the point is, can you service your people quite well? The blackouts happening every day, everywhere. And this is part of the regulations. Regulations should regulate something for the better life for the people, not how to arrange the blackout for couples of area in Indonesia. That's not the services. This again, photoelectron spectroscopy, everybody knows how to evaluate and how to manage all of the surfaces, all of uh, the electronics behaviors while they're exposed by the photons. But again, the problem is not this. We need to increase the productions of the renewable energy in Indonesia if you can't afford the fossil fuel to get electricity for their against. This is that's what I'm doing in my PhD. But when I come back here, there's the real problems. When I'm doing this, and then this is a bit further away from what I face off, that the people need the electricity. The people doesn't need the article. The people doesn't need the publications. They just need what can they do with the electricity they consume every day. Again, this one. Yeah. And this one. This is very expensive apparatus. This one. So not going to discourage everybody to do research, but let's do something a bit more strategic for everybody in Indonesia. That we need to do some more applicable to the surface of people in Indonesia for the better access to the electricity, so that I'm just turning myself, turning from that, going to be more practical, a bit more real. That I call it a 3E. I love this. How our students a bit more practical to do something that's going to be more beneficial for people in Indonesia, to encourage them to do some more useful for people in Indonesia. This is not quite expensive. We can do that. I just want to provide something that they can see very clear, they can use for their life and improving the engagement to the technology on the basis of the renewable energy. Thank you very much for your attention, and I would like to say sorry for everybody who are not going to be very agree to what I convenient here, but that's what I'm turning now from the something that is quite microscopic and very fundamentals to a bit more practical and useful for our people in Indonesia. Thank you very much, and I would retract my
Okay, thank you, Dr. Harry, for your very interesting sharing.
Yep.
So we will actually have some question for you, but I think we will save it for the forum session later on.
Yes, of course.
So
No
please stay tuned
problem.
for that. Okay, thank you. So with that, I think we would like to welcome back our presenter, our last presenter for today's session, Dr. Lily. Dr. Lily,
Okay. Yes,
yeah.
Dr. Sorry.
So are you ready right now
Yes, ready.
to
But I
resume
will
whatever
share
you?
using PDF
Yeah,
file. Is it okay?
yeah, it's okay. You
Okay.
want to share your webcam as well?
Yes.
Yeah, you can start at the place that you stopped just now, I think.
Okay. Okay, allow me. Could you see my screen?
I can see your, are you sharing the PowerPoint? Oh, okay, now PDF. Yeah,
Okay.
I can see.
Okay. Okay. Okay, thank you. Is it I better I go to my last presentation or start from first page?
I think you can go for based on resume, meaning today you go to your last presentation, the last
Oh,
slide
okay.
that you present.
All right. Okay, thank you. Okay, thank you. Thank you, Dr. Lim. Okay, thank you for the audience for today. Assalamualaikum warahmatullahi wabarakatuh. I will continue my presentation. This one is a review of the impedance-based method that we do. So based on the impedance-based value from the impedance line value and then impedance load, we can formulate the formulation, and also we consider the current compensator for the in the distribution and transmission line, so we can obtain the formulation of a distant value is like this. This one is already published also in our journal. Okay, this one is one of the example of the tested network in the single line diagram. For the this one I adapted from the underground distribution network in Malaysia also, because previously my research is in University Malaya. Okay, and then okay, as a resume of our discussion today, for the fault location, each fault location method have advantage and disadvantage. So we can consider for each of the method based on our condition in the practice, or our condition based on the database what we have. Okay, second, probably the combination method can solve the problem. So now the combination method is one of the option that can improve the accuracy of the fault location method. And then finally, the improvement for each method still have a discussion in the recent journal. So until now, because what I can, based on my review, that the fault location method still didn't have the very accurate or exactly point when the researcher uh, observe the fault location point. Okay, okay, that's all from me. Thank you very much for the time, and wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Dr. Lily. So
Okay,
I look forward to discuss with you more in the forum session later. Okay,
okay, thank you.
so thank you again for the sharing again. So with that, I think we have concluded our presentation session for today for all the speaker. So we are now going to move on to our next session, which is the forum. So with that, I would like to invite all the speakers, all the honorable speakers to attend this session. We actually have gathered some questions from you. So would appreciate if you can switch on the web camera and join the session. Okay, so do we have all the speaker here? Professor Linda, are you here? Dr. Fazira, let me know if you are here. Okay, yeah, thanks. I can see Pro Sadia, Pro Shiri is here, Dr. Tata is here, Dr. Henry is here as well. How about Dr. Fazira and Prof. Praslinda? Okay, so never mind. I think we are waiting for Prof. Salinda to join us. I will start the Q&A session, the following session first. So it's very interesting today. We have various speakers from Universiti Teknologi Malaysia and Universitas Air to talk about various topics related to the renewable energy. Okay, either from the system perspective or the fundamental components such as the material. So for the first question, maybe we can actually invite Dr. Satya first to talk about there's a one question about asking from the audience asking about does OTEC has the weakness like wind and solar energy in terms of stability? Does OTEC suitable to place with a shallow ocean? So I believe there are actually two questions here. So Dr. Satya, over to you.
Okay, thank you, Dr. Lim. And for Kamarul, I think he asked a question. I've already answered it on the chat. However, let me allow me to elaborate further. Yeah. So, ocean thermal energy conversion is a technology that I've been highlighting. It's the potential is high in the equators, and please bear in mind that we need the deep seawater or deep ocean waters, whereby we need the 5 degree or 6 degree or 7 degree that cold water. So with the temperature difference, the surface and the deep ocean water, we have about 20 to 22 degrees C. But let's say the thermal efficiency and the thermal, the thermal difference that we have is only 20 or 22. So if we have a higher temperature difference, such as, I just give one example, maybe in the Straits of Malacca or somewhere, some waste, heat waste is there. So let's say the heat waste is about 60 degrees C or maybe 40 degrees C. And then we can utilize the surface seawater because as we are aware in the Straits of Malacca, there's no deep ocean waters, right? Or on the other side of, South China Sea, Kelantan and Terengganu and this side. So when there's no, we don't have, we can still, design and think of a system whereby we have a greater temperature difference with the surface seawater. So this is the idea that, I think I wrote in the chat also. And the question, another question about supply, right? Base load, OTEC guarantees 24/7 base load supply in a stable manner. So why? Because the surface seawater temperature and the deep seawater or the shallow temperature, it doesn't change with the climate or with our, moon and so on. It doesn't change. So that's why we can have, unlike others, such as wave or wind and so on, it has a difference due to climatology. Right? Maybe I've answered the question.
Yeah, Dr. Satya, I agree too. Unless there's a volcanic destruction under the seawater, otherwise the temperature should be more or less stable, right?
Correct. Exactly.
Yeah, okay. Thanks for the clarifications. Okay, I think for the next question, we would like to direct to Dr. Tata. Okay, so you
Yes.
talk about your new material. So I think one of the audience asked about that this new material for semiconductor exists abundantly on the earth, since this will actually if affect the price of the future generation cost of the solar panel.
Okay. Yeah. Thank you. Actually, I also have answered the question from the
Dr. Tata, I can't really hear you.
check. 1, 2, 3, 4.
Are you talking
Check.
right now?
Yeah, I'm talking right now.
It's very weak, your voice.
Check. Check.
I'm not sure. How about the others? Will you be able to listen Dr. Tata clearly?
Your voice not clearly, Dr. Tata.
Okay. Wait. Check. 1, 2, check. Check, 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 check. One, check, check, check. Is still hear my voice? Hello?
I think still a little bit weak.
Doctor, I suggest you maybe you can write the question in the chat box.
Okay.
Thank you, Doctor.
Okay. Right. Thanks for the suggestion. So with that, we can move on to the next question first. We are waiting for Dr. Tata to share his opinion on that earlier questions. So for the next question, I would like to direct to Prof. Chili. Okay. So one of the audience is actually asking about, is there any potential of biogas from different type of wastewater, for example, from the food industry? So I believe you already answered this, but is there anything that you would like to further clarify on that?
Yeah, thank you very much. I think most of the questions are already answered there at the chat box. But however, I'd like to explain a bit. Yeah, we can use food waste for anaerobic digestion. There are many abused, and there are many studies that you can go through the literature review on this using food waste for AD system. But many are in laboratory scales. Even in Malaysia, we have done many research on this, and uh, even myself, we have done a lot of work in laboratory scale, combining food waste with other types of wastewater. But there's one or two companies that I know in Malaysia. One in Sabah, they're using the entire food waste, not combining with any types of wastewater, just the food waste itself. You can produce the biogas from the anaerobic system. There's one plant in Sabah, uh, but I didn't go and visit. But the manager of the plant met me recently, and he was explaining about that. But majority of them, majority of the wastewater companies in Malaysia, they're using combination of this food waste with other type of wastewater. For example, like I mentioned to you about IWK. IWK, they have some plant. In fact, they have done something on the anaerobic system in Pantai treatment plant way back, like maybe 5, 6 years ago. They have done that using food waste in combination of their wastewater that's coming into their plant, the sewage treatment plant. And I didn't see in a big scale, actually. I didn't see in any big scale they are combining the IWK water or the sewage water into food waste. But definitely there is opportunity of waste being used to generate electricity.
Yeah. I think the biggest challenge will be in terms of logistic handling, right? Especially when you talk about collecting the food waste. So
Yeah,
this
correct.
could be
That's the big. I think that's the biggest challenge. And what is the characteristics of the food waste? How are we going to segregate the food waste, to separate, and what do you mean actually the mean by food waste? Because there are many types of food waste are there. So whether it's really organic, is it from kitchen waste? Is it from food waste and all that? So there are a lot of things. Some fundamental studies should be done. I think many have done on that, but like you said, the biggest problem is segregating or separating the food waste for the anaerobic process. And also, there might be some inhibition of this ammonia and all that in the food waste that probably gives some effect to the anaerobic process. So all this must be studied first before we really implement in a big scale.
okay. Thank you, Prof. Shirley, for your answer. So with that, I think we'd like to move on to the next question. Prof. Haslinda, just to confirm, are you here? Are you here, Prof. Haslinda?
Doctor, I'm sorry, Prof. Has still in a meeting, so I think we
Okay.
proceed to the next question. I think
Okay.
Prof. Has still
Okay.
sorry.
Sure, no problem. Okay. So let's move on. So this question is actually direct to Dr. Lily. Okay, Dr. Lily. So
Yes.
so I think your topic is about study about the stability of the grid, right? So just wondering, what is your view? Like, for example, we know that when we're trying to integrate the renewable energy into the grid, especially for the solar PV, how does this actually affect the transmission and power quality? Have you done any similar study on that related to that? And what is your view on that?
Okay, thank you. Actually, I try to answer for the question. For the grid, from the renewable energy, for example, from the solar to the grid, yes, to the grid. Uh, what we can for the stability, uh, actually, so many parameter that we have to consider. For example, about the voltage stability indices, voltage stability when we connect for the online for the grid, and then also uh, uh, the efficiency, of course. That one voltage stability indices is related with the efficiency. So when we connect the renewable energy to the transmission or distribution network, uh, for sure, we have other problem about the voltage stability. The voltage will sometimes will drop, something like that. So this one is a one of the specific research that uh, we also consider for the continuity of our research also. And then another part is what I will already talk about the fault. Okay, when we go in the practice, when we connect also renewable energy to the transmission or distribution line, for sure that one in practice always we always have the fault. So this one also so many type of fault. So this one also uh, is a big problem that until now still researcher never stop to make a research that uh, we how we develop the method which generate the limited error like that. Okay, I think that's
Okay,
all from me. Thank you.
thank you. Thank you, Dr. Lily, for your insightful sharing and response on that. So for the next question, I think I would like to direct this to Dr. Harry. Dr. Harry, yeah. So thank you for your interesting sharing just now. So would like to discuss with you in the context of Indonesia, since right now you are working on education and also provide awareness on the solar PV. So
Yep.
did you see any difference between commercial and industrial uptake of solar PV against the domestic?
Yes, yes, that's very different things. If we are talking about the how to produce the solar cells and how to use as the like the the daily activities. For example, we install the PV on the top rooftop of our house, and it's a bit ridiculous because you can generate the electricity, but while you are not getting the batteries to storage the electricity, the potential. So what's the point? You can't do it for the longer period of the time. You just produce the electricity, you just use it at the same time while you're producing, and then at night you have no idea what should we do there. So this is kind of the why we are not going to do some others resources like the biomass to combine all of the renewable resources, not only the photovoltaics for the yes, photovoltaics can kind of this, you are abundant with the sunshine, right? Because we are in the equator, 6 months and 12 months we are going to be provided by the photons. But the question
Yep.
is, the batteries technology are still not quite accessible for everybody. So we need to turn to and open all of the variety of the renewable energy resources like the biogas, biomass, and the geothermals, wind.
Mm.
So we just provide all of the resources through all of the lands in Indonesia. So this is kind of the infestations. Yes, you need to build up and you need to invest some budget for national budget. But yes, we are doing research with the very 20% of the national budget of Indonesia, but then we still don't have any ability to get the well services for the electricity, the basic needs of Indonesia. So what's the point? 20% just for research? It's come on. We need to encourage people to understand what they need, not what they need to do for the like. Okay, get some bright and very reputed researcher is fabulous, but people need something else from what we are doing on the research. And that's why if we're talking about the depth valley between research and applications, that is very true. Every nation, every country is faced at the same time. But let's we close the gaps between the research and the applications, the solar cells and the batteries, the needs of the electricity and how we produce or generate the electricity. So this is kind of what we need to do for all of the whole country, like Indonesia, with its 2070 millions people, and the lack of the electricity for the day life. This is quite something. This is quite different. If we are talking like Malaysia, which is maybe 17 millions, or let's say I mark up until 20 millions, 20 millions people in Malaysia with the grants and with the research of fundings, then you can do anything for that. But for Indonesia, this is just, let's say, 1/6 of Indonesian populations, and the grants should go to somewhere else, not only for the research. We can do some research, but let's do a bit close to what the applications, what the people needs, not very further down of the fundamentals, which is, okay, you can do publish that one, that one, that one, but people still starving with the energy. Look, the more independent nations, of Malaysia and Australia, Sweden, or Europe countries, because they can do and afford all of the energy by themselves. Then
Okay.
we have the lot of sources in Indonesia, ring of fire, ring of the geothermal sources, and biomass with the
Yep.
sunlight with over there. So that's what we hold. Thank you very much.
Yeah. Thank you. Thank you for Dr. Harry for sharing your thoughts. Yeah, I think like you mentioned, I think for some countries, I think energy security has to become first. If let's
That's
say
right.
the current state have not achieved energy security first, so they may want to rethink about their strategy.
Yep.
Yeah, thanks for. All right.
Please.
So I think we still have time for maybe a few more questions. So now I would like to ask this last question for Prof. Shirley. But if any of the panel have any questions, feel free to rise up after this as well. Okay, so Prof. Shirley, this is actually for the audience. I know that you have answered the question, but because we are also broadcasting this on the YouTube, so maybe you can also share with us about this question. So the question is about asking about the effectiveness of the modified ABR to remove the nitrate and phosphate because based on the question in Indonesia, ABR is commonly being used as a method waste for WWTP wastewater treatment plant to treat the domestic wastewater, but it's actually not really effective to remove nitrate and phosphate. So, what is your thought on these issues, Proshiri?
Yeah, I think like I mentioned in the chat box, the removal of phosphate and these nutrients and all that from wastewater is one of the biggest challenge in the world. Even though we have a lot of technologies and all that, the amount of nutrients are still there in the wastewater treatment plants. And there's no one so far there's no one single process that can able to remove the entire nutrients, because it needs some combinations of microorganisms to remove that compound. Coming back to the question whether the anaerobic buffer reactor and I think the questionnaire, the person who asked the question, she said the ABR could not remove the nutrients in their wastewater treatment plant. Okay, how does the modifier anaerobic buffer able to remove? But like I mentioned, the ABR is basically is anaerobic process. Okay, it's just one single anaerobic process. You need some combination of process to remove the nutrients from the wastewater. For example, you can use anaerobic, aerobic, and anoxic process. Combination of microorganisms to do that. And like anoxic process is oxygen alone, from the denitrification process. And if you ask, the anaerobic process is about all, including the oxygen and also sulfate, nitrate, and so on. So for that question, whether the system, the anaerobic buffer reactor can remove the nutrients. Generally, for your information, we need to see the amount of nutrients that need to. If it's not that much, even the anaerobic process alone can remove that, because the anaerobic process needs nutrients, right? The NPK values are important for the anaerobic process. So you no need to add extra NPK, nitrogen, phosphorus, or kalium into the process. But it's too much and it's a problem, then you need to combine the process, like I mentioned just now, the anaerobic process, the aerobic process, and the anoxic process. And that has been used in worldwide. This is not something new. Many have used the process that I mentioned to you just now. So generally, that is my answer for that. Thank you.
Okay, thanks, Proshiri, for your response. So we actually have one question from Dr. Satya here. So he's direct the question to Dr. Harry. Dr. Harry, so what is actually the wind speed average potential in Indonesia? And based on your understanding, what is actually the share of wind in the energy mix in the context of Indonesia? If let's say you have some information on that, maybe you would like to share with the audience.
Yeah, so mixed up between the resources are interesting. So biomass is quite abundant on the basis of the organic resources. So like the waste management, we need to develop the new technology for the incineration, gasification, pyrolysis, and so forth. And as well as we need to understand how to employ the tides. Okay, the tides in Indonesia is not quite maximum if we compare to somewhere else in around North America or Canada, but it's still very, very homogeneous, because if we're talking about the tides in Indonesia, every month we will have the full moons, and the magnitude is about 60% of the maximum tides in Canada. which is very, very potential for to generate electricity. But the problem is not about the investment, how to facilitate all of the generators on that part, on the offshores, but the usage of these lands are actually, it has been used not quite wise. So, for example, we are not allowed to use the coastal lines for the industry. So if we are doing this, then we lack of the area of the tides to generate the electricity. And this is very free energy. Like you just wait until the full moon is coming, and then you just release all of the valve back to the oceans. And this is just for free. This is just for free. You just invest some concrete for them across the coastline. Coastlines not for the industry. But here in Indonesia, let's see, if you look at all of the coastlines, the northern of Java Islands, the main islands, the most populated islands in Indonesia, they have 80% of industry across the coastlines. So we are not going to employ this one. Look at if you are going to talk about the Sumatra. Sumatra is unfortunate. This is not unfortunate, really unfortunate. This is built up across like a bit vertical, which is the area of the coastal lines is not as long as what we have in Java, because Java is a bit almost horizontal. So that's why the tides in Sumatra is not quite like potential. But the empty space on the coastal lines in Sumatra is larger significantly compared to Java. This is on the other way around. That is the more potential we manage not quite wisely, but the lack of the tides there. This is kind of the example when we need to mix up between one resources to the others. We need to take into account how do we arrange the space, the rooms. Um, let's say we need to organize our land, right? We need to organize our lands. What the kind of the resources, the renewable resources, wind or water, let's say hydro, power hydro, and the tides. We need to organize which lands it's supposed to manage as which. Otherwise, we lack of these things and we do nothing. We not generate electricity for our people. That's
Okay.
actually the most potential we can do.
Okay. So thank you for the response. So I think we can actually have just a quick final question for actually Dr. Satya. This is actually from Dr. Tata. Okay, so this is going to be the last question. So is there any real implementation technology or combination of solar cell in marine renewable energy?
Okay, thank you very much, Dr. Tata. So I think you're trying to ask of the hybrid, Nowadays we have hybrid renewable energy whereby we will put some floating, on the ocean or what. Then we include there one small turbine, and then we include there one small, solars, floating solars. So I think that's what you're asking about. But to share with you from my experience, in UTM, there's a center called Marine Technology Center. They have a few, I think 3 or more, floating of solar and also the wind and maybe wave. Wave uses the wave is a part of marine, but wind is not. Why? Because wind is not using the ocean water, so it's just floating. So they have come up with this, but to share with you, I mean, it's just on a small scale and so on. But further, why I asked about the wind just now to Dr. Harry also is because we are trying to do some study in the Java near the Jakarta there in that. But
Yeah, it's the south part of Java Island, right? Yeah.
So it's not facing the Java Sea, right? It's the Indian Ocean.
Yeah, the
part,
Indian
yeah?
Ocean. Yeah, the
Correct.
Indian Ocean.
And I just got to know that the wave there is from 1 to 4 meters, So incorporating that, there are some feasibility study that, from the customer or the industry side, they are looking at it. So that's where we are. So we need to do a pre-feasibility study before we can really, come up with the hybrid that you asked. So, yeah, but hybrid is still like a small scale. We don't really have a commercial, because lots of study has to be done. All right. Thank you, Dr. Tata.
Thank you. Thank you, Dr. Satya, for your insightful answer. So with that, I think I would like to conclude the session today. And I would like to thank all the speakers for sharing your knowledge today to all the audience. So thank you for attending. So the next I will going to pass to Puan Nohariza. Okay, I think she has some announcement.
Thank you very much, Dr. Lim, for chairing this session. We will reach to the end of the morning session. On behalf of the local organizing committee, we would like to thank you to the speakers and viewers in today's session for their valued attention. I hope you found this to be informative and useful session. Ladies and gentlemen, now we would like to invite all speakers and viewers to switch on the camera and use the I-Bes 2022 virtual background for group photo session.
I'm so sorry. Can I use? I can't put the background. So sorry.
Okay, it's okay.
All right. I tried many times. I'm not quite familiar with the Webex, so I've tried many times, but I can't. Okay, thank
It's
you.
okay. It's okay, Doctor. So technical and cameraman of the day, please get ready and please give your best smile on the camera. With a count 1, 2, 3, smile. Another take. 1, 2, 3, smile. Okay. Inshallah, we will be see you again at afternoon session at 2 p.m. Malaysia time. Thank you and bye.
Okay, this is 1 p.m. Indonesian time, right? I need to
Yeah.
put in my mind that this is different times.
Okay. 2 p.m. Malaysia time.
Okay.
Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all speakers and viewers. Thank you for staying tuned with us in this virtual international symposium on biomedical, biorefinery and energy security through the WebEx meeting, Facebook and YouTube. My name is Nurhaliza Hamzah as your moderator today. Welcome to the sixth sessions of I-Bes 2020 on the topic of energy security. On behalf of the organizer, I would like to extend my warm welcome to all guests and speakers. Before we begin, I want to highlight a few important points for our event today. Please take a look at your chat box. In the chat box, you may find the guidelines for the WebEx meeting of I-Bes 2022 and also the attendance form. Don't forget to fill it in by clicking the link provided in the chat box. Most importantly, you can also find the program book for I-Bes 2022 in the link provided. Ladies and gentlemen, for your information, this afternoon will be divided into two subsessions and ended with a forum where question and answer will take place. All presenters are requested to stay on the WebEx platform until the end of the forum. If you have any question about I-Bes 2022, please get in touch with us through the chat box. Without further ado, allow me to introduce our chairman for this session. Associate Professor Engineer Technologist Dr. Ho Waishin is researcher and academician from Universiti Teknologi Malaysia. He is an expert in process system engineering and resource optimizations, where he applies numerical analysis and mathematical program to provide optimal solution. He specialized in the field of sustainability, including key research areas such as green energy, water management, solid waste management, and many more. His most notable work is his inventions of a novel optimization technique known as electrical system cascade analysis, which is developed into a software known as integrated distributed energy application software. His invention has won several national and international awards. He is currently developing a state-of-art building automation system that integrates conventional optimizations model with real-time automation system. Dr. Ho obtained his PhD in 2014 from UTM, and he has awarded the prestigious Commonwealth Scholarship to attend Imperial College London during his PhD. Dr. Ho's invention and research work has gained him numerous recognition, where he was awarded the Global Best Young Chemical Engineer in Research by ICAP in 2015. He is also awarded the Young Scientist Research Award by UTM in 2020, and in the same year was awarded as a National Young Scientist by the Ministry of Science, Technology and Innovation. It is my pleasure to welcome Dr. Ho Waishin to chair the session.
Okay, thank you very much, Nohaliza. So thank you very much for that kind introduction on the biography. So today I'll be the chair for this session. And first, let me share the list of presenters that we have. Okay, one moment. All right, so I believe this is the last session for this International Symposium on Biomedical, Biorefinery and Energy Security. And this is session number 6, if not mistaken, on energy security. And I'm the chairman, Ho Wai Shin, and the moderator is Ms. Nohaliza. Okay, for our first speaker, the plenary speaker is Dr. Ni Mazuzaro. And we have our next speaker is Associate Professor Dr. Zarina. Dr. Herlambang Setiadi and Dr. Nick Rumzi, Nick Idris. So their topic. Okay, so Dr. Ni Matuzaro will talk on the topic on efficient of biosurfactant production to meet the all industry needs. And then we have Associate Professor Dr. Zarina on the potential of carbon mitigation as the decarbonization strategy. Dr. Herlambang Setiadi on the multi-mode power oscillation damping for power system security. And Dr. Nick Rumzi on hybrid energy storage system for electric vehicle. So this is the first part of the session where we will proceed with the forum, and then we will have a short break. And when we come back, it will be the next session where we have Dr. Engineer Padmawati on biodiesel production by in situ transesterification of microalgae, Chlamydomonas and Stychococcus cultivated in technical grade media. Then we have Associate Professor Dr. Jasro Jamani on resilience control strategy in microgrid system with multiple renewable source. And then Dr. Mochamat Zaki on nano modernite design for support of producing bio-aviation fuel component. And lastly, Dr. Zurina on waste to energy in Indonesia. All right. So without further ado, I would like to invite our first plenary speaker, Dr. Ni Matuzaro. Okay, could you please share your slide? I'll stop sharing. All right. So, okay, first let me introduce Dr. Ni Matuzaro. So first of all, thank you very much for coming to this section. Dr. Ni Matuzaro, she received a bachelor degree in biology from the Department of Biology, Faculty of Mathematics and Natural Sciences, University of Air Langga in 1991, and a doctorate degree from University de la Méditerranée Aix-Marseille in France in 1998. So since 1992 until now, she has worked as a lecturer in microbiology in the Department of Biology, Faculty of Science and Technology, Universitas Air. In 2011, she was the chairman of the Biology Undergraduate Study Program, Department of Biology, Faculty of Science and Technology, University of Air. And in 2015 to 2017, she worked as a secretary of the Institute of Educational Studies and Development. Then in 2017 to 2019, she became the secretary of the Directorate of Education at Universitas Air. In 2019 until now, she has been the vice dean of the Faculty of Advanced Technology and Multidiscipline. And as well, she has been assigned as the research group coordinator of the Applied Microbiological and Biological Resources, the Research Center of Biomolecule Engineering. Research grant that she has received since 2001 until now includes RUT, Stranas, IPD, IPTEK, PDU, application of microbial formulas for fertility, organic waste treatment, and bioremediation of environment contaminated with hydrocarbons, pesticide, and heavy metals. And another grant is on the bioconversion of organic waste to biosurfactant production. So far, she has published her research result in various international seminars forum organized by Higher Education Institute in Indonesia, Malaysia, France, Germany, and in various international journals, and has obtained one national patent. She is the member of the Indonesia Biology Association, the Indonesia Microbiology Forum, and the ASEAN Network on Microbial Utilization. So with that introduction, I would like to now pass the session over to Dr. Ni Matuzaro for her presentation. Thank you very much.
Hello, Doctor.
Hello, Dr. Matuzaro, are you there? Well, sorry for the technical error.
Doctor, can you unmute your computer? Hello, Doctor. Doctor, can you hear me? Can you unmute?
You can hear me?
Okay, Doctor. I can hear you.
Excuse me, you can hear me?
Doctor, I can hear you, but can you change your slide to slideshow?
Excuse me. Now? It's okay?
Doctor, can you at your right, show the slideshow, Doctor, please. At the uh, right bottom at your slide.
Now it's okay?
Okay, all right, Doctor. Okay, thank you.
Excuse me. Bismillahirrahmanirrahim. Thank you very much for presenting me. My name is Nikmati Sahra. I'm from University. This afternoon, I will share with you about our research that supporting energy security. We go to the introduction. As it now that energy security is one of the pillars of sustainable development goals. All efforts that can support efficiency in the oil industry will certainly support energy security. Biosurfactant is commonly known as a green product that has the potential to be used in the petroleum industry. Biosurfactants are amphiphilic compounds synthesized by several microbes like bacteria and fungi. And the characteristic biosurfactant is it has low toxicity, biodegradability, and stable in temperature, pH, and salinity of protein. You know that biosurfactant have been proven to be play a very important role in various activities in the oil industry, like it can facilitate action, it can increase gradation. Also, it can be used to clean deposit in oil storage tank. The full fulfillment of price of the needs in Indonesia still depend on imported products. And demand for biosurfactant from the oil industry tends us to be able to provide biosurfactants that are effective, efficient, and environmentally friendly. And ladies and gentlemen, of course, of domestic biosurfactant will help support energy security in Indonesia. And
The research group of the applied microbiology and bioresearch technology as a part of the research center of biomedical engineering, we call it Biomed, Universitas Langga, has made the topic of biosurfactant as one of the focus of the research area. We have started research on the biosurfactant. We have started research on biosurfactant and the role in supporting the oil industry since 2000 until now. This activity includes exploration of potential microbes using biosurfactant and hydrocarbon degraders, and potential testing and effort. Now, we will inform you in general that we have done. We have carried out various studies for efficiency effort in disinfectant production, included installation of local bacteria producing biosurfactant, optimizing of biosurfactant production through exploration and use of substrates from agriculture waste, optimization of conditions where biosurfactant product produced biosurfactant. Several genera of these potential bacteria, including Bacillus, Acinetobacter, Pseudomonas, Achromobacter, and several bacteria are still being identified. Additionally, in providing substrate for biosurfactant production is carried out by utilizing biomass from agricultural waste, which was previously categorized into sugar media, which is ready to be used for biosurfactant production media. The following is an example of biosurfactant production from isolate PP15 using agriculture-based hydrolysis media. We also carry out an enzymatic hydrolysis process using enzyme salt from Indonesian indigenous fungi, such as penicillin and aspergillus. These substrates are chemically purified first to assist the enzyme from to access an enzyme hydrolysis process by fungi. The result of this research using various substrates made from hydrolysis of agriculture waste products have obtained a potential source of substrates to be used as medium for biosurfactant production. The type of sugar determine the year. The type of substrate determine the year sugar came from. This picture shows the hydrolysis product of rice straw and corn from penicillin, which are simple sugar. We use standard sugar such as glucose, glucose, and fructose. Each microbe has a different enzymatic potential, which is indicated by the type of sugar produced. When then we then convert the hydrolysis from agricultural waste into biosurfactant using various types of potential bacteria that we have, such as Bacillus, Micrococcus, and Achromobacter. We use molasses as a control medium. We evaluate the production of biosurfactant from key suspension value through product yield to get the CMC value. The following is the result of biosurfactant production from Achromobacter antioxidant using contact hydrolysis as a substrate on rice straw. We also test the stability of the biosurfactant activity at the various pH, temperature, salinity variation to reveal its application process. This image shows the biosurfactant product Bacillus subtilis 3TP using contact hydrolysis and its stability test of variation in pH and temperature. We optimize the production by using various types of carbon source, like soluble and insoluble substrates, and variation of nitrogen source. The following table show the result of optimization of biorefinery production in open bacteria, which we compare with the result of other research. We also try to extract biosurfactant products using various methods, such as precipitation of ammonium sulfate, zinc sulfate, acid precipitation, acetone precipitation, until the utilization of organic solvent. The result shows that the extraction method determine the yield and the characteristics of the surfactant product, which is indicated in CLC value. We have also tested the potential of biosurfactant to be used in oil and battery. The test was carried out in a laboratory scale using a variety of biosurfactant formulation and methods with a synthetic surfactant. Repeating is a concept. The results are shown in the presentation of oil recovery and oil removal. Ladies and gentlemen, the combination of potential oil degrading microbe with the addition of hydrolyzed media from agricultural waste, such as rice bran and corn, has also been effective, helping increasing the degradation of hydrocarbon or oil. This is a very effective to support efficiency in bioremediation in polluted environment as a result of oil industry activity. These various activities that we are carrying out for the efficiency of biosurfactant production to its application are hopefully able to meet the needs of the oil industry to realize energy security and efficiency. Finally, the conclusion is the microbe and the biosurfactant produced by microbe can contribute significantly in supporting the implementation of the sustainability of energy for energy security. The results of our research are published in various scientific research, scientific articles, and in conference forum. This is our presentation. I hope to provide information regarding the activities we do that may have the opportunity to collaborate together. Here, our team that supports biosurfactant research in Langga University. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Nimatu Zaro, for that very insightful presentation. All right, so we will not be doing a Q&A for now because we will have the combined Q&A session later as a forum. So again, thank you very much. And I will proceed on with the next presenter. All right, so thank you. Okay, for the next presenter, Dr. Zarina. So I would like to request that if you can share your presentation slide on the screen. All right, so thank you very much. Okay, Dr. Zarina Abdul Muiz is a senior lecturer and director of Process System Engineering Center, Prospect of Universiti Teknologi Malaysia. She received her bachelor degree in chemical engineering from University Science Malaysia, master in advanced process engineering from Loughborough University, and PhD from UTM. She specializes in process planning, scheduling, modeling, simulation, and optimization. Her research activities are focused on low carbon society, climate change mitigation strategy, renewable electricity generation, and renewable energy distributed energy generation, DEG. She has won numerous international and local awards such as INATEX, MPE, and a national award during Seoul International Invention Fair and multiple research grants. Dr. Zarina is a registered electrical energy manager awarded by Suruhan Jaya Tenaga. She is also a certified energy manager awarded by ASEAN Energy Management Scheme, and she is a registered engineer with the Board of Engineers Malaysia and graduate member of Institute of Chemical Engineers, ICHEME. So without further ado, I would like to invite Dr. Zarina to deliver her speech entitled, Potential of Carbon Mitigation as an Energy Source and Decarbonization Strategy. I'll pass the session to you.
Okay, thank you very much, Associate Prof. Dr. Muaishin. Good production of me, introducing of me. Okay. Right. So Assalamualaikum and good evening, everyone. Okay. I'm Associate Professor Dr. Zarina Abdul Muiz, okay, Director of Process System Engineering Center, Prospect, UTM. There are some changes in my title. Okay. So I will present on the potential of carbon mitigation as an energy source and decarbonization strategy. Okay. Right. So what is carbon mitigation? Okay. So carbon mitigation is actually part of the carbon capture, utilization and storage strategy, where carbon mitigation is fall under this utilization part. Okay. So this is how it looks. Okay. The carbon from the source will be captured. Okay. And then it will be compressed. Okay. Transport, and then either we utilize or store it. Okay. So this is one of the initiative for this for the decarbonization. Okay. To reduce the carbon emission. Okay. Right. So carbon capture, utilization and storage, CCUS, also referred to as carbon capture, utilization and sequestration. Okay, so it's a process that capture carbon dioxide emissions from sources like coal-fired power plants and either reuses or stores it, so it will not enter the atmosphere. Okay. So the carbon dioxide storage in geologic formation includes oil and gas reservoir and deep saline reservoir. Okay, so I'll explain later the term for that specific strategy. Okay, structures. That one is, we call it the structures that have stored crude oil, natural gas, brine, and carbon dioxide over millions of years. Okay, so why we need to reduce the energy emission. Okay, so I just browsed this news on the 19 June, 2 days ago. Okay, glacier kiamat di Antartika mencair lebih cepat, or English version. Okay, the glacier kiamat is referring to two biggest glacier in US. Okay, the one is a Florida size glacier. Okay, they call it Doomsday Glacier, and the other one is Great Britain size. Okay, so the ice, okay, melting, okay, at the fastest rate in 5,500 years. Okay, because of the global warming and the rising of the sea, the temperature, sea temperature, okay, global temperature. Okay, so this one of the effect of the carbon dioxide, one of the greenhouse gas in the world. Okay, so so emission of carbon dioxide can be divided into two categories, so which are stationary and non-stationary. Okay, so the stationary source are a point of large CO2 emission, which provides significant and realistic chances for reduction of CO2 emission. So the non-stationary source, for example, from transportation, for example, cars, lorries, and so on. Okay. So the large stationary sources are mostly from heavy industry, such as power plant, cement industry, iron and steel industries, refinery, petrochemicals, and gas processing plants, which contribute to more than 60% of the total stationary emissions. So this is according to Hassan et al. 2015. Okay. So if there is no initiative on the emission reduction, so the total carbon emission from industry may project up to 90% by 2050 compared to year 2007. Okay, so this is according to International Energy Agency. Okay, so in view of this situation, carbon capture, utilization and storage (CCUS) technology is a promising strategy for decarbonization. Okay, but there are some drawbacks in terms of economic and environmental. Okay, so take a look later. Okay, so this CCUS technology scheme is basically capturing or collapse the CO2 emitted from industry, transport, and transport it to the location where it can be utilized or being stored underground reservoir for sequestration. Okay, so this is according to Styring 2011. So selection of the right technology for the right sources is crucial in order to ensure the implementation of CCUS is cost effective. Okay. So for this presentation, okay, so I'll just focus on the CO2 utilization specific to the methanation. Okay, so the carbon dioxide can be utilized for the enhanced oil recovery and enhanced coal-bed methane recovery. So EOR, the enhanced oil recovery, was implemented in oil and gas industry, where they inject the CO2, the pressurized CO2 to the oil well. Okay, and then sorry. Okay, number two, carbon dioxide as a raw material for chemical and fuel production. Okay, and CO2 can be used for mineral carbonization and for microalgae source biofuels. And the last one is methanation. So what is methanation? Okay. So methanation is a chemical reaction that converts carbon monoxide or carbon dioxide, okay, or we can call it COX, okay, to methane, okay, through hydrogenation. So the process for converting this COX to methane, okay, across the Sabatier reaction was proposed by Paul Sabatier and J.B. Sanderson in 1902. Okay, so right. So methanation can be performed like this. So this is the stoichiometric equation, okay, for Sabatier reaction. So the hydrogen can so it's a reaction between carbon monoxide or CO2 or carbon dioxide with hydrogen. Okay, will produce methane. So carbon dioxide we can capture from industry or from any stationary source, right? We can capture abundant of CO2. But where can we get hydrogen? So hydrogen can be produced from various types of resources such as fossil fuel, renewable energy, and so on. Okay. But the simplest technique to produce hydrogen is via hydrolysis of water. But the drawback is this process is energy intensive. Okay. So where okay, so we will see later on. So what will be the alternative for for these energy resources? Okay, right. So these are the advantages of CO2 methanation. Okay, so carbon dioxide could be better utilized and transformed into storable chemical energy in the form of methane. Okay, reduce carbon dioxide emission, decarbonization, and this energy can be stored. Okay, so the issues that can be catered by the methanation, CO2 methanation. Okay, so in Malaysia particularly, we have large amount of carbon dioxide produced annually from energy sector, transportation, and industrial sector. Okay, right. So this CO2 can be utilized, okay, to and convert it to energy back. Okay, so the methanation of carbon dioxide is not really feasible due to expensive production of hydrogen because it's energy intensive process. Okay, so to cater for electricity demand for hydrolysis, it is proposed to generate electricity from renewable sources such as solar and biomass. Okay, so for your information, our center, Process System Engineering Center, so our research basically modeling, optimization, simulation. So only a few of us done what we call it, the experimental part. Okay, so in this presentation, so I'll touch only the how we can optimize and how we can get the optimized energy source technology for hydrogen production to be consumed in methanation for CO2 utilization. Okay, so the scope of this part is the technologies involved in hydrogen production. What are the technologies involved? Okay, the optimization. Okay, for the optimization part, okay, a mathematical model was developed, and we convert the mathematical equation to um, uh, GAMS coding. GAMS is General Algebraic Modeling System, the optimization software that we use. Okay, and then we perform the sensitivity analysis. Okay, to analyze technical performance with the target of minimizing cost. Okay, so what would be the least cost? Okay, the minimum cost for this CO2 methanation. Okay, right. So some of the literature review conducted about the CO2 methanation. Okay, some of the thermodynamics. Okay, so the CO2 methanation is exothermic reaction. Okay, and these are the okay. We also conduct the several type of catalysts. Okay, but after some review, okay, we choose to use nickel. Okay, because of high activity, selectivity, and stability. Okay. Okay, the price also reasonable, and the operating temperature 500 degrees Celsius to 700 degrees Celsius. Okay, we also review some type of reactors. Okay, and the production of hydrogen. Okay, what type of electrolytes and so on. Okay, okay, and then hydrogen production technologies. Okay, so we conduct as well this type of technology, okay, different type of technology available to produce hydrogen. Okay, as I mentioned before that we choose the water electrolysis. Okay, because of the benefits of the this technology. Okay, no pollution with renewable energy sources. Okay, existing infrastructure, clean energy. Okay, and integration with fuel cells. Okay, so these are the research methodology. We collect relevant data. We develop the superstructure. Okay, develop the model, and then analyze the results. Okay. Right. So some of the data that we collect, okay, cost of technologies include capital cost, operating and maintenance cost, and we consider as well the efficiency of the technologies. Okay, model was developed, and then uh, key into the GAMS software, and we analyze the result. Okay, so this is the superstructure for mathematical model. Right, we consider three types of renewable energy: solar, biomass, biogas, and as well as the grid. Okay, so so the grid as a backup if solar, biomass, and biogas cannot fulfill the demand. And as you know that solar and biogas is intermittent, right? The production of electricity from solar and biogas is quite fluctuate. Okay, so that's why we need to have backup from the electricity from the grid. Okay, so we also put in our model type of solar panel, different type of solar panel, different type of residues, okay, different type of waste, and so these are the type of details, type of each renewable energy as well as the grid. Okay, so this hydrogen, okay, the hydrogen generated right from electrolysis will react with CO2 from palm oil mill. Okay, so in this case, okay, this is the first case study lah. We plan to capture the CO2 from the palm oil mill, or I would call it the biogas upgrading, biogas upgrading, where we turn all the biogas consists of methane and carbon dioxide. So we need to separate the carbon dioxide and convert carbon dioxide to methane, right? Okay, so can get high purity of methane. Okay, so this is the study that we did. We back calculate, okay, using mass balance, okay, to estimate how much CO2 produced from the FOME, okay, from the biogas comes from FOME. Okay, we calculate only a few percentage, okay, of CO2 that we capture and utilize. Okay. So this is the type of catalyst for CO2 methanation, and we include this as well, the conversion of the catalyst for CO2 methanation, the parameter for methanation process, okay, parameter and calculation for solar panel required, okay, and the economic parameter as well as the reference where we get the data. Okay, so this is the result. Okay, right. So the result shows that electricity generated mostly from the palm oil residue. Because of what? Because of this, the case study is palm oil mill. So the palm oil residue, you can get the what we call it, the raw material free, okay, from the palm oil mill. I mean with the assumption that the palm oil mill self-generated this, the self-generated the energy from renewable energy, which is particularly from the palm oil residue. Okay, right. So we also can perform this carbon CO2 methanation, okay, in the power plant. Okay, so that's what TNB research done. They have the pilot scale methanation, okay, carbon methanation pilot scale. Okay, so they integrate the carbon methanation with the power plant. Okay, right. So this is the strategy for the power plant. Okay, there are a few renewable energy that we can consider. For example, solar, floating solar, because the power plant is near the sea. Okay, so different type of renewable energy that we need to consider. So different case study, you need to consider different type of renewable energy. Okay, just show you the. Okay, so this is the general model for GAMS, okay, general mathematical model. So you need to have the objective function as well as the constraints. Okay, so this is the superstructure for the specific case study, the power plant. Okay, okay. So these are the cost, the objective function actually. Okay, so this is the objective function for the model. Okay, cost of electricity generation plus increased cost due to capture and storage. Okay, and minus offset to cost of electricity. So you will get net cost of electricity. So your objective function, you need to minimize the net cost of electricity generation. Okay, so some of the publication. So this one is not related to the CO2 mitigation, but this one is the energy planning, okay, electricity planning. Okay, for CO2 capture, we also have the published a few papers, okay, for the CO2 capture, okay, using computer aided approach. Okay, for utilization, okay, we have the publication and other publication as well. Okay, so for the conclusion, okay, CO2 mitigation is one of the strategy, okay, to reduce the CO2 emission as well as one of the promising source of energy. But somehow we need to investigate further, okay, to wait whether this CO2 mitigation is economically viable or not. Okay, because of the energy intensive as well as the cost of, you need to consider everything, all costs, okay? The operating maintenance cost, capital cost, as well as the catalyst cost and so on. Okay, so I think that's all from me.
All right. Thank you very much, Dr. Zarina, for your great presentation on CO2 mitigation. So I believe there's a few questions for you, but we will do that in the formal session later. So without further ado, I would like to invite our second invited speaker, Dr. Helembang Setiadi. He has received his PhD from the University of Queensland, Brisbane, Australia in 2019, and Bachelor of Engineering and Master degree from Institut Teknologi 10 November, Surabaya, Indonesia, and Liverpool John Moores University in UK in 2014 and 2015 respectively. Currently, he is a lecturer at Faculty of Advanced Technology and Multidiscipline Universitas Air. He is also investigator at Institute for System and Computer Engineering, Technology and Science, InsecTech in Portugal. Okay, so InsecTech, he's working on analyzing microgrid stability with renewable rich power plant, and his main area of research interests are small signal stability in power system, RE integration, dynamic system simulation, control system, and application of meta heuristic on power and control system. So based on his research, he has published over 75 articles. So with that, I would like to pass the session over to Dr. Helembang. The floor is yours. Okay, Dr. Helembang, you may share your screen as well for the presentation.
This is my first time to use Webex, so I could try. Did you see my screen now?
Yes, perfectly.
Okay, thank you very much.
Welcome.
Okay, thank you very much for the chance. So my name is Helembang Setiadi. I'm from Universitas Air. So it's an honor for me to be here to present our research. So our research is about multi-mode power oscillation damping for power system security. So before we talk about power system security, let's see about this graph. So as we can see in here, this is the renewable energy map for 2050. 50%, 58% will be used as a power electricity. So it will be used at the power plant. And then one of the interesting thing in here is solar PV and wind. They have percentage, really high percentage for renewable energy application. So solar PV like 55% and wind is 24%, which is really high. So mostly in my talk, I will talking about the integration of this solar PV and wind. So our focus will be only in solar, the impact of the solar PV and the wind. Okay, so yeah, solar PV and wind has a really good advantages in providing electricity with clean and sustainable energy. As we know that wind is always there and sun is always there, so it's always renewable, and uh, there is no negative impact in the in the system in the environment. Then, because they can provide clean and sustainable energy, they can reducing the impact of reducing greenhouse gas effect. However, although they can provide clean and sustainable energy, they have disadvantages. The first disadvantages is uncertainty of the sources. As we know that the speed of the wind is always changing. Every minute, every second, every hour, they always change. Similar with the sun, they not always there is not always sun. Maybe it's that this day is cloudy or not. Because of that, the power output of the power plant itself is intermittent. It's not stable stable power. They cannot provide stable power. That's one of the problem. The other problem is lack of inertia. So when we see about thermal power plant, like conventional power plant, we know that there is a synchronous generator in there. There is rotating machine in there. But wind and PV, they don't have that rotating machine. Although wind have that rotating machine, but there is an interface between the grid and this type of power plant. So to make electricity from the sun and the wind, they wind and PV need power electronic devices as an interface between the grid and the sources itself. These power electronic devices have the characteristic of lack inertia, so they don't have any rotating machine, so they don't have inertia. So when we talk about uncertainty of the source and inertial characteristic of this wind and PV, it will lead to instability of power system. When we talk about instability of power system, is the stability itself is how the power system can maintain stable operation. So when they stable, they will giving reliable power to the consumer. But if they cannot bring a stable power, then this power system is not reliable. So when the consumer like government need a reliable power system, they cannot provide it. So stability is one of the important things. So to see, there is three different stability aspect in power system that need to be achieved. The first one is frequency, rotor angle, and the voltage stability. In my talk in here, I will talk about rotor angle stability specifically in small signal stability. Why? Because when we talk about uncertainty, the uncertainty of wind and PV can be handled by adding energy storage. But how about the lack of inertia? The lack of inertia can bring negative impact with the rotor angle as well as the frequency. But there is no solution of that. For this particular problem, I will talk about how to handle the impact of low inertia in rotor angle stability. And then rotor angle stability, there's two different types. The transient stability, and small signal stability. And our focus in small signal stability, because small signal stability is happen when there is a small disturbance such as load changing. So this is the small signal stability. Small signal stability is the ability of power system to maintain synchronization when experiencing minor disturbance, such as load changing, the simple one. Then, how to investigate small signal stability? We can investigate small signal stability by detecting dynamic behavior of power system. The dynamic behavior of our system can be described using differential and algebraic equations such as this model. Then from that, there is one specific thing that we have to do is modeling all the system into state space representation. From the state space representation, we can get the eigenvalue. The eigenvalue is one of the most important thing of small signal stability. Then from the eigenvalue, we can get frequency oscillation and damping ratio. One of point of small signal stability is the stable condition of the system achieved when all of the eigenvalue have a negative real part. So in the left half plane. Another standard is the minimum damping ratio. Should not less than 0.05 or 5%. Another standard is the settling time of the signal. So like when there is changing, how the frequency react when there is a load changing in the system. So the frequency has to go back to the steady state condition between 10 to 20 seconds or less than 10 seconds. That's the standard. So when we talk about dynamic, so we have to modeling the power system itself. So first one, this is the model for conventional power plant, which is about thermal power plant, steam power plant. Basically, this model is something like this. And then we also have to capture the dynamic model of the wind energy conversion system. When we see in here, there is a converter and inverter. This is the devices that make the wind power plant doesn't have inertia, because these devices will be interfaced with the grid. And then this is also the model of PV generation. So as you can see in here, there is a converter before they go to the grid. And then this is the battery energy storage model. Like I say that when renewable energy such as PV and wind is on the system, we should have battery energy storage to store and releasing energy when the PV and wind is not stable. This is our contribution. So as you can see, this is the controller that will provide damping to the system. This controller will be added to the battery energy storage, wind, and PV cells. What is special of this controller is this controller is resilience to any loss of signal failure and control failure. The reason why we are modeling this controller as a multi-input and multi-output. So when one of the signal is lost, the other controller can still work, or one of the controller is failure, the other controller is still working. And then this is the test system of my study. So we are using Java Indonesian Power Grid as a test system to simulate the impact of renewable energy integration. We are replacing one synchronous generator with PV, which is in the bus 4, and then adding wind power system in this bus. And the capacity is around 300 megawatt. Both of them is 300 megawatt, and battery is 100 megawatt. The controller is added to the battery energy storage, PV, and wind. This is the result. So the scenario one, which is Java Indonesian power grid with renewable energy. Scenario number two, using traditional oscillation damping. Scenario number three is using wide area power oscillation damping. And the black one, which is scenario 4, using our proposed method. As we can see in here, the highest damping is provided by scenario 4, which is our proposed method. We are validating this result by using time domain simulation, as you see in the below picture. In the both picture, we can see the black line will giving less overshoot and faster settling time. Then the damping result above is validated by using the time domain simulation. And then to see what is happened with the renewable energy output, we are trying to plot the result. As we can see in here, for PV, battery energy storage, and wind, scenario 4 has higher overshoot because they are supplying power. This is the power output. They're supplying power to the system higher than it should be because there is a load changing. So when they can provide more power to the system, or more power to the system, then the other power plant will work more easy. So this is the result for resilient test, which is there is normal condition, loss of signal, battery energy storage control failure, wind power system control failure, PV control failure, and anything, and etc. As we can see in here, although two controller in wind energy and BESS is fail, the damping is still higher than 5% or 0.05. Then the controller itself is resilient to any controller failure as well as loss of the signal. And then this is the result for increasing penetration of renewable energy. As we know that we are moving to more renewable energy, then we have to do some simulation to show that it is the power system is still capable to add more renewable energy and reducing thermal power plant. As we can see in here in scenario, when we see the scenario 2, when we are increasing renewable energy more than 40% of the total generating, the damping become negative. When the damping become negative, it means that eigenvalue it's become positive. When the eigenvalue become positive, it means that eigenvalue the system is unstable. And we can see the scenario 3, after 40%, the damping is below 5%, although it's not become positive, but below 5% is not acceptable for the standard. And as we can see, our proposed method with the scenario 4 can maintain the damping below 5%, even when the renewable energy is increasing until 50%, which is really good. 50% of the power generation is coming from renewable. So to conclude my presentation, from the case study, we know that the multi-mode controller can maintain satisfactory damping ratio even the presence of severe communication and control failure, as well as varying level of renewable energy penetration. The proposed controller was demonstrated to have no negative effect to the internal dynamic of the wind, PV, and BESS, as you can see in the output of the wind, PV, and BESS. And it is worth noting that the proposed multi-mode controller can increase renewable energy penetration in Java Indonesian power grid by up to 50%, which is really high. Thank you very much. That's all for my presentation.
Okay, thank you very much, Dr. Halambang. So again, we will proceed with the Q&A later on. So again, thank you very much. And we should proceed to the next invited speaker. So the next invited speaker we have is Professor Nick Idris. So Professor Nick Rumsey, he received his Bachelor of Engineering from the University of Wollongong, Australia, and Master in Power Electronics from the University of Bradford, and Doctor of Philosophy in Electrical Engineer from Universiti Teknologi Malaysia back in 21. Right, so Professor Nick Rumsey has professional membership as a senior member of IEEE, Power Electronic Society, Industrial Application Society, and a member Board of Engineer Malaysia. So far, he has numerous research fundings as principal investigator over several millions of ringgit. And he has so far published a lot of papers and have a site H index of 27. Okay, so without further ado, I would like to invite Professor Nick Rumsey to deliver his presentation on his topic. The floor is yours, Professor Nick.
Can you hear me now?
Yes, I can hear you.
All right, thank you, Dr. Ho, for the for the introduction.
Welcome.
All right, the title of my presentation today is Hybrid Energy Storage System for Electric Vehicles, and thank you for the organizing committee for inviting me to give this talk. I will try to limit myself within this 20 minutes time frame as much as possible. Okay, this is the contents of my presentations. I'm going to talk a little bit about why the interest of EV, the surge interest in EV globally, and then what are the problems of barriers of adoption of this EV globally as well as in locally in Malaysia, and the hybrid energy storage system, which is a technique or method which can be used to help to reduce the barriers of these adoptions of EVs on the road. Then I'm going to talk on how the energy management control strategy for this hybrid energy storage system, some results and simulation experimental results, and finally the final remarks. Okay, the main reason of this surge interest in EV in this time of perhaps a few years back is basically due to the environmental concerns, which is global warming and climate change. We know that burning fossil fuel produces huge amount of CO2, which is part of the greenhouse gas, which trap heat from leaving the earth. If CO2 is produced naturally by trees, then it's okay, because that trapped CO2 will sort of stabilize, regulate the temperature of the earth to a suitable temperature. But if this CO2 is produced too much, especially by man-made gas, greenhouse gas, which is CO2 here, then more heat will be trapped, which means that more than it's supposed to be heat trapped in the Earth atmosphere, which causes what we call the global warming. And this is sort of the graph which shows the rise of the temperature of the Earth's surface prior to the industrial era. Okay, starting from 1890, which is captured by 4 entities here, which gives almost the same result here. Prior to the industrial year, the temperature has, after the industrial year, the temperature has rise about 1.5 degrees Celsius. And it is confirmed that this rise in temperature, according to the IPCC, which is the Intergovernmental Panel on the Climate Change, which is a United Nations body, is caused by human. So what happened when the temperature gets hot? The ice melts, the sea level increase, and according to the IPCC, by 2100, the sea level might rise up to 0.6 meter, which is, I think, one of the reasons why Indonesia is shifting its capital from Java Island to Borneo, as what the press states says. Okay, and warmer oceans will cause the unpredictable weather conditions. Some part of the world will have droughts. Some part of the world will have ocean floodings, and so on. And this is what we call the climate change. If you look at the carbon dioxide emissions in Southeast Asia region from 1960 and 2020, which is obtained from statista.com there, you can see that the highest country that produces CO2 is basically Indonesia, as you can see there, followed by the rest of the countries within that Southeast Asia. But you cannot blame Indonesia because they have 280 million populations, all right, compared to the other countries like Malaysia. We only have 32 million populations. And if you look at the per capita emissions of CO2, in fact, Brunei is the highest per capita emitter, followed by Singapore, Malaysia, and Thailand, and Indonesia is not that bad. All right, so according to the International Energy Agency, the 27% of the global emission is coming from transport sector. And also according to a study in Malaysia, 28.8%, which is slightly higher than these global values, is coming from the transport sector, which is the land transport mainly. And in Indonesia, it is 27% of this overall CO2 emission is coming from the transport. So we have to do something about this. If you look at the interest of EV, it started all the way back in the 19th century where we have that golden age of, let me just initiate the laser point here, in 1912, but the reason for this surge of interest is different from the surge of interest which occurred around this 20th century here. The reason here is that the internal combustion engine is not that efficient. You have to manually crank the engine to start the engine for the internal combustion, whereas if you have a battery power car, then you don't have to do that. But then when the internal combustion engine is improved from 1924 to 1960, we can see a completely blackout of EV on the road here. Not until this 20th century here, where the surge of interest in EV is, you can see the surge of interest of EV again. And we can see that this is the second wave, and the third wave is coming soon here. All right, this is the second surge here is basically not because of the inefficiency of internal combustion engine, but rather because of the awareness on the climate change, global warming, and so on. And we have a slightly low interest in the EV here because of the hybrid electric vehicles, which is a combination of the interest in the hybrid electric vehicle, which is a combination of the internal combustion ICE and the electric pure and the electric battery energy source. And in fact, if you look at the trends of the registration or sales or share of markets of battery electric vehicles and plug-in hybrid electric vehicles, you can see the trend, especially in China, that mostly people are now shifting towards the full electric vehicle rather than the plug-in hybrid electric vehicle, which is, as I said, a combination of the internal combustion engines and the battery. All right, so what is the problems? In some part of the world, especially the developed country, they have pledged to completely ban ICE, which is the internal combustion engine, on the roads. This is basically led by Norway, which plan to completely ban ICE in 2025. And you can see that Iceland, Denmark, Ireland, Netherlands, even our neighbor Singapore plan to completely ban ICE in 2040, which is not far away from now. Norway, especially if you look at Norway, which is currently as of 2022 March, they have the number of passenger auto registration is 91.9% are electric vehicles and plug-in electric vehicles, by plug-in hybrid electric vehicles. And out of that, 86.1 is basically pure electric vehicles. So to have a target of 2025 to have a pure zero ICE on the road is not really a problem with Norway. But I think for us in Malaysia and Indonesia, it is far from reaching this target. And in fact, Norway, if you look at the electricity productions of Norway, more than 90% of the electricity produced is renewable energy. It's coming from the renewable energy sources, especially the hydroelectric. All right. From the consumer point of view, the problems or the barriers of adopting these electric vehicles on the road is because of the cost, which is mainly coming from the cost of the battery of the battery, as well as the cost of replacing the battery. There was some ideas of swapping the batteries, but it does not really work. That didn't go really well, which ideally can reduce the cost, but it didn't really work well. In fact, one of the company which pioneered in the swapping battery went bankrupt in 2013, which is Better Place, a company in Israel. And then there is another problem. What I'm trying to say here is that mainly the high cost of the electric vehicle, which can be as high as 30 to 40% higher than its counterpart ICE-based engine, is coming from the battery. Another problem is that the range anxiety, where people seems to not to feel that they will not reach the destinations by using the battery. And I think this has got to do with the another factor which is causing these barriers is the lack of fast charging stations which is available. If you have more fast charging station available, then this range anxiety can be basically removed. This range anxiety, in fact, nowadays you can see that for example, Tesla, for a full charge car can go as long as 500 kilometers. But if you can go 500 kilometers, but you cannot see a charging station, then you still are not happy with the electric vehicle. So this range anxiety problem and the lack of fast charging station basically is interrelated to one another. We need to improve on the battery capacity. At the moment, we have the specific energy of the lithium ion can go as high as 250, 260 watt hour per kilogram. And we need to have more fast chargers stations available in order to remove the anxiety problem, range anxiety problem. Now, what I'm going to show you next is that we can somehow reduce the barriers of these adoptions of electric vehicles on the road by introducing what we call the hybrid energy storage system, which basically helps to increase the lifespan of the battery, therefore reduce the cost of replacing the battery, and also improves the efficiency of the system by efficiently capture the braking energy of the car during the decelerations compared to the battery. And we are proposing to use in fact, we propose to use the supercapacitor as the second energy storage device because of its high specific power. If you compare to the batteries, which typically has 3 kilowatt per kilogram, the supercapacitor has about 10 kilowatt per kilogram. And the way that it is manufactured with activated carbon cathode, it has a very high capacitance, specific capacitance, which is about 250 farad per gram. And because of this high specific power, this supercapacitor can actually capture the braking energy more efficiently compared to the battery alone. And of course, the cost of the supercapacitor is much expensive than the lithium-ion batteries. But we are not going to use associate the supercapacitor with the energy which is very large energy, because we shall see later that this supercapacitor is basically just to use to capture and to release the energy during the braking and the acceleration. To understand the concept of this hybrid energy storage system, what I showed here is the architecture of the electric vehicle with and without the second energy storage or call it the battery electric vehicle and the battery hybrid electric vehicle, which consists the supercapacitor. This is a typical architecture of electric vehicle. You have a gear system, gearbox, the motor, and the converter, which is connected to the battery, and then we have the motor controller here. And then with the battery hybrid electric vehicle, which consists the supercapacitor, what we did, there are several type of architectures, but I'm using this architecture here, which uses only one power electronic converters, which is connected to the DC link via that bidirectional DC-DC converters. Okay, the challenge is therefore to control the energy flow and the power flow between that supercapacitor to this propulsion system here. Let's look at what happened during the decelerations in a battery electric vehicle. All the most of the power, in fact, not all, but some of the braking power during the deceleration will go to the battery, and and part of the rest of the braking power will be lost as a mechanical braking, because the battery alone will not be able to capture all the braking energy because of the limited charging current, and also to limit the stress on the battery. However, with the battery hybrid electric vehicles, or with the hybrid energy storage system, we have an option of capturing this braking energy to the supercapacitor, which is shown here, which means that the mechanical braking can be avoided, which means that more energy can be captured during the deceleration, which can be used later in the accelerations. And at the same time, we also reduce the stress of the battery, because we are reducing the high surge of current which typically flow in the pure electric vehicles without the secondary energy storage during the decelerations. And during the acceleration, what happened is that in the BEV, all of the power needed for the acceleration will come from the battery, which means that there will be high surge of current during the acceleration, which means that it will increase the stress on the battery, therefore reduce the lifespan of the battery. For the battery hybrid electric vehicle with energy with the secondary energy storage, this acceleration power will come as well from the supercapacitor. Okay, and because of the low internal resistance of the supercapacitor during the energy capture as well as the energy release during this acceleration will be more efficient, which means that you can effectively increase the travel range because of these efficient energy capture and releasing of the energy. And at the same time, you reduce the stress on the battery, which means that you can increase the lifespan of the battery, which means that you are reducing the cost of replacing the battery every 6 or 7 years. However, the main problem of this energy management control is to derive the suitable values of the supercapacitor power, such that it will not depleted at the end of the accelerations, or it can have enough capacity to capture the braking energy, right? There are many ways of doing this. In general, it can be classified as either rule-based, which can be further classified as either deterministic or fuzzy. And then we also have the optimization based. Optimization based, typically you require the route of the vehicle in advance, which means that it is not suitable for real-time applications. But there are some works on doing the real-time optimization, which is based on the model predictive control for the optimization base. What we are proposing, what we have proposed, and we have did here in UTM, done here in UTM, is the rule-based, which is based on the deterministic control strategy. There are two types of control strategy that we use to control this energy flow between the battery and the supercapacitor, what we call the name as the acceleration based and the deceleration based. And the difference is on how the capacitance of the supercapacitor is designed and how the supercapacitor reference current is generated. And this work is basically credited to Dr. Ari Wangsufapol, who is the PhD student, ex-PhD student in UTM under my supervisions, who is now working as a lecturer in Chulalongkorn University a couple of years ago. Now, let's look at the acceleration-based acceleration-based design. What we did here is we are trying to balance the kinetic energy and the energy stored on the supercapacitor. By doing so, we somehow correlate the speed and the capacity of the supercapacitor to ensure that, as I said earlier, that enough capacity is available during the braking to store the energy, and enough energy is available to accelerate the vehicle until towards the end of the acceleration period. There are two ways, therefore, of flow of energy, whether we base on the acceleration, in which the flow of energy is coming from the supercapacitor to the propulsion system, what we call the acceleration base, or the other type is the deceleration base, in which the energy from the propulsion system or from the moving vehicles, kinetic energy is stored back to the supercapacitor in what we call the deceleration-based design. Let's look at on the acceleration-based design first. Assuming that 75% of the energy on the supercapacitor is used to accelerate the vehicle, then we can equate the energy balance equations between the energy stored on the supercapacitor and the kinetic energy of the car, where the zeta total here represents the overall efficiency, which includes the efficiency of the power electronic converters, the batteries, and the electrical components, and including the internal combustion, the internal resistance of the supercapacitors, as well as the internal capacitor, as well as the efficiency of the motor drive systems. This is where the power from the supercapacitor flow to the propulsion system, and we do the balance energy balance equations here, in which from here we can actually calculate the roughly calculate the capacitance required to accelerate the vehicle. And in order to devise the control strategy, what we do is that instead of using the half of the maximum supercapacitor voltage here, which corresponds to 75% of the energy stored, we replace it with the instantaneous supercapacitor reference voltage. And instead of the maximum voltage here, we replace a maximum speed of the vehicle, which is SV there. We replace it with the instantaneous velocity of the vehicle. And from there, we can obtain the supercapacitor voltage, instantaneous supercapacitor voltage based on the instantaneous speed of the vehicle. And after that, we can obtain the reference current of the supercapacitor by differentiating the supercapacitor voltage with respect to time and multiplying with the supercapacitor capacitance of the supercapacitor, which we have calculated earlier. From there, we obtain the reference of the current reference of these for the supercapacitor. And how do we implement this? Before that, let's look at on the deceleration base, which is the opposite to that. As I said earlier, now the power is flowing from the vehicle to, or from the mechanical side to the energy stored on the supercapacitor, which means that the efficiency of the system, including the mechanical efficiency, now is on the mechanical side of the equations here. From there, we can derive the supercapacitor, and using the similar approach, we can also derive the reference current for the what we call the deceleration-based design. How do we implement that? We have these existing motor drive systems, and what we actually add is that we have a DC-DC converter here connected to the DC link of the propulsion system. Via this DC converter is the supercapacitor here, and the control of the current of the supercapacitor is performed using the closed loop current control system. And since the system is nonlinear, to obtain the to properly design the PI controller here, we need to average and linearize the power electronic systems, and from there we can provide the closed loop current control of the supercapacitor, and in which the reference current is obtained basically from the speed of the vehicle, as I've shown you earlier. We've done some simulation work on the actual scale of the vehicle, which is based on the electric vehicle that we have in our lab, which is basically a conversion from the Proton Saga shown here. We use the parameters of these converted vehicles, which with the mass, the aerodynamic drag, frontal area, and so forth, and so with the maximum speed that can go as high as 120 kilometers per hour there. assuming the mechanical efficiency of about 94%. And these are the calculations which is based on the energy acceleration based ABD and DBD. For the battery bank here, we are using the lithium ion. We are assuming a lithium ion with voltage of 240 volts. And then this is the supercapacitor that we have calculated using the ABD and DBD. As you can see that the capacitance is about 54 and 32 farad, which means that the energy associated with the supercapacitor is very small as compared to the about 24 kilowatt hour energy associated with this battery, which is less than 1 kilowatt hour, which means that even though the cost of the supercapacitor is high, but we are using a very small amount of energy to store to the supercapacitor, which means that the cost is not that really a problem. The speed, we simulate the system using the European driving cycle. These are the results for the battery alone. The battery alone, which is shown in the red here, and then we have the reference speed here for the European driving cycle, and then we have the battery hybrid electric vehicles, which is either ABC or DBD. There is not much difference in the speed response except for the battery alone, and where we are assuming that we are not applying the mechanical brake here, which we can see that because of the limited amount of charging current to the battery, then we cannot capture all the energy during the braking, which means that the pure electric vehicle without mechanical braking will just be coasting to reduce the speed here. This is the battery for the ABD, the supercapacitor current for the ABD compared to the DBD. You can see that a slightly higher in ABD compared to the DBD. Because of the acceleration base, but this does not mean that DBD is perform worse than the ABD, because in order to maintain that supercapacitor voltage, you require to charge the supercapacitor, and in DBD that charging the supercapacitor is coming from the battery. We'll see that later on. This is the variations of the yes.
Sorry, Prof. Interrupting. You have 2 minutes to
All right.
complete
I
your
will wrap up.
presentation.
I will
Thank
try. Yeah,
you.
I'll try to
Sorry.
wrap up in that 2 minutes. So this is the variations of the voltage of the battery, and this is the variation, the battery, the current battery for DBD and ABD. As you can see that the variations for the BHEV, which is the hybrid electric battery hybrid electric vehicles, is less than the pure without the supercapacitor, as well as the current for the ABD and DBD is less. And as you can see that for the ABD, the current to charge to maintain the voltage of the capacitor is higher, which means that more current is drawn from the battery here. And finally, this is what we want. We look at the energy consumptions of the ABD and DBD. We can see that the final energy consumptions as well as the battery voltage variations is shown here, and the best option is to use the DBD rather than ABD, which is much better than the battery alone without the supercapacitor. We also done simulations using the UDD as a driving cycle, which is shown here, and the result is basically have a similar pattern to the European driving cycle. And we also perform some work on laboratory work to verify the feasibility of our control scheme. However, the result is not that good because of the higher internal resistance of the supercapacitor and the battery. And the battery that we use in the lab is not the lithium ion, but rather it is a lead acid batteries, which gives a different results. Nevertheless, we are now working on the actually implementing the HESS to the actual EV in our lab instead of just using the laboratory scale experiment that we've done previously. This is the results that this picture of the laboratory scale setup that we use, and these are the results that we obtained. As you can see that the result is not that encouraging or not as similar trend it's not having a similar trend to the actual scale simulations because of the higher internal resistance of the supercapacitor and the battery. Final remarks. Such interest in EVs is basically due to the awareness on the global warming and the climate change, and there are barriers to the EV adoptions in some part of the countries, including Malaysia and Indonesia, I think, due to the cost, travel range, and lack of charging infrastructure. We can somehow reduce this barrier by introducing the hybrid energy storage system with proper control strategy, which basically increase the travel range and reduce the stress on the battery, which can reduce the cost of replacing the battery. And some simulation results, which is encouraging result, is shown here or presented just now. And as of now, we are actually in the stage of implementing this hybrid energy storage system to the actual electric vehicle that we have in our lab. And we always welcome collaboration with Universitas Air Langga, Indonesia, for this research area. And these are the, if you are interested in looking on our research area or research field, you can always visit our group, Powertronics and Drive Research, which is shown here. And that's, I think that will conclude my presentation. Thank you.
Okay, thank you very much, Prof. Nick Rumsey. Yeah, so please stay on with us in the session, because now we will move on to the forum session. So I would like to again invite all the previous speakers, Dr. Ni Matuzaro, Associate Professor, Dr. Zarina Abdul Muiz, Dr. Helambang Sediati, as well as Prof. Nick Rumsey. Okay, so I would like to invite all of you to the forum session. Right, so can we have everyone's screen there? Nurhaliza?
Okay, Rata, hold on.
Yeah, sure, no problem. Okay, right. So we have everyone here, so that's great. Yeah, so the forum, we will be asking some questions. So I'm now looking at the chat. Okay. All right, I personally have some questions. So maybe I will start with the first presenter, Dr. Ni Matuzaro, right? Doctor, you mentioned about biosurfactant and to meet the oil industry needs. So we are in the chapter on topic on energy security. So could you elaborate a little bit in terms of the oil industry? How are they able to reduce their energy? Is that what you're trying to say when they are using the biosurfactant?
Yeah, thank you, Dr. Hu Wai Chin. You hear me now?
Yeah, I can hear you.
Okay,
Thank you very much.
You know that the oil industry, normally there are many activity, right? First, how the oil industry can obtain more oil, and biosurfactant can help to increase the oil recovery. And normally, oil industry use the synthetic surfactant to aid the oil recovery from oil well. And now, several kind of company try to change to find the alternative, the synthetic surfactant. They use the biosurfactant. This is very important. So if we can keep the solution, the biosurfactant as an alternative surfactant synthetic, of course, it can reduce the cost for oil recovery. That is the first. And the second is normally, actually, in the oil industry, their activity feel the pollution caused the activity oil industry. The bioremediation is the one thing that we must find the solution. And actually, it's commonly known that the bacteria that produce the biosurfactant can help the degradation hydrocarbon in oil contaminated soil. So if we obtain the formula, the brief or excellent formula, it can decrease the cost to remediate the environment. So how to reduce the cost, how to increase the activity of bioremediation, it can actually can support the energy security, I think. Yeah.
All right. Okay, so which means in summary, I could say with this biosurfactant, they are not only improving the efficiency of for them to extract the oil, but
Yeah.
the environmentally costs, everything can also
Oh,
reduce. Right?
yes, that's
Well,
right. Yeah.
yeah, thank you very much for the answer.
Thank you. Thank
Is there
you.
the other panel, the other speaker, would you like to ask any question to doctor? All right. Okay. If not, if I have another question, I will ask again. Maybe I can ask Dr. Zarina. Okay, Dr. Zarina, you mentioned about methanation, right? So I believe from your presentation and also from the model that you have presented, and if your model could generate a result, which means it is actually a good option to go for methanation, right? But I do not see much industry currently is applying this technology. So maybe could you explain or explain a little bit in terms of what is the largest barrier? Why is the industry currently not applying it?
Okay, thank you very much, Dr. Ho. So, as I mentioned in my presentation, so the most challenging part is the feasibility or the cost of the technology. Okay, because the CO2 methanation is quite expensive technology. Actually, the NB research already developed the pilot scale of the CO2 methanation, and currently they are trying to find the most economical operating condition. Okay, so still in the I would say in the pilot scale study, but as far as I'm concerned as well, in US, for example, in Canada, they already implement this technology, even though it's quite expensive, but they already implement this because of the environmental awareness lah, because of the environmental issue. Okay, so maybe let's say if we can find the most we can reduce the cost of the process of CO2 methanation. So most probably we can implement that soon.
Yeah, or I would say because like for example, Malaysia, our electricity is cheap, so that's why it is not that implementable. Do you agree with that?
Yeah, I agree. I agree because of we our electricity costs still highly subsidized by the government, so it's not quite competitive now. Okay, to implement that CO2 methanation, even though it's a the it's a you can solve two issues in one solution. Okay, where you can reuse the CO2 emission, you can reduce the emission, and at the same time you can convert it to energy. Okay, so yeah.
All right. Okay, so thank you very much, Dr. Zarina Muiz. Okay, I have a question also for Dr. Helembang. So just now you mentioned about the power control for the solar PV and the wind, right? That one, I'm sorry if I have missed out on the presentation. Are you describing it for a standalone microgrid, standalone system, or is it a grid connected one?
Okay, thank you for the question. So it's grid connection. So the PV, wind, and energy storage will be connected to the Java Indonesian power grid.
Okay. How do you see? Because currently, yeah, a lot of study has been done indicating, battery could help to solve the intermittency and things like that. But again, similar to like what Dr. Zarina's question, right? Like the current state, we don't implement that technology yet. So why do you think that is the case? And when do you think that we will be starting to actually go for it in practice?
Okay, from the start, if we talk about Indonesia, grid renewable energy integration is not yet done. But when we talk about Australia and Europe, most of them has already integrating renewable energy such as PV and wind to the grid. And then there is a lot of study about what we call as inverter, grid forming inverter, which is that inverter-based power plants such as wind and PV can provide similar response, similar similar performance like conventional power plant. So what I have done in here is to developing some controller that can be used to that inverter based power plant to not only provide frequency control and voltage control, but also rotor angle control. So that's what we are developing, the controller for rotor angle stability. So when we talk about the frequency, it's all the controller is already there. Voltage is already there, and there is a lot of study about grid forming inverter. So we are our contribution is we can use another controller to make that grid forming inverters much better to mimic the performance of the conventional power plant.
Yeah, but this one it requires the battery is compulsory, right? For this,
Yeah,
to right. Okay. Yeah, I think because one of the main reason battery is still very expensive. If it could break the barrier in terms of getting the battery price down, I believe we could go forward as well. I think the similar case, right? Electricity is still subsidized. Maybe it's still cheap in Indonesia and Malaysia.
Yeah.
All right, cool. Thank you very much. Okay, so last question I have for Dr. Nick Rumsey. Of course, we also having the other session starting from 3:50, so we have another 3 minutes. Okay, Dr. Nick Rumsey, you presented about the supercapacitor to integrate the supercapacitor in the current EV, right? You mentioned that it can improve like the battery lifespan and things like that, but how about the supercapacitor itself? Would it be very expensive?
Yes, as I've said, can you hear me? Yeah, okay. As I
Yeah,
said,
thank you.
the supercapacitor itself is much more expensive than the lithium ion. I think we'll say about 10 times more expensive. But as I said, the energy stored or the energy capacity, the capacity of the energy that we are dealing here for this particular application is not that large. As I said, for example, for this particular actual scale simulation, we have 24 kilowatt hour for the battery, but for the energy which is used for this capacitor is just less than 1 kilowatt hour, which is much less. And this supercapacitor can be the cycles, the charging and discharging of this capacitor can be up to 1 million times, which is much more higher, which means that the lifespan of this supercapacitor is much higher than the lithium ion battery nowadays. So yeah.
Yeah, okay. All right, so means the supercapacitor, although it is more expensive, but we are not going to use a very big size of it. So
Exactly.
basically,
Yeah.
Okay. I have another question here from Mr. Camaro. So it says, other than the power from braking, is there another source of power that can be stored in the supercapacitor?
Other than the braking?
Yeah, other than braking.
I think the only power that can be stored as far as the electric vehicle is concerned is from the braking of which is the reductions of the kinetic energy, which is converting back to the electrical. But this type of hybrid energy storage system can not only be applied to the electric vehicle, it can also be applied to other systems, like, for example, the elevators. And we've seen these applications in the electric train, everything which moves, which has to deal with the motions in which we can convert the kinetic energy back to the electric. Then we can utilize this supercapacitor to capture that surge of power during this braking. So other than the braking power for the electric vehicle application, I don't see any other energy, any source of power which can be captured by the supercapacitor.
All right. So thank you very much for the answer. I also have limited time to ask you more. Actually, I have few more, but it's already 3:50, so we have to move on to the next session. So again, thank you very much to all our plenary speaker and invited speaker, and thank you for your time being here. All right, I'll see you again.
All right, thank you.
Thank you, Dr. Ho.
Thank you, everyone.
All right. So for the next section, we have another four speaker. So for the first speaker, I would like to invite Dr. Padmawati. Yeah, maybe Dr. Padmawati, you could share your presentation slide on the screen first. All right. So Dr. Padmawati, she is currently from, wait, give me a moment. Okay, she received her education from Bogor Agriculture University for undergraduate program, as well in the same university for master program as well. For her doctoral program, she went to Kyushu University, Fukuoka, Japan, to obtain her PhD degree. All right. Currently, she is the lecturer from the Fisheries Product Technology Study Program from the Faculty of Fisheries and Marine, Universitas Air, and she is also the chief editor-in-chief for the Journal of Marine and Coastal Science, as well as the coordinator of Planning and Development Board for the Universitas Air. Okay, so her achievement. Okay, she have won the best graduate of the IPB Master's Program in 2013 and the Brilliant Academic Achievement at the Aquatic Product Technology Graduate School of Bogor and S3 Chemical System and Engineering in Kyushu University. Okay, so without further ado, I would like to invite Dr. Padmawati to deliver her speech on biodiesel production by in situ transesterification of microalgae cultivated in a technical grade media. The floor is yours.
Okay, thank you, Dr. Hu. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. First of all, I would like to thank the committee for giving a chance as one of the speakers in the seminar. I would like also to thank to Dr. Hu for introducing me and give me the time for delivering my presentation. Today's topic is about the biodiesel production by in situ transesterification of microalgae cultivated in the technical grade media. So in this experiment, actually I used two kinds of the microalgae, namely Chlamydomonas and also Cyanococcosis sp. For the introduction, so as you know, the fossil fuel are cheap energy sources which have continued to meet wood growing energy needs due to the increasing of human population. On the other hand, the fossil fuel is believed one of the causes climate change. The climate change causes by the greenhouse gas emission and also greenhouse gas emission and also carbon dioxide emission. Especially it will be affected to the increasing of the temperature in the environmental. By increasing of the temperature in the environmental more than 2 degrees Celsius, it will be suffering 100 million people. They would lose their life and also lose biodiversity, as well as food scarcity, worsening health, and also poverty. The detrimental effect of this increasing the temperature in the environment, it will be increase of sea level and also extreme weather change. Based on the IPCC reported that emissions from fossil fuels are the dominant cause of global warming. In 2018, carbon dioxide emission sources came from fossil fuel and also industry. Therefore, fossil fuel as sources of energy should be replaced with renewable clean energy sources to reduce carbon dioxide and greenhouse gas emissions. In addition, according to Indonesian Ministry of Energy and Mineral Resources, that Indonesian oil reserve will be available for the next 9 years. with the national oil reserves of 4.17 billion barrels, with proven reserves of 2.44 billion barrels. This needs to be the constant in the future because human welfare is related to the future uh, because human welfare is related to the amount and quality of energy utilized in the modern life. So we need to alternative fuels that are renewable and environmental friendly to develop to fulfill global energy requirement and also demand. So one of the best candidates for sources of bioenergy is biomass. So we can see in this graph that biomass consists of two kinds. Firstly is conventional and renewable biomass. For the renewable biomass is divided in the different generation depending of the type of the feedstock. So first and the second generation of biomass include the food and waste such as rice, corn, sugarcane, jatropha, and we can see in this table that the currently major portion of biofuel is derived from especially palm oil, soybean, and also corn. So on the other hand, first and the second generation feedstock require a huge amount of land, relatively long growing time, and also competitive with world food production. Hence, the third generation feedstock, such as microalgae, is one of the best candidates to meet biofuel demand. So we can see in this table that microalgae is one of the potential sources for bioenergy. Uh, Microalgae production has a promising candidate for its higher oil content than oil crops. Microalgae also have a very high growth rate where it takes only few days to complete its entire growth cycle and also high photosynthetic ability compared to the plant. Microalgae also higher adaptability to different environmental situations and also no need a huge amount of the land. Moreover, if we can see in this schematic that microalgae can produce useful quantity like polysaccharide and also triacylglyceride. Both of the polysaccharide and also triacylglyceride is one of the potential sources for the transport fuel like biodiesel and also bioethanol. For you can see in this PPT that the production of the biomass for microalgae consists of three steps. Firstly is cultivation. We can use cultivation of microalgae by using open pond on or closed photobioreactor. The secondly is harvesting. We can use harvesting by using flocculation or centrifugation, filtration, and also flotation. The last step for the production of the microalgae biomass is dehydration. So for dehydration, we can use sun drying, spray drying, and also freeze drying. However, for the production of microalgae biomass is need 75% of the total cost of biodiesel production. Moreover, based on the quota and Sorgulus reported that microalgae production facility estimated to achieve for an average of 30% up to 60% of the total budget of the cultivation. So in this experiment, we use the cheap media using a technical grade because by using this technical grade media, we can remove the cost for cultivation to get the biomass of microalgae. Uh, For the production of the biodiesel from microalgae, there are such any problem like we need several steps for converting biomass to biodiesel. For converting biomass to biodiesel, we need to extract lipid from biomass, and also we need to convert lipid to fatty acid methyl ester. Both of the process need energy, the high energy consumption. So we need to find way to producing algal biomass with removing the cost and also time effectivity. So in this experiment, so we use in situ transfer esterification. So we can see in this PPT that for conventional transesterification, we need extract lipid, and then we convert the lipid by transesterification to become fatty acid methyl ester or biodiesel. But by using in situ transesterification, we can eliminate the extraction of lipid and also drying step of the oil after drying step of solvent after the extraction process. So from this information that in situ transesterification process proved to be fast and easy in biodiesel production from dry biomass. So this is the object study. In my research, we observe of biodiesel production by in situ transesterification of microalgae from two kind of microalgae, Chlamydomonas and also Cyanococcus sp with chief culture media. So in this research, we have three steps. Firstly is rejuvenation and preparation of isolate. The second step is production of biomass from microalgae. So the last step is the production of fatty acid methyl ester. So for first step, we have four species of microalgae. First species Cyanococcus sp, ICBB 9111, and three species of Chlamydomonas 9112 until 9114. For rejuvenation and also preparation of stock culture media, we use the basal media BG11 on the scale lab media by using source of light lamp. Source of light is lamp. Yeah. After finish this step, we then use this stock culture media for the next step. So stock culture media from the previous step, we use cultivation. We use as we use for cultivation in the certain media. We have three kind of technical grade media here. So we culture this microalgae in the aquarium, but sometimes we also use raceway to culture all of the microalgae. So after the reach optical density 0.5, it means at the beginning of the stationary, we harvest this microalgae to get biomass. The harvesting of microalgae, we use the flocculation and also we use the filtering. We use harvesting of biomass by using flocculation and also filtration. So with biomass we get, then we drying at 80 degrees Celsius for 24 hours, and dry microalgae we then analyze by proximate content, and also we calculate the yield. The base microalgae, the base condition from this step, we then use for the stage 3 the production of the biodiesel by in situ transesterification. This process, we use the methanol and also calcium hydroxide as the catalyst. This in situ transesterification is need 5 hours at 100 RPM and also at 70 degrees Celsius. After finish this process, we then cooling the sample, decantation, evaporation, and also washing and drying to remove residue of the solvent. After we get the fatty acid methyl ester, we then analyze fatty acid methyl ester by GCFID, density analysis, acid number, saponification number, iodine, and also calculation of the yield of the biodiesel. This is the result and discussions. So we can see that for all microalgae, the time growth of the microalgae, Cyanococcus and also Chlamydomonas 9112, 9111 until 9114 with different technical uh, media here that by using sunlight was faster than basal media with lamp like a source of light. From this, then we get the dry of microalgae. For dry microalgae, we characterize of water content, ash content, fat content, free fatty acid, and also we calculate the yield. From this result, we can get that Chlamydomonas sp. 9114 is the best candidate for the next experiment because of yield of the Chlamydomonas sp. 9114 is highest compared the other microalgae. Then we also characterize the fatty acid composition of the microalgae. So we can see here that the Chlamydomonas sp. 9114 is the highest fatty acid methyl ester, and then we use this Chlamydomonas sp. 9114 for the production of biodiesel by in situ transesterification. So this is the result. We characterize the biodiesel from the Chlamydomonas sp. ICBB 9114 by in situ transesterification. We try to measure the yield total of PEM, density, acid number, saponification number, iodine number, cetana number, and also ester number. So we can see in this table that almost all of the parameter meet criteria of SNE biodiesel. Expect the acid number here. Yeah. So we also check the fatty acid fatty acid of Chlamydomonas, fatty acid of biodiesel from the Chlamydomonas ICBB 9114 by in situ transesterification. So we can see here that the percentage of fatty acid C16 is higher if we compare to the kind of other fatty acid. It means that the Chlamydomonas sp. ICBB 9114 is a good candidate as a raw material for biodiesel. This is the conclusion of our research that the Cyanococcus ICBB 9114 has the lowest level of lipid and also fatty acid methyl ester. And the Chlamydomonas ICBB 9114 has the highest lipid content and also fatty acid methyl ester. And biodiesel Chlamydomonas sp. ICBB 9114 processed by in situ transesterification has characteristics that are mostly meet criteria as any biodiesel. So this is the future perspective and that the integrated processing of biomass from microalgae, starting with the production of fatty acid methyl ester via in situ transesterification and then using the residual biomass for bioethanol production is one of the feasible approach. Protein-rich residual biomass from microalgae after biodiesel and bioethanol production can be used effectively for biogas production through appropriate pretreatment strategies. And if we use genetically and modified microalgae and also use open pond cultivation can produce higher biofuel yield and we have to also if we use the genetically modified microalgae, standard operating procedure and biosafety, also strict monitoring because this is can the uh, expose of environmental and health risk by engineering microalgae to the natural system. So this is my acknowledgement to my supervisor because this topic research is when I took the master PhD in IPB. So thank you. That's all for my presentation.
Okay, thank you very much, Dr. Padmawati, for your interesting presentation. So we will proceed with Q&A later. So please stay on with us, okay, until about 4 something, then we will have the forum session. So for the next presenter, I would like to invite Dr. Jasro Jamani. So if you may, you can share your presentation slide on the screen. So Dr. Jasro Jamani bin Jamian received the Bachelor of Engineering degree, Master of Engineering and PhD degree in Electrical Power from Universiti Teknologi Malaysia in 2008, 2010 and 2013 respectively. He is currently the Director for Power Engineering Division, School of Electrical Engineer, Universiti Teknologi Malaysia. And Dr. Jasro is actively involved in research as a principal investigator as well as leader in consultancy projects with several companies such as Petronas, TNB, Tenaga Nasional Berhad, okay, which focuses on relay coordination project and off-grid solar PV design. So he is an author and co-author of more than 80 publications in international journals and proceedings in the area of power system and energy. His research interest includes network reconfiguration, optimization technique, and renewable energy, right? So I will pass the floor to you, Dr. Jasro.
All right, thank you very much, Dr. Ho. Okay, Assalamualaikum warahmatullahi wabarakatuh, and good evening, everyone. First of all, I would like to thank to the organizer for inviting me to give some sharing knowledge regarding my research. So today I would like to share about the resilient control strategy in microgrid system with multiple renewable energy sources. Okay, let's begin with a little bit overview about the power system. Okay, maybe some of you who are familiar in power system, or maybe not, but let's try to get some overview about the importance of this research. Traditionally, okay, our power system actually consists of how we get our electricity. Actually, we get from the generator and goes to the distribution. Means we got a generator, transmission system, substation, and after that go to the distribution. And all our loads are connected to the distribution network, and the power is flow in only one direction, which is from the generator go to the load side. Roughly, that's the idea how power system works previously. But due to due to the increment of the load, okay, the demand is increasing and so on and so forth. So we can expect that every time if we have a new development in the country, automatically the demand of the electricity increase. So transmission system also have their own capability to transfer the energy. So in other words, you need to build up a new transmission line, transmission system in order to cater the new additional load. That's what happened in the previous network. But after that, last a decade, I think last 10 years or last 15 years, people have thought that why not we put our sources, okay, at the distribution network. Okay, by putting our resources at the distribution network, so we are not need to install a new transmission line, isn't it? We can just directly supply from our resources, directly supply to the network, to our load. From that idea, okay, they come up with a new term, what they call it as a microgrid. If you compare between this box versus this diagram, actually the substation is here. Here also we got the substation, which is distribution substation. However, the difference between the first box and second box, first box, we can see that there is no resources at all. Okay, there is no source power supply from this side, except whatever that coming from the generator. On the other hand, in the microgrid, what they try to do is we can put the generator near to the load. Okay, the generator can be placed really close to the load or beside of our load, big load, for example, or we can put at the feeder. Okay, we can put at the feeder in order to supply for this zone. So roughly that is the meaning of the microgrid. All right, so means that it's a very small grid that consists of the load, consists of resources, and these resources, this source, okay, this power supply will supply directly to our load without using a transmission system and so on and so forth. And currently, most of the researcher, okay, when they talk about the generator, when they talk about distributed generator, which is generator which are
Justin, we
located at
cannot
the
see your
distribution network.
screen. We cannot see your screen. We just,
Oh, yeah, okay, sorry. You cannot see my screen. Oh,
yeah, we can see the screen, but it is not moving.
It's
You're
currently
not
at the
sharing
first slide or second slide.
you're not
You
sharing
are
the
still in
presenting
the
slides.
introduction slide.
Oh, okay, sorry. Actually, I already go to the third slide. Okay, let me share again. I just want to confirm. All right. Can you see the slide is moving?
Yes, you can see it now.
All right. Okay. Thank you, Prof. All right. Okay. Roughly, actually, I'm talking about this box. Okay. Okay. Actually, I'm talking about this box. We are talking about this distribution network versus this microgrid system. Okay. So if you compare between these two boxes, previously our traditional network, whatever that we have from this particular box is come from the generator. It must come from the main generator, go to the transmission system, go to the substation, and after that go to our loads. On the other hand, for the microgrid system, actually the definition of the microgrid system, we have a generator itself at the distribution network. Either it is located close to our load directly, or we can put at the feeder, okay, substation feeder and so on and so forth, or downstream feeder in order to supply. So roughly that is the general idea of the microgrid system. And currently, when we talk about the distributed generator, which is generator which are located at the distribution network, people or most of the researcher, their interest is to put all this generator at the close to the load, and in the same time we are using a renewable energy. Okay, so such as we can use a biodiesel, we can use PV, we can use wind turbine, we can use our traditional diesel generator and so on and so forth. Because when they place all these distributed generator, okay, most of the idea that being used is to reduce the overall power loss. Because you can imagine that when we have all these resources at the distribution network, we will use less energy from the traditional generator. In other words, less energy will transfer from the generator through the transmission line before arrive at the distribution grid. Am I right? So in other words, the total power loss is reduced and the overall power system performance will increase. However, actually, and this what people normally talk about when they put the generator. They just focusing on, okay, we can reduce the power loss, and power loss. On the other hand, actually, we can use all this distributed generator when we to improve our system, especially when we have a natural hazard. For example, in Malaysia, if I took the example in Malaysia, we have a high potential of flood happen in Malaysia. Okay, that this is the natural hazard that happened in Malaysia. Okay, we got a high potential of the flood. We have a medium potential of the forest fire or landslides. We have a very low potential of the earthquake, tsunami, and so on and so forth. Okay, but if we still remember our previous case, okay, last year, we have a lot of flood in Malaysia, and many area they does not have any electricity, okay, because of the flood, and they need to shut down some of the substation, and automatically it will cause that particular area did not have any electricity. So this is what we should think about. If let's say we want to place the DG, okay, if we want to place the distributed generator, rather than you are focusing on power loss, okay, reducing the overall power loss, why not we think about the placement of the DG should consider the natural disaster, so that we can improve the resilience, okay, the resilience of the distribution network. Okay, I just took one example. If let's say this is our distribution network, the network that we are talking about, this one just now, okay, let's say assuming that this feeder consists of 33 distribution network. If we got the 33 distribution load, 33 bus, if let's say there's and we assuming that there is a flooding area occurred at the section 19, section 27, section 16, and section 12, we can see that a few islands will happen, okay, and all these islands will not getting any electricity because the incoming supply is only coming from the bus one. So this is the case if we does not have any DG. But if we have a DG, there is a possibility that the DG able to supply this island. All right, that's the first possible solution that we can use if we want to improve the resiliency of the network. The second technology that we can use, okay, is actually we can reconfigure back our network. Okay, what means by reconfigure? Means that rather than, for example, initially we can see here that line 1, bus 1 connected to bus 2, connected to bus 19, connected to bus 20, 21, and 22. And there is no line that connected between bus 22 to bus 12 because we need to make sure that our distribution network are in radial configuration. However, if we have the tie switch between these two buses, actually we can implement this kind of technology. We can reconfigure back our network so that we able to supply the whole loads. So roughly the idea here, for example, with the same condition, for the first initial condition, we have 1, 2, 3, 4 islands which are not does not get any supply. If we able to reconfigure our network, we can see that actually we able to supply 100% all the loads just by reconfigure back our network. So based on these two ideas, we can see that, for example, without any reconfiguration, the power supply, okay, supply load is only 66%. If we able to configure our network, we able to increase the percentage of the load between 80% to 85%. All right. So based on these two ideas, we are doing a research. Why not we place the DG? Okay, why not we place the DG as well as we reconfigure the network so that by the combining of these two, we can help to improve the resiliency of the network. All right. To do so, we come up with a three-step analysis. The first step, we do a forecasting, okay, based on the actual data, okay, Malaysia actual data, we do some forecasting. The potential, the high potential of the flooding area that can occur, as well as based on the statistic. Okay, we do some statistic analysis and we identify which area that have the highest potential of the flooding and can cause island and tripping. Okay, and after that, from all this data, okay, we can come up with the reconfigure. Okay, we try to get what is the best configuration based on the potential flooding area. And last but not least, we can place our distributed generator for that at that particular island so that we can improve the system resiliency. So we come up with the statistics. So the rate from the red to the blue, actually the red is the high potential of the natural disaster. The blue is the least potential natural disaster. And we consider all the power loss and so on and so forth, and we come up with a resiliency index formulation in order to evaluate the system performance. All right, so I just go a little bit quick. So roughly this is the potential. Okay, we come up with a 20 scenario with the 20 potential 20 potential tripping, okay, due to the natural disaster. And from this 20 potential tripping, we can see that, for example, for the first scenario, here is the potential island without any power supply. The others, even though there is a tripping, but after we reconfigure the network, they're still able to get the supply. However, for this particular case, this is the only island that does not have any supply. The second scenario, third, fourth, until to the 20 scenario. From this 20 scenario, we come up with a statistic to see actually at which scenario that at which place that we should put a DG. And as a conclusion, we can figure it out from the 20 scenario of the potential natural disaster. The PV or our distributed generator, in this particular case is I put a PV, should be placed at the bus 16, bus 18, and bus 28. By placing the PV at these three locations, automatically it will able to improve the resiliency of the system. It's not only improving the power loss of the overall network, it also can reduce the chances of the system from overall tripping. So as a conclusion here, we can see that, okay, if without reconfiguration, if we just place a DG, okay, for the sake to minimize the overall power loss, we can see that if the natural disaster happen, the percentage of the lost load is around, or the load that can be supplied is only 51%. So we can imagine that if we have one distribution network, okay, if we just put the DG without any reconfiguration technique, if natural disaster happen, we can assuming that 50% of the load will be missing. Okay, if we only do a reconfiguration without any, if we only do the reconfiguration, we can see that we're able to supply up to 94%. Okay, if we do reconfiguration with the DG together, actually we can secure nearly 99% of the network. So from this case, we can conclude that if we place the DG, okay, when we want to implement a DG, when we want to do a project, rather than we put a DG just for the sake to reduce the power loss of the overall system, why not we place the DG so that it can help the distribution network, especially when there is a natural disaster happen in that particular area. So, and of course, when we place the DG, okay, when we have a DG here, and if there is a natural disaster happen, similar like, for example, like scenario 18, there is a possibility that our PV unable or our distributed generator unable to cater the all loads. So, of course, we need to do some load shedding as well. So, for example, here you can see that the percentage of the load shedding need to be implemented after the reconfiguration in the system. All right. So as a conclusion, actually, if we are focusing on DG placement just for the sake to reduce the power loss, if there is a natural disaster happen in the distribution network, it will cause the system collapse. However, if we consider to use DG as well as reconfiguration technology in the distribution network, actually we can improve the resiliency of the distribution network, and in the same time it will improve the performance of the system. And our current research, actually we have a multiple resources. Okay, currently what we set up in our lab, we got several resources. For example, we have a PV, we have an ocean energy simulator, we have our traditional generator, as well as we have a battery and supercapacitor in this setup. And actually we plan to do some sort like a reconfiguration as well as DG placement and to investigate the capability to do a load shedding and to improve the overall distribution network. All right, so I think that's all from me. Thank you very much.
Okay, thank you very much, Dr. Jasro. A very insightful presentation. Killing two birds with one stone, I say. Right? Okay, so I'll move on with the next presenter, Associate Professor Dr. Muhammad Zaki Fahmi. So if you may, you can share your slide on the screen. Okay, so Dr. Muhammad Zaki, he's the Associate Professor from the Department of Chemistry from the University of Langga and is the Chairman of the Department of Chemistry and Supra Modification Nano Micro Engineering Research Group Leader. Okay, so in 2007, he obtained his bachelor from the 10 November Institute of Technology, Indonesia, and master degree from the same university in 2009, and in 2014 from the National Taiwan University of Science and Technology. Right. So his expert is in nanomaterials, nanomedicine, and nanofiber polymer. So over the years, he has published a lot of papers and is and other than papers, he has published several peer-reviewed books as well as joined several international conferences. Okay, so without further ado, I would like to invite Dr. Muhammad to present his case. Okay, thank you very much.
Okay, thank you very much, Dr. Ho. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good evening for everyone. First of all, thanks to the committee that give me opportunity to share my research, part of my research regarding in nanotopic application of material for bioefficient fuel. The topic as a nano modernity design for support of producing bioefficient fuel components. And this actually research of my colleague that it already passed away. I already mentioned in the end of this presentation. Yeah, to give further insight for bioefficient fuel, the like a common fuel, efficient fuel is important component for the transportation actually in the flight transportation, and then it can be a main energy source in efficient sector, and then this similar with another transportation, the occupy of the transportation will increase fuel, and also in efficient also the crew of the flight and also will contribute not only will contribute not only for fuel but also the bad impact of the current fuel use. We know that kerosene is the main component of the aviation fuel, and then this on the slide I show you that 1 hour flight with 150 passenger it contribute not only consume high kerosene but also give a bad effect relating to the emission of the pollution, not only for carbon dioxide but also some sulfuric oxide and also carbon oxide and many other toxic pollution. And then they can be a worry for us regarding for the next step that fuel can give bad contribute for the pollution. And regarding all this, people thinking that change to the biofuel, we know common as biodiesel for the another transportation. Biofuel is identified one of appropriate solution to achieve a significant emission reduction in 2015. And why it is important? Because people now thinking that to regularly share using the biofuel instead of the common fuel for aviation. And what is biofuel, and then how it compares with conventional fuel? Here I show the table comparison between fossil jet A from shell industry, that is a common kerosene using for aircraft, and then usually main component of kerosene consists of paraffin, natural paraffin, and also isoparaffin instead of naphthalene and other aromatic. And when we compare with the people already make effort to synthesize of bioaviation fuel, and then when we compare it, we see that comparing with the conventional fuel, the bioaviation fuel, they not producing aromatic compound in the fuel. So and maximum component is consists of the isoparaffin or paraffin. So we can compare this by many process for production of the aviation fuel, and then we can see that they no aromatic component. We know that this aromatic component give more bad effect in the emission and bad pollution because the carcinogenic compound that potentially can be promoted by aromatic compound. Then isoparaffin, olefin, and naphthalene is a big thing that we must concern if we want to claim our product is suitable for bioefficient fuel. Then many people, as I mentioned before, they try to change to biofuel and then emerge new way in synthesis process to synthesis bioefficient fuel with some feedstock and other biomass is very common. And then we can see here that many way to synthesize bioefficient fuel, but most of them is complicated. And then people thinking to using a catalyst to minimizing or simplify the synthesis process. And we see that all of this process supported by catalysts. So that is why development of catalysts on this process is quite important and then crucial to get the bioefficient fuel. On the other hand, nanotechnology is growing very fast, and then give my impact to main aspect, including textile, biomedicine, healthcare, food agriculture industry, electronic, environment, and also renewable energy. And this deeply touch to many aspects regarding to renewable energy. People also transfer technology from the nanotechnology to the catalyst. So yeah, it is a common known that reducing of size of material can give high surface area, and then it will be for the catalyst that have active site. Increasing active site will help to catalyst process, and then can make the catalyst efficient and effectively. And then regarding the catalyst, one of catalysts that mainly used is zeolite, and then the conventional zeolite we know from mine. One main of this zeolite is modernite. Modernite is used for the many reaction, cracking, alkylation, dimethylamine, because they have high thermal and acid stability. We know that the zeolite is synthesized with a high temperature, and then they performing Lewis instead of the processed acid side that help to the catalyst can work well. And then so far there is no report investigating ionic exchange effect and nano effect on the modernite for the catalyst of bioaviation, and also yeah, minimal information on using of the modernate to bioefficient fuel production. And then this study will improve on how effect of the metal impregnation and also nano modification of the modernate as a catalyst for the cracking process to producing bioefficient fuel. And we focus on three kind of the metal, such namely iron, copper, and chromium. Is a iron component exchange to the material, the modernate, and then we investigate how the effect of this ionic and then the size of the nanomodernate. In the experimental session, it is quite a simple way because we using commercial modernate in the market, and then we doing washing and then change to each modernate, and then we try to give metal ion by impregnation process, and continuing by polyming to get nanometal ion modernate. And then this quite simple because we try that this way can give a benefit for a huge aspect of bioefficient fuel. After the synthesis of nanomagnet, we try to assess sensitivity and activity of the catalyst on the citric acid is as a reactant for the bioefficient bioefficient product, and then we using 190 degrees Celsius for the process, and then the product we took, and then following by characterization on by SRP, SRF, FTIR, CM, GCMS, and particle size analyzer. And on the result, we see we comparing many kind of the ion impact with the modern and combination of these three ion metal and also nanomodernite. And then by SRF, we see that we can see here that increasing the new element regarding the impregnation ion, they increase. Even at here, we have some in the normal mode per naronate, we also having chromium inside this, but overall it is okay. Increasing of the ion is following by impregnation process in the specific ion. We continue to assess in the SRD. We see that comparing the pair modernate, H modernate, and ion impregnated modernate, all is have similar SRD pattern, and then in nano form, they also have a similar peak. Even at here, we can see have the noise is high, and then the intensity is getting low. We predict it's because of nano effect, because decreasing size will minimizing size crystal size of the material, and this will be decrease intensity in SRT. And then we continue with FTIR and PSA and acid side using FTIR pyridine. In FTIR, we getting reveal that they have additional of ion. It exists in the FTIR because they have vibration. In 787, and then we also assess the FTIR pyridine to access acid side in the process of the Lewis acid. We can see here that increasing impregnation it effect increasing process and Lewis acid side, and nano modification will increase process and Lewis higher than the bare modernate or normal hybrid modernate. We also using PSA to identify the particle size, particles distribution, and then we can get that the ball mill is quite effective to getting nano modernate. On the SEM of the normal impregnated ion impregnated modernate and nano modernate, you can see this morphology of the particle of the nanomodernate is getting lower in size diameter compared to the normal or without ball mill modification modernate. So we can see here that roughly a size diameter is around 200 to 100 nanometer. And then for selectivity, we can get we surprising from this data because the nano modernate we expect it can be giving good selectivity, but in the initial time for selectivity of bioaviation, it's giving good selectivity percentage, but by increasing time they not increase, but they getting low. And comparing with the nano modernate by iron, copper, and chromium, they can average, and but for iron modernate they can have maximum at the 2 hours with selectivity over than 80%. And selectivity of the paraffin or isoparaffin we can get here also similarly with previous selectivity. Selectivity of the acrylic for the nano is maximal in the initial time. In the 0.5 time they get the increasing, but they getting low after 1 hour, and then 3 hour is minimum. And then we predicted here that nano is performing highest active site, but they potential for the saturated condition is high. So that is why selectivity is getting low by additional time. And for the conversion, we can getting that nano is good in the initial, but this consistent with the next time. I mean, activity of this nano is quite good, and comparing with non-nano treatment modern need, we can see here that they can be active roughly in the after 2 hours, and then we try to select the component, and then we can get the aviation condition parameter here that claim that this product by modernate or nanothermal modernate is eligible to apply as a bioaviation fuel. As a conclusion, we see that steric acid cracking, we can use the modernate the combination with the metal, and then size is not quite impact, but they give a crucial or maximum value at initial time. It will be give choice to using this to minimize to get efficiency, because they without a long time we can get a high efficiency, and then the cracking reaction of this acid predominantly produce tritican, tetraticane, and pentaticane. That is kind of the paraffin, and then this claim that this process is eligible to use and then give a good bioaviation fuel. As an announcement, as I mentioned before, this actually research of my colleague, Dr. Abdullah, that passed away in 2020, and then this research already published in Indonesian Journal of Chemistry with this Dr. Abdullah in the first time, and then I help because I colleague and then co-author for this project, and so I become principal author, and I thank you very much to Ministry of Research, Technology, and Higher Education, and also Universitas Air for supporting this research. So far, this research also effect by our collaboration with some university in Asia, and also Indonesia, and also institution, and also all students that support me for this research. Maybe this all for me. Thank you very much.
Okay, thank you very much, Dr. Mohammad. All right, we will proceed with Q&A later. So we will move on to the final presentation. Okay, so for the final presentation, I would like to invite Dr. Nurina. Could you please share your slide on the screen?
Okay. Do you hear my voice, Doctor?
Yes, yes. Okay, let me give a brief introduction for you first. Okay.
Okay.
One moment. Well, the internet is
Sorry, I'm sorry.
slow. No,
Yeah,
I'm sorry. Okay. All right. Okay. So, Dr. Nurina Triani is a lecturer in the Environmental Engineering, Universitas Air, Surabaya, Indonesia. So she received her bachelor degree and PhD in environmental engineering with research field in drinking water treatment. So FTSP from Institute Teknologi in 2010 and 2015 respectively, right? So 10 November ITS Surabaya. So having research interest in water supply and sanitation since for about 10 years. So initially it was mostly dealing with water treatment technology, and then the interest for the last 3 years was dealing with system dynamic modeling in water treatment. So basically, she has been dealing with water technology since the last 10 years, and lately is more related to the wastewater treatment for sanitation and community empowerment. Okay, so thank you very much, Dr. Nurina. I would like to pass the floor to you to deliver your presentation. Thank you very much.
Okay, thank you very much, Doctor, for the very brief introduction. Let me present my my knowledge and my little research about waste to energy in Indonesia, case of Surabaya from waste to what. Doctor, do you see my screen?
Yes, yes, we can see your screen.
Okay, okay,
Thank
thank you.
you.
Okay, so I would like to start with Indonesia, as we know that Indonesia is neighbor with Malaysia, and Surabaya is somewhere here, close from Bali and close from Madura Island. And yeah, we have a very huge population, as the population is about 267 million approximately. And as I showed in the previous screen, that Indonesia have a lot of islands. So the number of the island is about more than 17,000 island, and it is consists of 34 province and 500, more than 500 counties and cities as well. And as I would like to present about the waste to what, from waste to energy, and it is coming from solid waste. So I would like to explain about the general solid waste in Indonesia. We have about more than 25 million ton solid waste per year, and poorly the what is it, the waste reduction is quite low. It is about 16% waste reduction. And yeah, actually our national government have commitment to change the waste to energy. And it is the commitment is showed in some policies. The first policies in 2017, it is about national strategic project, and then the second policies is about in 2018, it is about solid waste power plant development, and then the last policies in 2020, and it is about utilization of renewable energy for the provision of electricity. And yeah, to implement their commitment to implement the policies, so they need to accelerate the policies, and they choose 12 frequencies and series that are included in the program accelerate in solid waste power plant, as known as PLTSA in Indonesia, pembangkit listrik tenaga sampah. And as you see in the screen, that one of the cities is Surabaya, the cities when I stay at the moment. And so I would like to explain Surabaya city further. And yeah, Surabaya is in Java Island, and we have like four area, and Universitas Air here in east area, and our campus is in coastal area. And Surabaya have 326 kilometers square with 2.8 people here in Surabaya. And Surabaya have 31 district with 154 sub-district, and we have more than 1,000 RW. RW is Rukun Warga, is kind of like community like, and we have more than 9,000 RT is kind of Rukun Tetangga, is what is neighborhood like. And if we are talking about the solid waste facilities in Surabaya, they have 187 temporary disposal site, and from the TPS, the solid waste disposed to the landfill, the end of fate of the solid waste. And we have one landfill located in Benowo district, and it is actually closed for the northern cases. And I would like to explain about the existing condition of solid waste in Surabaya. Actually, Surabaya city dispose about 1,400 until 1,500 tons solid waste per day, and it is contained of 55% organic, and the rest of the solid waste is inorganic. And as you see, based on Andina 20 and 19, that Surabaya is the city with the highest solid waste produce in Indonesia. Therefore, the national government strong push Surabaya city to to reduce the solid waste production. And yeah, if we are talking about the solid waste management, I would like to divide into two methods. The first method is reduction from source, and yeah, this is what we call engagement. Um, Local government of Surabaya very encourage the community to reduce the solid waste. And the first engagement is waste bank, and then the second is composting house, and then the third is waste competition. Okay, so this is the first method of engagement. We have a waste bank, and yeah, I mean, like here in Surabaya, solids become money. So in 20 and 19, Surabaya has more than 300 waste bank, and the number increase every year. And the biggest waste bank in Surabaya has more than 700 customers, and the profit of the waste bank is up to 70 million rupiah per month. So we need to reduce not only unorganic waste that disposed to the waste bank, and to reduce the organic waste, we use the composting house here in Surabaya, and Surabaya has 26 composting house, which is 21 composting house is managed by a local government, and the other managed by communities. So the last method is competition, environmental competition, and this is the way government, the local government, to approach to increase the awareness of the people. What is it? To the awareness increase to manage their solid waste. The first competition is freedom from waste, and then the second competition is Surabaya Green and Clean. This competition is began in 2007, and it is end in 2070 as the program change become Surabaya Smart City competition. Yeah, with this competition, the communities is exciting to join the competition, so they 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 have self awareness to spirit the waste. Yeah, this is the breakthrough, one of the breakthrough from our local government. We need to pay a plastic bottle to ride the bus. Actually, the bus is for public transport, one of the public transport in Surabaya, and it is managed by Agency of Transportation in Surabaya. If we want to ride the bus, so we need to pay with the plastic bottle, and we can around the Surabaya a whole day. And then the second method is the final disposal site. Yeah, this is the end of fate of solid waste. I would like to introduce the place where the solid waste end. We have landfill. We have one landfill site, as I mentioned before in the previous slide. The landfill site in Penowo district, so we call it Penowo landfill site, and the area of Penowo landfill site is about 37.4 hectares, and this landfill site is already operated for more than 20 years. And actually, based on the standard, the landfill site is the period period operation of the landfill site is for 10 years. you know that in Surabaya is what is it, the the population is dense, and then it is another challenge to find land to land that far from the housing, far from the community, to make a landfill. So the local government need to find the breakthrough to treat the waste in the landfill site. So one of the breakthrough is we use the solid waste become the energy. They change the solid waste become the power plant, become the electricity. And yeah, this is the Penowas, what is it, several years ago. Even we can find cows inside the landfill site. We can find a lot of scavengers. They bring their children, and even we can find a small Starbucks, yeah, inside the disposal site. This is the Penowa in several years ago, but at the moment, when into 2012, the management of the Penowa changed from the local government to the private company. Uh, the name of the company is PT Sumber Organik, and it is kind of collaboration between local government with the private company. So Benoa is changed, yeah. It is already have PLTSA, and the old cell of the Benoa already covered by membrane and sand to trap the CH4. So we can utilize this kind of methane to energy. And yeah, I would like to present about the technology of waste to what. As I mentioned before, that we produce about 1,500 tons solid waste per day. So I think it's huge amount. And in our landfill site, and it is already operated more than 10 years. So the cell of the landfill divided into two condition. The first condition, the cell that still operating, and the second condition, the cell is already operated, so it not use anymore. The first is gasification process, is process to collect the gas and convert into the electricity, and the gas is coming from uh, the old Satuan, and then the landfill gas, and it is produced 2 megawatt electricity, and then the operating landfill, we use gasification to reduce the number of the solid waste, and we convert into the electricity, and the capacity is 9 megawatt. So the total of the electricity we have 11 megawatt. And yeah, this is the scheme of the Penawa wastepower plant. Actually, as I mentioned before, that there are two kind of process. The first is gasification. It is happen in the operating cell, and then the other method technology is use the landfill gas power plant. And yeah, this is the brief explanation about the technology for landfill gas. The gas that trap in the landfill site, and it will collected in the gas well, and then they converted in electricity. And this is the process that gas recovery well, and then from the gas collection pipeline, and then condenser separator, compressor, and then there are we can get the gas, and then the other is flow to the power generation system, and then the overflow is coming from in flaring system. So yeah, based on gasification in Penawal landfill site is able to reduce the waste up to 1,000 tons solid waste per day. But in other review research, it's find that incineration is able to reduce the waste as well. And yeah, the last is my conclusion. I would like to conclude that the presence of the thermal technology of PLTSA is not able to produce the electrical energy, but also able to reduce the number of the solid waste that disposed to the landfill. And this kind of technology, it can be solution to reduce the number of solid waste, especially that in the place or the series or the vacancy that produce more than 1 ton solid waste per day with a limited land for landfill, for example, in Surabaya. Okay, I think that is my presentation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much, Dr. Norina. So now we will proceed to the Q&A, or basically the forum session. So I would like to invite back the previous speakers, Dr. Jasro, Dr. Padmawati, and also Dr. Mochamat. So can you all come on the screen?
Okay.
All right. So yeah, actually our session is supposed to end at 5. So it's already 7 minutes past 5. So it won't be a very long forum. So I have to apologize for that. But basically I will ask a very general question to maybe each of the panel if there is no other question from the chat, I guess. Yeah. Okay. Yeah. So basically to the Dr. Padmawati first. You mentioned about biodiesel, but lately there's a lot of, talks about EV, electric vehicles. So how do you think that biodiesel will progress in the current situation where a lot of people actually is moving towards EV? Just your opinion. Yeah.
Okay, I think biodiesel still need we use from the transportation. By using the biodiesel, we can use for diesel fuel. So Indonesia also so many car use the diesel. So by using biodiesel, maybe we can more sustainable resource by we can use the source of biodiesel from biomass, and I think Indonesia is still need biodiesel for the replace the fossil fuel, because the reservoirs oil in Indonesia I think is still low. Yeah, something like that.
Yeah, I think it won't be soon that we can totally phase out totally phase out fuel. So I guess biodiesel will still play a prominent role, and it's important for sustainability. Yeah. All right. Okay. So for Dr. Jasro, right? Dr. Jasro, you mentioned about the restructuring of the grid in order to make it more resilient. And from your result, you have shown like you get up to 99%. But I'm just thinking of the factor of safety. Like when there is flood, right? If the grid is actually still operating, wouldn't it be dangerous in the electricity and everything?
Yeah, thanks, Dr. Ho. First, normally, if we refer back to our previous case study, why normally TMB cut off the electricity? Because substation got a problem flooding. So if substation is quite dangerous, so normally they will cut off. For the household, yes, if let's say the flood covered everything until to the dB, then it's dangerous. But if let's say we are talking about just a normal flood, which are not really high up to the house level, so actually it's not really dangerous. And we got the cases previously, they does not have any electricity for 24 hours, 48 hours, and they got problem to get help and so on and so forth. So we can consider about that factor as well in the analysis, in the future analysis, to see the possibility to to come up with another protection system that can cater the flooding issue and etc.
Yeah, I think that's especially true if, let's say, like, after a few hours, the water has subsided, then maybe they can operate back the grid. But because the TMB one was a centralized, so they still cannot. So
that's
that's
right.
why you say 48 hours, right?
Yeah.
Very interesting research. So, okay, thank you very much for that. Sorry for the quick for the quick answering and question. Yeah. For Dr. Mochamat, for aviation, right? Just want to know, like, for the aviation industry right now, how many companies have started, changing to biofuel, or they use it as a mix?
Yeah, thank you for the nice question. Yeah, similar with biodiesel for the vehicle and car, they not completely we cannot directly use totally 100% of biodiesel. It just mix with bioefficient is mixed, and then not over than 10% of kerosene. So they're similar because we also need to in kerosene still have some important component need to, because the machine is for the kerosene, and then if we change totally to the bio aviation fuel, maybe have some problem. That is why just make it in the little compound.
Okay. Yeah, I think that's a very good answer. Thank you very much, Dr. Mochamat.
Yeah.
Okay, for the last presenter, Dr. Nurina. Yeah, I saw that you show us a lot of different form of waste to wealth option, and the one that you're showing is basically to convert, and then you can reduce waste to landfill. But actually, I want to ask about the one you say you can ride the bus with the bottles. Right. So
Yes.
can I ride the bus
Yes.
without the bottle? Like, do I must?
Yes, of course, doctor. Because this is actually we can use the electronic money, but if we bring the bottle, we can ride the
Then
bus
you
the
don't need
whole
to pay
day.
at all. So you bring the bottle, you
No
don't
need
have
to
to pay at
pay.
all.
No need
Just
to pay
give them the
money.
bottle.
Just bring the plastic bottle.
Oh, that is very good. I'm just wondering, like, the presentation that you have shown, all the technology, do you have a good collaboration with the government? Like, do the government support, or this is purely like private company initiative?
Yes, it is, doctor, because you know that in 2012, when the government keep the management of the landfill to the private company, it changed a lot. Because however, the government need to pay the tipping fee. Tipping fee is kind of some money that need to pay if the government dispose all of the solid waste to the landfill site. And the tipping fee is not cheap because we need to pay about 170,000 rupiah per ton per day. Yeah, per ton per day. Yeah, so it's a huge money. It's huge amount of money.
Right. Okay. So yeah. So again, thank you very much to all our speakers, Dr. Pamawati, Dr. Jasro, Dr. Mochamat, and Dr. Nurina. That was a very nice presentation from you all. And also, this is our last session for I-Bes. And our session on energy security has been a very interesting one, where we have so many people talking about different form, from electricity, from the grid, from fuels, and also waste, and the biosurfactant and everything from the previous section. So it has been a very interesting one, and I believe energy is always, like to say, the most critical thing, because anything that we do now is energy. So if we can reduce that, we can actually solve a lot of issues related to global warming, related to sustainability, right? So with that, I would like to pass back to the organizer, Ms. Nohaliza, and also to proceed with the conclusion, the closing ceremony for I-Bes. Thank you very much.
Yeah, thank you all.
Thank you very much, Dr. Huaishin, for chairing this session. We have finally come to the end of the I-Bes 2022. Before I close these sessions, I would like to thank all the speakers and viewers in today's session for their valued attention. I hope you found this to be informative and useful session. Ladies and gentlemen, this 3-day symposium is an event intended to provide an exclusive platform between UTM and UNAIR researchers to showcase their findings and knowledge extension, as well as to foster effective communication and create shared values. To close the symposium, I would like to call upon Professor Dr. Retna Apsari, co-chair of I-Bes 2022, to present us with the closing speech and ceremony. Please welcome, Prof.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much. Let's praise to Allah. Finally, the entire series of IP seminar have been completely done for 3 days, 19 until 21 June 2022. This was an extraordinary activity as the gate for research and innovation between UNAIR and UTM. This activity also supports the achievement of SDG 17, namely the international relationship between UNAIR and UTM. Hopefully, the activity could be continuous developed through matching research among researchers from the two institutions so that research and publication collaboration will be achieved. It is expected that there will be research funding between UNAIR and UTM. I would like to deliver my gratitude to the Rector of UTM, Rector of UNAIR, the RECD Deputy for UNAIR and UTM, the Chairman of the committee and all of the committee from UNAIR and UTM, all the great speakers, wonderful speaker, moderator, MC for the wonderful and extraordinary cooperation. On behalf of the I-Bes committee, I would extend our deepest apologies for any mistakes. I hope that the I-Bes activity could continuously implement further. Sending greetings to all of you to stay in good health. Hopefully, the COVID-19 pandemic will soon to be endemic so that the collaboration will back to normal. Have a great day and thank you very much for all people in this evening. Thank you.
Thank you, Prof. Retna. Before we end it, I would like to invite all speakers and viewers to switch on the camera and use the I-Bes 2022 virtual background for the group photo session. So technical and cameraman of the day, please get ready. And please give your best smile on the camera. With a count 1, 2, 3, smile. Another take, 1, 2, 3, smile. Okay. On behalf of the Secretariat, we wish to see you again. Thank you and have a great day. Bye.